Everyone. So, in continuation to the second video of our tutorial, where we are covering the AWS tutorial, here I'll be talking about the scenario before the cloud and the scenario after the cloud. Correct. So, before the cloud scenario, what was there? So, it was all on-prem center, and here we were talking about the online shoppings apps and the startups. Correct. So, just suppose that you are about to start your own startup, and you have an idea, you have written down the code, and you have to deploy it somewhere. Correct. So for the deployment of your mobile application, deployment of your web application, or the any services what you have created, correct, you need some infrastructure where the servers, the memory, the cpu, and other required infrastructure, correct, the data centers, so where you can deploy your services, and you can store the data as well, the read kind of data, the write kind of, so whatever the transactions are happening, all those kind of data, you have to store it, correct. So for that, you had to go with all the infrastructure creation, and the not even the creation, you have to procure this that infrastructure, you have to purchase all those components from the market itself. And even if you just suppose that you have started your own business, and you see that there are 100 number of users which are coming to your market, correct, and all of a sudden on the weekday, or like for the 100 number of users, you have set up the infrastructure and everything is working very fine, correct. Then just on the Saturday and Sunday, you saw that people are free, or there is any festival or something kind of thing, and all of a sudden the number of traffics, the peak traffic increases on the holidays or the weekends, correct, there is a sale or something. So the number of users which are who are logging into your platform, that becomes 100 to 10,000. So there is a sudden spike, or even 100 to 1 lakh of users, correct. So it's a sudden spike in your traffic, and this sudden spike in your traffic cannot be handled by the infrastructure which were there before, correct. So now you have to manage the infrastructure, correct. You have to procure the few more infrastructure, you have to route the traffic there as well. So what are all the things will happen here? You will be procuring the infrastructure, you will go to the market. So there will be multiple team, there will be multiple people engaged in all these activity. You will go to the market, you will purchase that, you will come back to your office, you will set up all this infrastructure. So there will be a team, dedicated team to set up the infrastructure, there will be a dedicated team to purchase the infrastructure, there will be a dedicated team to decide how much infrastructure is required, so that what kind of infrastructure we need to purchase at the runtime. Then there will be a dedicated team who will manage the infrastructure which has been set up, correct, and the monitor. So there will be multiple teams engaged, and there is one more overhead here, that you have to plan everything in the future for the sudden increase in the load or for sudden decrease in the load, correct. You have to plan everything in the future. So what if you have gone from 10 cpu to 100 number of cpu you have purchased, correct, and that you are utilizing for sudden increase in the load. Then after 5 days, you see that now you have only 110 users. So those extra number of cpu what you had purchased from the market, that is of no use right now, correct. So even if you procure the infrastructure for the high load, for the peak load, but when the load is not peak, you don't have to use that, correct. So for at that particular time, there is a wastage of your infrastructure what you have procured, correct, the low infrastructure utilization is there. Then the challenges which are there, needs ahead of time planning. Then high cost of procuring an infrastructure, that's the one challenge. Second challenge, needs ahead of time planning. Third, low infrastructure utilization. For this, dedicated infra maintenance team as well, correct. So a startup who are like, if you are thinking, or if I'm thinking of starting my own business, and where I'm going with the one of the idea, I have just launched the services. So before launching my services, I have to procure all the infrastructure, I have to arrange that particular team to set up, correct. I might be expert in coding, but I might not be expert in setting up all the wires, all the CPU, all the memory related, those hard disk and all those things, correct. I might not be expert in that, so I will require those resources as well. This is the scenario which were there before, on the on prem side before the cloud. So just checking on all the challenges, some of the organization thought of that why don't we come up with a solution where we can implement the rental things, just like the flat or the any property kind of thing. You come, like if you are a working professional or if you are looking for a job, you are, just suppose that you are in Delhi NCR and you are moving to Bangalore or the Mumbai, correct? So you don't go there, you just don't purchase complete flat or the building, you just go there, you pay the rent for that particular flat, and you stay for 1 year or 2 year, depends on your requirement, and you just come back once your job has been changed from there as well, correct? So you just rent those things for a certain period of time. So the similar kind of thing the organizations thought of, that we should also we should also implement that kind of model where the infrastructure can be rented, correct? Then your different cloud providers comes into the picture: the AWS one, the leading one, the Microsoft Azure, the Oracle, the Salesforce, the Google Cloud, the Alibaba, the IBM Cloud. So all these vendors, the cloud providers, came into the picture where they created the multiple services. At the back end, these cloud providers were also using the actual infrastructure, correct? The all those data centers, all those hardwares, the CPU, the memory, the data, the other data centers, the wires and all those, correct? So these cloud providers are also using the same thing, but for you, like you, if you are the end user, for you, you will be utilizing the services which will be kind of virtual for you, correct? So just suppose that if I have to launch this server of 1 GB memory and 1 core of CPU, so that 1 GB core CPU and 1 GB of memory server will be launched somewhere on a physical machine, which will be having 100 GB or more than 100 GB of resources, correct? But I will be just getting 1 GB out of that, and I will be paying for that only. I don't have to go for 100 GB and all. So ultimately, these virtual or the cloud systems are also being launched on the actual physical machines only. But for you, it's pay as you go model, correct? Or you will be just using all these things virtually, and it will be based on demand, correct? So if you can see the first pointer, that is on demand resource provisioning. So when you require, you just click on few buttons, and infrastructure is ready for you to deploy your services. Then on demand delivery of IT resources over the internet with pay as you go pricing. That means if I'm using the servers just for 2 minutes, I'll be paying for only 2 minutes. I will not be paying for more than 2 minutes, correct? Initially, if you purchase one time, it's one time investment. You will have to keep that, correct? Or you can resell it. But here, the moment you use, the moment you pay, correct? You don't have to go for any other things. So these cloud providers came into the picture due to these challenges. Now moving forward, what are what are the advantages of this cloud? Like when it came to the picture, what are the advantages? So the first advantage is stop spending money on running data centers. Now you don't have to think about running your data center. So if you are not running the data center, you just save your cost, and that's a cost you can invest in your marketing and in any other sector to hire resources, the perfect engineers and other staffs, correct? Then go global in minutes, that's the second point. Go global in minutes, that means the cloud providers provide you the to launch the services into multiple regions, correct? So if you work with the AWS cloud, you will see that there are multiple regions available. Your AP South one, the Mumbai region, the London region, the Singapore, or the Ohio, the North Virginia. There are multiple London region. The multiple regions are available where you can launch your services, and you can be available globally within a minute, correct? So that's the second point. The third point is increase speed and agility. Like if your number of traffic increases, correct? You are going with 100 number of users, and all of a sudden your traffic increases from 100 to 10,000 number of users. Then cloud providers gives you the facility to increase the number of servers dynamically based on the number of based on the number of requests which are coming to your services, correct? So the moment traffic will start increasing, the moment at the same moment the server number of servers will start increasing, correct? So the traffic which are coming to one server will start getting distributed to another servers as well, and that will not down your performance, correct? Because the number of traffic is getting distributed, so ultimately the performance of the application, the performance of the services will be high. So that kind of speed increases the application performance, the application speed increases, correct? So that feature the cloud provides. Then stop guessing capacity. That's the 4 point. You don't have to think about the future. The moment you will require the number of the servers, the number of services, you can click on that. You can get it. So you don't have to think about the future, that what kind of infrastructure we will require, how many number of items I have to purchase, those kind of things. Then fifth point is benefit from massive economies of scale. So whatever the number of servers, the services you increase, the moment in the your utilization has been done, the you can scale down as well. So either you scale up or the scale down, you can save the cost in both way. If you scale, like if you require only 5 number of servers, you will just scale 5, you will be utilizing that, you will be paying that, and after that you can just scale down. So you will save the cost as well, because now you are not utilizing, so that will save your cost as well. Moving forward, what is AWS? Like basically we are talking about the AWS here only. So it's Amazon Web Services, leading cloud service provider in the market right now, and it has more than 200 plus services. So AWS provides the multiple services for your basic application deployment like BPC, EC2, RDS, SNS, SES, CloudWatch, IAM role policy. So the AWS has multiple services available, and it also provides you the services for the AI, ML. It also provides you the services for the IoT. It also provides services for the your ETL processes, so like where you can work with the data, you can train your data, correct? So for that thing, the AWS provides them multiple services. It's reliable, secure, and cost effective. And the model what the cloud adopts, that's pay only for what you use, pay as you go model. That is the actual term which is called here, correct? These are the kind of data centers in the Mumbai. So that you can see that these are the kind of components which are there. So this was all the picture before the cloud, or it's the running actual the data centers of the AWS as well. If you were before this cloud, even you will have to set up this kind of infrastructure if you get into the on-prem kind of thing, correct? So in this particular video, we'll be talking about this much only, and moving forward, we'll be talking more in the third video of our tutorial on the AWS, correct? So till the time, thank you. Bye. Hi everyone. So in today's video, we will be talking about the AWS, how to get started with the AWS. Till now, we have covered like why there was on-prem, like what were the challenges with the on-prem data centers, correct, and why cloud came into the picture. Now from here onwards, we will be talking about how to get started with the AWS and the AWS services, correct? So this is our day 3 of the AWS tutorials, where we are covering all the AWS services and the complete training on the AWS side, and from the scratch itself up to the end. So this is day 3, and let's start with the that. If you want to watch other videos about Terraform, about any other topics on the AWS, you can watch over the previous videos which are available on the channel, and that will be more helpful for you, correct? And if you want to go from the scratch, you can watch out the complete tutorial here what we are recording, correct? So let's start with the AWS account, and you will be creating your free account. So I'm going with the theory, and all the steps are covered here in the pictures, and you can go for that particular thing, like how to proceed, how to do the entry, and use your debit card, or use your credit card to create your free AWS account, correct? So let's started. So you will have to have one email ID, correct? And then of course, if you are doing the sign up, you will require a password as well. Then you will have to go with your contact details, like your home location, the complete address. Then you will have to add your billing information, that means your card details you will be adding, and few amount will be deducted. I think it's 1 rupee that will be deducted, and it will be returned back to you. That's your step 3. In the step 4, as you can see here on the screen itself, confirm your identity, verify PAN or DL or the mobile number, correct? So you can go with either your PAN card details, or you can go with your mobile numbers. And the fifth step is choose your support plan, correct? So of course you are creating the free account, so you will be going with the support plan only. So these are the five steps where you will be creating your free AWS account to do the learning purpose, or if you want to do any kind of POC or something on your own self. So on yourself, so you can create your free AWS account. I have attached few screenshots as well here with few of the details. So here you can see there are sign up page where this is the step one, where you will see the sign up page. You will put up your name, and then you will be creating your AWS account. So here after the mail and the AWS account name, you will be clicking on this verify email address. Then you will proceed for the second step. In the second step, you will have to pass the name, your phone number, then your address, and then you will move for the third step. Here you will be adding your details, viewing information, and after that you will be moving forward, and you will go for the fourth step. In the fourth step, sign up for AWS. You will be selecting your like the mobile phone number you will be putting it, and you will confirm your identity with that. In the fifth step, you will go with the support plan, like which kind of support plan you want either free one, or you want the developer support or the business support, depends on your use case. So if we are proceeding with your free AWS account, so you will be selecting the basic support, correct? And that's it. You are done with your free AWS account creation. You will receive the mail, and you will be you will be getting the access of that, the management access you will be having, because you are the one who is creating the AWS account. So you will have the all the privileges, correct? So you will be creating your IAM identity center, you will be creating different AWS accounts within that, and all the things you can handle that, correct? So that will be covering later on. So let's start with the AWS. Once you do have the AWS accounts, you will be logging into your AWS account, and you will start seeing the on the console. You will see the drop down for the option regions and the availability zones and other things. So before getting into AWS console, let's go with the theory first, and later on we will cover the practical one as well, correct? Because we are going from the scratch, so I'm going with the theory part first. So regions are nothing but physical geographical locations, correct? Like if you talk about the Mumbai, if you talk about the New York, if you talk about the London region, if you talk about the Sydney, Ohio, North Virginia, so these are the available regions in the AWS cloud side, correct? So the thing is, this AWS organization, the Amazon organization, it has created its own data center. It has developed its own data center into a different regions, and within one region it has developed the areas that you can call it as availability zone. So just suppose that these regions are just for one example, these regions are kind of one state. Within the one state there are multiple districts as well, correct? So one region can have the multiple availability zone as well. And like you can consider that just taking a political example, there is a government, central government in the Delhi, correct? That's the central government. These central government are associated with the different state government, and the state governments are ruling their things with the help within the different districts with the help of some administration, correct? So AWS is a kind of central government, states are a kind of region, and within this region there are some districts where the operations are happening. So whatever the policies or whatever the things are coming from the center, that will go up to the district. So whatever the services are being provided, that will go to the state, and from state to the district, correct? So in the similar way, whatever you deploy, that will be deployed to your AWS cloud, that will be in some region, that is in some state, and that particular service will be deployed in your different availability zones as well. So you will have to select the configurations for that as well, correct? You have to go for that availability zone, and few of the services will be in some of the availability zone, few of the services will not be part of that availability zone, just like the different policies. Few power can be to the state government, and few of the power can be only centralized to the state government, correct? So everything is distributed to the center, to the state, to the districts, correct? So in the similar way, in the technical terms, region has some capabilities. Every region has some capabilities. Few of the services might be disabled in the different region, and few of the services might be enabled in the different region. Then to make the services highly able, there are availability zone within these regions, correct? So you can see from the points, regions are physical geographical locations, 20 plus regions across the world where its data centers are located, determining the right region for your service, data, and applications, correct? because if you are in Mumbai region, if you are in India and you are nearby the Mumbai, you will be launching your services in the Mumbai region. So and your uh, end users are also part of Mumbai only, so for them it will be very low latency, the performance, the data transfer will be very fast, correct? But if you someone business user end users are in the Newark or the Ohio, correct? So for that you will have to launch like you can launch your services in the Ohio region, that will be much faster than any other region for those end users, correct? Then talking about these regions, I can see there are Oregon, Cloud, Spain, Paris, Ireland, London region, correct? So these are the kind of regions. Hyderabad, Singapore, and Sydney, and other regions are there. Then moving forward, basic terminology that is called AZ, and AZ means availability zones, correct? So as you can see, for the US East one, there are three availability zones: US East, US West 1A, US West 1B, and 1C. Similarly, for AP South 1A as well, and like for the Mumbai region, we call it as AP South 1, and there are three availability zones: AP South 1A, B, and C. So in one region there can be multiple availability zones as well, correct? So these availability zones are nothing but the three different centers, and the group of these three different centers are called as a region, correct? As we explained, that group of few of the districts will be called as a state, and this state will report to your central government, that means the AWS cloud itself. So availability zone is a single data center or a group of data centers with redundant power, networking, and connectivity within an AWS region. And why this is required? It's required to make your services highly available. By any chance your 1A, the first data center goes down, the second data center will start serving the traffic. So all these things, how it will behave, that depends on your configurations as well, correct? But yeah, these are the terminologies which we will be using moving forward. Now coming to the next slide, how your AWS billing will happen. The services that you use to pay your AWS bill monitor your usage and analyze and control your cost, correct? So with the help of AWS billing portal, you can control that how much cost you are paying for your EC2 instances, in which month how much cost has been created, correct? How much cost has been populated based on your use case. And as you know that AWS supports your pay as you go model, so with the help of that you will be just paying for that much of amount what you uses, correct? So there are you can even calculate with with the help of this AWS billing. If you want to predict something, you can go to the portal, you can do the calculation, like if you use this particular resource for this much duration, how what will be the cost, correct? And if you like even you can integrate your mail ID, correct? So whenever you can, like if you are using this free AWS account, you are a new learner and you are creating your free AWS account, and you want that whenever there is a charges more than $1, you should get an email, you should be notified, so that it does not go from $1 to $100 or some higher cost, correct? So you will be just paying that $1 and you will stop your services or whatever you have left running, correct? So you will be getting that mail as well, so you can integrate your mail with that in the AWS billing, that will give you the notifications, correct? So yeah, that was the thing, AWS billing. And then from here we'll here coming forwards, we'll be starting with your EC2 instance. So up to this we are done with the video, and thank you so much, and we'll be covering the day 4 on some another day. So till the time, thank you, bye everyone. So welcome to the channel, and today we'll be starting with our day 3 on the AWS EC2 side, and here we will be discussing about how you can start your DevOps career, and you can start learning your AWS cloud. And the first service in the AWS we will be covering on the EC2 instances, correct? So as you can see, the in corporate data centers, applications are deployed to the physical servers, correct? So as you know that we have already talked about the on-prem data center, like the company had to purchase their the CPU, the memory, the other compute engines, correct? So they had to purchase and procure all those infrastructure which were required. So earlier the applications were deployed to the physical servers, but when the AWS cloud come into the picture, or any of the cloud come into the picture, we go with the virtual servers, correct? So here we are talking about the AWS. So In the AWS, the virtual servers are called as EC2 instances, Elastic Compute Cloud. Correct? So that's our EC2 instance, which is virtual server where you deploy your applications in the cloud. Then with your virtual server EC2 instances, you can attach a storage on the network storage to your EC2 instances, manage network connectivity for an EC2 instance. That simple means that for this particular EC2 instance, the virtual server, correct, you can manage that which kind of traffic can come to the server and which kind of traffic can go outside the server. Just suppose that you have to install some of the software on your EC2 instance on your server, correct. You have to install Jenkins, you have to install Python, you have to install Git, correct. Any kind of software you have to install on your server. So for that you will have to define some rules that how your server will interact to the internet and how it will download the softwares from the internet to your virtual server, correct. So this kind of facility, this kind of feature can be configured with the help of security groups in the EC2 instances. So it will manage the network, and in the while you progress into the security groups, like you do the more configuration, you can also control the which kind of traffic can come to your server, correct. Like you want to deploy your database in the server which cannot be accessed directly by the internet, correct. So you want that kind of server. So for that you can create your private EC2 instances. When we say the private, you can deploy it without internet, correct. So that complexity we will learn later on, but here just understand that this server will not have any access the from the internet side, correct. So that means internet cannot access to your virtual server, while the virtual server, the EC2 instance, can access the internet. So that kind of facility and the configuration you can create in your EC2 instance, correct. So that's the your fourth point. It manage network connectivity for an EC2 instance, correct. Then your fifth point is load balancing and auto scaling for multiple EC2 instances. So just suppose that you have 10 EC2 instances, correct? And on these 10 EC2 instances, your 10 microservices are running. Just suppose that your 10 microservices are running over there. So how will you distribute all these microservices traffic to these 10 servers, correct? For that, there is an option of doing the load balancing. You can create a load balancer. You can attach that load balancer to these target groups. The EC2 instances groups will be called as target groups. So based on their paths, like based on the microservice A, microservice B, microservice C, you can route all this traffic to the different servers, and they can serve the your business need, correct. Even you can do the auto scaling as well. Like when we were talking about the on-prem, we talked much about that when we were dealing with the on-prem, we had the complexity of like future prediction, correct. You had to always predict that how much traffic will be there, according to that how much infra you will have to procure in advance, correct. So that kind of issue got resolved here, and you started on using the auto scaling, which can increase the number of servers based on the increasing number of requests, based on the increase on the CPU utilization. So that feature you can adopt here. Then the same payment model was there, pay for what you use. So the moment you use your EC2 servers, you will be paying for that. The moment you terminate this EC2 server, you will not be paying for that. And there are some EC2 instance classes, the types: general purpose, compute optimized, memory optimized, accelerated storage, correct. So these are the details about that, the type and the description, the method. So you can read more detail in this, like but let's go with the T family. So in the general purpose, we do have this T2 micro, T3 medium, and all those EC2 instances, correct. So you can see on this. And in this particular video, we are just making it a short to start with that, and the more details about this EC2 instances we'll be talking later on. So stay tuned for the next coming videos on the AWS tutorial. So till the time, thank you. Bye bye.
Hi everyone. So till now we have covered how to set up your free AWS account, and at the same time we have also covered that how you can start your cloud journey, correct? Like you can understand about that how the on-prem data center were working before and how cloud came into the picture, why cloud came into the picture, and what kind of challenges were there before, which on-prem was not able to solve, and your cloud came into the picture and it solved that particular problem, correct? Like it solved the problem of your auto scaling, it solved the problem your problem of load balancing as well, and it also solved the problem of like how you can auto scale, correct? Auto scale the number of servers, or scale down the number of servers. So it saved your cost, it saved your effort, it saved your future forecasting and everything, correct? So the cloud has the more features, and we have started that journey to learn about the cloud itself here. And particularly here we are talking about the AWS Cloud. And this is your day four, sorry, day five towards the DevOps journey and learning the AWS Cloud. So till now we have in the last video we have talked about the Amazon EC2 instances, where we have talked how EC2 instances can be utilized as a virtual server. And on this virtual server you can deploy your applications, you can use the property of load balancing, you can use the property of auto scaling as well, correct? And moving forward, we also talked about this. There are multiple type of EC2 instances, like there are general purpose, there are computer optimized, memory optimized, accelerated computing, storage optimized, and a few more. I think they are there. So talking about these particular EC2 instances, what are the features related with this? So general purpose, if you can see the description, it's good for a scale out workload supported by ARM. So it's a kind of architecture, that's the ARM architecture. And what is the type of this general purpose? It's a A1 T family. When we get into the T family, that is called as T2.micro, T3.medium, T4.large, T5.x large, correct? So as you go with the different type of EC2 instances in the general purpose category only, but you will be getting the different kind of CPU and memory and the network associated with these different type of EC2 instances, correct? Let's suppose that if you have T2.micro, so it will have 1 GB of memory and 1 core of CPU. If you proceed further, just for the example, if you go with the T4.x large, so you might be having 8 GB of memory RAM, correct, and 8 core of CPU. So that kind of configurational changes happens with your number of servers in with the type of server, correct. Then let's get into the depth, where we will be talking about the different EC2 instance types. And here, as you can see, the EC2 instance type, one is the general purpose. So what's the description of the general purpose and what's the usage of the general purpose, that we will see here. So the general purpose EC2 instances are great for a diversity of workloads, such as web servers or the code repository. Just suppose that you have a code repo on your GitHub or the GitLab, wherever, correct? And within that source code, you have written one application code which can be run on any of the virtual server. So what you will do, you will just do on you will launch a EC2 instance of the general purpose, that can be your T2.micro as well, because you are just doing the demo kind of thing. So for that, you will do the git clone, and your application source code will be there on the virtual server. Then you can run the commands, like if you have the Python or the Java. So based on that configuration, based on your technology, you can run the commands, and that application can be executed. You can install Docker, you can install Jenkins, any kind of software you can install on this virtual server, correct? So what does this general purpose EC2 instance does? It balance between the compute, memory, and networking. So it has the general purpose features, correct? It gives you the basic compute services, basic memory services, basic networking. So there is a balance between all these three, correct? We will be using T2.micro in our demos, so that will be sufficient for us. So we will be going with the T2.micro whenever we will be using this instances for the demo purpose. Moving further, the second EC2 instance type is compute optimized. So when we say the compute optimized, that means the computing power we have to check, correct? What kind of performance it can give this kind of servers. So it is great for compute intensive tasks that require high performance processor. And which kind of tasks can be processed with this kind of server? The media transcoding. Like if you have to do the real time streaming, if you have to do conversion of some files, like you are getting MP4, you have to convert it into movie extension, you have to convert it into MP4, correct? So that kind of media transcoding can be done over here. high performance web server. So if you want to deploy any e-commerce application for which you want, then there should be a very low latency to your application, correct? So for that kind of purpose, you can use this compute optimized EC2 instances. The EC2 instance type it starts with the C, just like the in the T2.micro. If you can see in the general purpose, it starts with the T, while the compute optimized with C family. Then memory optimized stands for the R family. R that means RAM, correct? C is for the compute, M is for the main, R is for RAM, X is for extreme. So every particular terms has some description, correct? So we talked about the compute optimized. Now moving forward, we will be also talking about the memory optimized. So what's the usage of memory optimized EC2 instances? It is used for fast performance for workloads that process large data sets in memory. So it can be used for your Redis kind of databases, correct? Where you have the distributed web scale cache store application performing real-time processing of big unstructured data, correct? So the kind of you can think of live streaming of election results, correct? That is the data which is coming, and you have to just reflect it over the system. You have to just go with the telling the news or speaking out the news over the media, correct? So for that real-time processing of the data, you can use this memory optimized EC2 instances, or you can use for the databases, non-relational database or relational databases. If you have to host your Postgres database, if you have to host your MySQL database or Oracle database, anyone for that, you can use the memory optimized EC2 instances, which will serve your purpose of high performance with those kind of data processing. The name of the memory optimized EC2 instances starts with the R. Then moving forward, the next. So we have the storage optimized EC2 instances as well. What is the use case of this particular EC2 instance? It is used for great for storage intensive tasks that require high sequential read and write access to large data sets on local storage. What's the use cases? High frequency online transaction processing system, relational and NoSQL database, cache for memory in RAID databases that can be your Redis where we store the caches. What is the Redis? If you are not aware of, Redis is an open source in-memory data store that can be used as a database, cache, or message broker. Message broker, when we say that means you can use this Kafka, you can use this RabbitMQ, and that kind of services can be used for queuing, correct? And there you can utilize this Redis as well. It's often used for caching web pages and reducing the load on servers, correct? So whatever the web pages are there, if you have made a request for a web page, so that will be stored as a cache. And next time if you make the request for the same, or any user make the request for the same web page, it will not go to the server, rather than going to the server and asking from there, it will get it back from the cache itself, from the Redis itself, so that the load on the server side will be a little bit less. So name starts with L. That's the mostly storage optimized. We can verify from here as well. Storage optimized. Sorry, I. I is for the IOPS, correct? So that's the term here. I stands for the IOPS. So storage optimization to instances names to start with the I, correct? Then moving forward, let's see few of the examples of EC2 instances. So one, one of the example is T2.micro. So T2.micro has one core of CPU, one GB of memory. Storage, it supports ABS, elastic block storage. Network performance, low to moderate, correct? It has the network, that kind of thing, low to moderate. Then the next EC2 instance is T2.x large. It has 4 core of CPU, 16 GB of memory, and it also supports ABS, but it has a little bit of good performance of the network, correct? So moderate kind of performance it does have. Then talking about the third instance, it's C5.x large. C5, that means compute optimized, correct? So these two are from the your general purpose instance type, and the third one is from the compute optimized. C5.x large have 4 core of CPU, 8 GB of memory, and storage is ABS only. That means it also supports your elastic block storage only. And the network performance, it's too high rather than the general purpose EC2 instances, correct? You can see up to 10 Gbps it has the network performance, and ABS bandwidth 4750. So it can do the transfer of the data up to 4750 bytes, correct? Now, if you want to check for the more details about the EC2 instances, you can go up to this particular URL, https ec2instances.info, and it will show you the proper details of all the EC2 instances, correct? You can compare the multiple EC2 instances according to their configuration, the CPU, memory, and the bandwidth. So it will just show you the list of those EC2 instances, correct? So that you can utilize. And instance class of example. So what do you understand from T2.micro, correct? So you have seen here that this is T2.micro instances. So what are these terminology? T2.micro. So what are these terminologies? So for that, you will be understanding over here. T stands for instance class. That means we talked about the general purpose. So T stands for that instance class. 2 stands for the generation. Like if you purchase your system, correct, the laptop itself. So you go with i5, i7. So those kind of generation, which generation it has, the Intel generations, correct. Here also for the instances, 2 stands for the generation. AWS improves them over the time. Micro stands for size within the instance class. So what kind of sizes are there, correct? So 8 GPU, sorry, 8 GB of memory or the 2 GB of memory. So all those kind of things are handled through the micro. Similarly, for the T3 medium, C5 X large, and so on. So all these things stores your kind of you can say the C stands for your class, the compute engine class, sorry, compute optimized classes. 5 will stands for the generation, it's of fifth generation, and your X large will stands for the sizes like it's a 1 GB core, sorry, 1 GB of memory, 1 core of CPU, or 8 GB of memory, and 8 core of CPU. So all those configurations, the details comes from this T2.micro, C5.x large. So these are all the details in the second day part 2 of the EC2 instances and the class day 5. And here we have talked about the EC2 instances in the details. In the furthermore, we'll be talking about the elastic block storage and we will move forward. So for this particular video, watching this video, watch this and thank you so much. Let's meet in the next video.
Hi everyone. So welcome to the day 6 of the AWS tutorial where we are learning about the DevOps journey and how to get started with the AWS Cloud itself. That's what we are learning over this particular platform and over this particular tutorial. So till now what we have covered how to set up your free AWS account, how to get started with the cloud, what were the challenges before the cloud and why cloud came into the picture. That's what we have covered till now. So in day 6 here we will be covering about elastic block storage, and then we will be further moving forward. We will be covering about your the different kinds of the block storage, and then what's the IP addresses, correct? The elastic private IP address, public IP address, and what's the difference between these two. Sorry, these three. So that we will be covering moving forward. So let's get started with the elastic block storage. So talking about the elastic block storage, it's a block storage service from AWS, correct? That means it is provided by the AWS itself, and with that can be attached to your any of the EC2 instances. That means to your any of the virtual server. And where can this be utilized? It can be utilized to store the data on your application on your server, which your application is writing, correct? So just suppose that you have deployed your one of the application on your virtual server. That means AWS EC2 instances, correct? And you are writing some of the data. You want to store that data, so you can use this elastic block storage that is also called as a volume. So this one can be attached to your AWS EC2 instance, which can be further more utilized to store the data. And if by any chance your the server which is running that goes down, so you can take the snapshot of this volume, and this volume can be now attached to a new server, and your application will be running fine with the same data, correct? So you can save your data in there will not be loss of any data. So now if you see the definition, uh, AWS EBS is a block storage service from AWS, that means AWS provided, that allow users to store and manage persistent block level storage volumes. This is also called EBS volumes, which can be used with Elastic Compute Cloud, that means EC2 instances. So this is EBS volume can be attached with your EC2 instances, which can be utilized to store the data. What are the features of this EBS? Storage volumes can be used like a local hard drive to store file or install application, correct? Just like the hard drive, you can attach this to your server and it can be utilized as a hard drive to store the data, correct? Store to install some of the softwares that will be persisted in your server. Then you can take the snapshot. Snapshots means backup. So point in time copies of EBS volume that can be used for disaster recovery, data migration, or backup compliance. When we say the disaster recovery, that means by any chance your server goes down, so this snapshot can be recovered to get your data, and the same data, the same volume can be created from this snapshot, and this snapshot of the this volume can be now attached to a new server, and with the help of that you can retrieve those data which has been retained to your server, correct? So it helps in that feature as well. Then encryption is the one of the feature, that means your data which is there will be secured, it will be encrypted. So data at rest is encrypted using AWS managed key or key created through Amazon KMS. So this is one of the more service provided by the AWS itself, which help you to create the encryption. So there is a two type of KMS key, actually key management service, that we call. Either you create on yourself, you define the policy and everything, like when we say the policy, that means the permission, which kind of permission you want to grant over this particular policy, correct? So either you can create, or there is a AWS managed policy KMS key as well that you can utilize, the default one. So that feature it supports. Then volume types. So EBS offers two volume types. Either you can use SSD or HDD. SSD, that means solid state drive or hard disk drive. SSD volumes are optimized for transactional workloads, like where the transactions are happening. You can say the payment application or any kind of transactions which are happening at the runtime, correct? And while HDD are optimized for your large streaming workloads. When we say the large streaming workloads, from the words itself you can understand that when we say the streaming, it's kind of media streaming, the your video streaming, so live video playing, correct? Or your live streaming, that your real gaming application, that will be your streaming one, correct? So HDD volume types will be used for large streaming kind of application, or the large streaming kind of services. Then moving forward, it is of two types, as we talked earlier as well. So type of EBS volume is general purpose SSD, that is of GP3, GP2 processor, and then provisioned IOPS SSD, correct? So you can learn more about these two. So it's a block storage service from AWS that allow users to store and manage persistent block level storage. So that the same definition what we talked in the previous slide. Then moving forward, what's the EBS bandwidth? So EBS bandwidth is the amount of data that can be transferred between EC2 and the EBS. So you have a server that is called your Amazon EC2. You have an elastic block storage, a volume where the data can be stored. How much data can be transferred from this server to the block storage, correct? So that bandwidth will be called as your EBS bandwidth. So EBS optimized instances deliver dedicated throughput between EC2 and the EBS with options between 500 to 80,000 megabytes per second. So that's our EBS bandwidth, you can say 500 to 80,000 megabytes per second. Then moving forward to the next slide, EC2 IP addresses. So whenever we launch a server, the AWS EC2 machine, we will do the demo as well while we will start with the demo. Right now we are going with the theory, so that you understand the theory first, and then we will start the demo where we will be covering all these topics with the practical session. So in this EC2 IP address slide, public IP addresses are internet addressable. So whenever you launch your server, there will be some public IP address assigned to that. Based on that, you will have to configure that whether you want public IP address or not. So a public IP address will be assigned to the EC2 machine, that will be used to connect your server with the EC2 to the internet, correct? Your server will be connected to the internet, and it can fetch any kind of the data, or it can install some of the software directly from the internet. So if you want your server to communicate with the internet, you will be configuring your server as a public IP with having a public IP address, correct? Then private IP addresses are internal to a corporate network. So if you are going to launch your server, that for that you want that this particular server should be private to my organization only. It should not be fetched from somewhere else. So the services which I am deploying as a part of my application, that application should only fetch the server, this server. So for that you can deploy your EC2 instance, the server, with the private IP address. You cannot have two resources with same public IP address. So definitely public IP address is a kind of unique and it can be associated with only one server. So you will not be having the same public IP address for those for multiple servers, correct? Every server will have their unique IP address. However, two different corporate networks can have resource with the same private IP address. Yes, that can be done. Your two resources can have the same IP address, but it will not be having the same public IP address for two resources. Then next point is all EC2 instances are assigned private IP address. That's also true. So whenever you will be launching one server, your virtual server or the AWS EC2 machine, whatever we say, that will be having one private IP address for sure, correct? Even if you launch the public with the public subnet in the public subnet, that will be having the internet access. It will have one private IP address as well. So that it will be like connected with the help of your private IP address as well. And if you want to make it connect with your public IP address, you can connect with that as well. So remember, when you stop an EC2 instance, public IP address is lost. Yes, that's also true. Whenever you launch a public server and if you stop that in between, like you want to use it furthermore after some time, so you just stop that EC2 instance. So your public IP address will be lost while private IP address will be there. It will not be lost. But there is a trick. If you want to keep the same public IP address, you can use the elastic IP address concept that we have covered in the next slide. So it's a static public IPv4 address provided by AWS. This static public IPv4 address can be associated with your any of the instance. Now, if you either stop or start, the public IP address for that particular server will be same. It will not be changed. What's the usage of EIP? The same usage what I'm talking about. It can be used to associate with an instance or network interface in a virtual private cloud. Virtual private cloud, that means VPC we are talking about. So this elastic IP address can be assigned to a server, and this that particular server will be having consistent and the same IP address throughout its life cycle. Either you stop, start, restart, anything, correct? The IP address will remain the same till the time you terminate. If you terminate, the server will itself go away, correct? And your IP address will be released. It can be used to enable communication with the internet for instances that don't have a public IP address, correct? So if your server does not have a public IP address, you can associate one EIP with that and you can establish the communication with the internet, correct? There is hourly charges associated with EIP that are not associated with running instances or associated with the stop instances. Yes, that's true. EIP comes with a charges. So you should be careful when using the EIP, Elastic IP, correct? Because it does have the charges, AWS charges for the EIP. That means once one public IP address has been assigned to you, correct? So you have taken one resource from the AWS side, so it will be chargeable whether you use it or you don't use it, correct? If you have reserved that for yourself, it will be charged. So be careful when you are using, you just use it, and if you are not using it furthermore, you just release that EIP so that it will be assigned to someone else. So it's chargeable. A public IP address associated with an instance is not a static case and is lost when the instance is stopped. That's something what we talked here. When you stop a to instance, public IP address is lost. So that will be lost. And if you want to keep the public IP address remain the same, EIP address is a static public IP address associated with your AWS account. So you can attach your EIP with that particular server, which will remain the same for moving forward. What is the furthermore property? Constant public IP address for EC2 instance. That's the property of EIP. Elastic IP can be switched to another EC2 instance within the same region. If you have created one EIP, it can be attached to one EC2 instance or another EC2 instance. You can switch this IP address to any of the server where you will attach. That server will be having permanent IP address which is assigned to EIP, correct? You have to manually detach it, correct? And yes, the major point which you should always remember, charged for an elastic IP when you are not using it. So whether you are using it or not using it, if it is assigned to your cloud, if it is assigned to your AWS account, it will be charged. So make sure that you explicitly release an elastic IP when you are not using it, correct? So you should focus on this as well. Then the difference between these three features: communication, private, public, and elastic. Private IP address communicate within the VPC, while public can communicate over the internet. The elastic one can communicate over the internet as well. It's similar to your public one, correct? Then address ranges for the private gets IP address from the subnet range. Public IP gets IP address from Amazon pool within the region. So for every IP address location, there is a AWS pool, Amazon pool. So it will come from there. Elastic gets IP address from Amazon pool within the region, similar to your public, correct? Instance we stop behavior on the stop and start. Private once assigned cannot be changed. It will be remaining. It will remain the same whether you stop the server, you start the server, or restart the server. Public IP address changes over stop and start. Once you restart the server, public IP address will change. Elastic IP address, it will not change. Do not change over instance stop and start. Then releasing IP released when instance is terminated. If you delete that particular server, private IP address will be lost. It will be released. Public IP address released to pool when instance is stopped or terminated. So it will go back to the AWS pool. While the elastic IP address not released remains in your account itself. Till the time you do not delete this elastic IP address, if there it is left, you will be charged for that. So you should focus on this every time. Automatic assignment receives private IP on launch of your EC2 instance. So whenever you will be launching one EC2 instance, you will receive one private IP address associated with your server. Public IP receives public IP on launch of EC2 instance if public IP addressing attribute is set to true. So you have to set this attribute enable disable, so that you will have to set while launching this particular server. So then you will be getting the public IP address. This automatic assignment for the elastic have to explicitly allocate and attach EIP. So you will have to separately create EIP, elastic IP address, then separately one EC2 instance, and now you will have to establish the communication between these two. That means you will have to explicitly attach this elastic IP address with your server, correct? Examples: application server database for the private one, where application servers and the database, your private IP address can be used for that. Like if you want to secure your database, so you will be launching that in private server with the private IP. Public one, web servers, load balancer, you can utilize this where you want to distribute the load, you want to run application which can be accessed with your public IP address. For that you can use assign public IP. Elastic one, web servers and the load balancer, similar to the public one because it can also communicate with the internet, the similar thing. So and this is all for this particular video. We will be talking more in the day 7, like the tomorrow video. And if you do have any questions about this EC2 instances, you can ask me in the comment section, and I'll try to answer that. Now further moving forward, we will be talking about the user data and all those things. So for this video, that's it. So let's meet in the tomorrow video. Till the time, thank you. Hi everyone, so welcome to the day 7 of your AWS tutorial, where we are learning about the DevOps journey, and particularly we are learning about how to get started with your AWS journey. And the first AWS service what we are covering is AWS EC2 instances. That means your virtual server, correct? And till now, up to the day 6, we have covered that how to get started with the cloud, what were the challenges before the cloud, and why cloud came into the picture. And till now, we have also discussed about the EC2 instances, the different types of the EC2 instances, what are the different kind of IP addresses, public IP address, private IP address, and elastic IP address as well, correct? That which can give you the permanent IP address for your server to connect with your internet. correct? So and ABS also we have talked. If you have not watched this video and you have come for the first time, you can watch out this video, earlier one up to the day 6, and you can come here and you can get started from this day 7, correct? So particularly in this video we will be doing the demo on the EC2 instances, and we will be covering the topics what we have talked theoretically till now. So here I'll be talking about the user data example. Like when we say the user data, so just think of the thing, just think of a use case. Like you have launched a server, correct, and you want that you want to install Python on that particular server, or you want to install the Git on that, you want to install Jenkins on that. You install the software, install that particular software on your server, you completed your work, and after that you terminated the EC2 instance. Once again tomorrow you require the same software, so again you will be running the same command of the server, you will install the softwares on that particular server. So rather than doing the manual installation every time whenever you launch the server, now if you want to automate this, that whenever my server will be running it up, all the prerequisites should be done before the server comes up, correct? So if you want to that kind of feature, you can use this EC2 user data, where you will be writing some of the script, and these scripts will be executed while your server will be coming up at the same time, correct? So your server will come up with all this software installed on that particular server, correct? So let's directly jump to the demo now, and we will see how this can be useful for you. So let me go here, and here I will be creating one EC2 instance, launch instance. So if I create one EC2 instance called as demo, correct? So let's start with saying that how you can launch your first EC2 instance. That then we will see how to use the user data, correct? So let's start with your EC2 creation first. So I'm giving like for that you will have to search EC2 instance here. If you are new to the AWS console altogether, so you will have to search the EC2. You will see all these options, EC2 dashboard. You can click on the dashboard section. You will see the number of instances running, the dedicated host, key pair, security groups, and all those details you will see here. Then you can click on the launch instance. You will be able to see all these configurational details, correct? So I'm just passing the name demo for my EC2 instance. Then you have to select application and OS images, which kind of OS image you want, correct? So I want to launch Linux server, so I'll be selecting here Linux server. What does this define? If you can see the description, Amazon Linux 2023 is a modern generic purpose Linux based OS that comes with 5 years of long-term support. It's optimized for AWS and designed to provide a secure, stable, and high performance execution environment. So if you want to launch your Mac OS software, you can launch that OS, Ubuntu, Windows, or Red Hat, any kind of, correct? So I'm going with the Amazon Linux, and here you have to select instance type. So if you remember from the slides when we were talking about the different types of the instances: T2.micro, T3 medium, C5.x large, correct? Memory optimized, compute optimized, your EBS optimized, that kind of things we were talking about. So here T2.micro is free tier eligible, and here you can see we are launching in the Asia Pacific, that means in Mumbai region. The code for this Mumbai region is AP South 1, correct? That you can see, and even if you click over here, you will see the multiple regions are available. So we are launching our EC2 instance in Mumbai region as of now, correct? So here you will be selecting T2.micro, that is free tier eligible, and then you have to create one key pair. Why the key pair is required? Key pair is required to secure your server, correct? Whenever you will require to log into this server from somewhere else other than this AWS console. If you have to log in this server from somewhere else, you will be using this key pair to authenticate. So whenever you launch this server, one key pair will be created, one private key will be associated with your EC2 machine, and public key will be downloaded to your local system, correct? Then whenever you will be doing the SSH is a way of connecting your making a secure connection with your server, correct? So whenever you will be doing, it will be authenticated that the server the key which is at your system and the IP address to which you want to connect, whether these two are matched or not. If it does not match, you will not be able to make the communication between the servers, correct? So for that you need to create a key pair. So it's a just you can consider the example lock and key. So if you have the right key, then only you can open the lock, otherwise you won't be able. So key pair will work in the similar way for your server, whether you want will be able to log in or not. So that it and this will define. So I'm creating one key pair here. So I will have to sign in again. I think it was not signed in. So let me sign in here. Nation910@gmail.com. Then I will have to pass the MFA key which is on my system. I think it got signed out in between. So yes, I need to pass. And yes, we are logged in once again. Let me give the details once again here. Demo. Then I will be selecting this Amazon Linux. Then t2.micro key pair I had to create. So I'm just giving the demo. That's the name. Here there are two types of some. Either you create PAM key or PPK. So we will be using the PAM key because I have to go with the open SSH. We will be doing the SSH kind of thing, correct? So I'm going with the PAM key. Let's create on the key pair. Key pair has been created and one has been downloaded as well. Then get into the network settings. So by default we have not created any VPC as of now, correct? So I'm going with the default VPC which comes as of when we create your AWS account. You will see one of the VPC will be created. That will be your by default. So for that you can search VPC in the search bar here and you can click on that. You will see there will be one VPC that will come as a by default here, correct? So yes, you will see one VPC that is by default. So this VPC we have selected, and within this VPC we will be launching into one subnet as well. So this is the availability zone. So every region, if you remember in the while we were talking theoretically, every region has some of the availability zones. So if you see AP South 1, this particular region has three availability zone: AP South 1A, AP South 1B, and AP South 1C. In these three subnets, you can these three availability zone has one subnet in each availability zone, and all these subnets have different CIDR as well. If you can see 172.31.32/0, then 31/.16, then 31.00. So this is the division of the IP addresses within this particular VPC, correct? So in three parts. So that is your subnet. We will be talking more in the VPC and the subnet part later on. So as of now, the networking part we are selecting the VPC, then the subnet, and auto assign public IP. This one is useful for giving the public IP address to your EC2 machine, correct? So if you remember when we were talking about this public IP, private address, private IP, and the elastic IP, correct? So whenever you have to communicate with the internet, you will require the public IP. So I will be selecting this public IP. Yes, auto assign of public IP enable, correct? If you don't, if you want to make your server as a private, you can disable it. But now we are trying to make it as public EC2 instance. So I'll be selecting as enable. Create security group. Here you can give the name of your security group. So I'm just giving as name demo SG, and then whatever the description you want to give, you can pass. So I'm just calling it as demo SG, and whatever the rules you want to define. So we will be doing the SSH. So SSH type we will be selecting. SSH only works on port 22. So port 22 is by default selected, and that's the rule. So I'm just going with the all these configurations to create my EC2 instance, the first EC2 instance, correct? So just move ahead and click on launch instance. Your instance is launched, and very soon it will be running. So it will take few seconds to come from your pending state to running state, correct? So let's wait for a few seconds, and after that we will connect this EC2 instance. So meanwhile you can see for this EC2 instance demo, one public IP address has been allocated to this server, one private IP address has been allocated. There is a public IPv4 DNS as well, and these are the configuration what we have passed: auto assigned IP address, VPC ID, then which AMI it has used, the Linux AMI we selected, correct? So that is there. And what's the security group we have attached? So the security group what we had created, demo SG, that has been there. Networking, so what's the subnet ID, in which subnet ID we have created, and in which subnet availability zone it has been created. So we had selected the subnet ID, and this subnet ID was the part of IP South 1A. So in that availability zone, my demo EC2 instance has been launched. Let's refresh and you will see it is running. Let's click on the connect section. there are multiple options to connect your server. Connect using EC2 instance connect. There is a public IPv4 address. You just click on the connect and it will be connected. There is an option to connect your machine with the SSH as well. So this is the command SSH-I, and the key pair what we had created at the runtime demo.pam, that will be utilized. EC2-user and then public DNS, correct? Public DNS for your server. When we say the public DNS, you will see I'm talking about this public DNS, this one EC2 13127, correct? So you can see that command is there, 13127. So either you can use the public DNS or you can use the public IP address with this one to connect your server. That can be done from your local. Now, right now I'm not going with to connect with the local, that we will cover later on. So right now I will just clicking on the connect, and when I click on the connect, it will connect me to the to the EC2 instance what we have launched, correct? And here I can run any kind of command, any kind of execution, the command execution I want to do, that I can perform here, correct? So if you see, I'll be running sudo su. Why I am running the sudo su? To make this connection, uh, like to connect this particular EC2 instance with the root user, sudo su, correct? Then if you do ll, you'd see there is a no file. If you want to create any file, you can call it touch abc.txt. That's your Linux command. You do the ll, you will see abc.txt is created. If you want to install any package or any software, you can install here. So if you do yum update -y, what this command will do, this command will update the package manager. Yum update -y. So it's taking time, and in a few seconds it should update your package manager. So yeah, nothing to do, completed. Then if you have to install something, correct? So let's say yum install git. So before git installation, let me show you that right now there is no git installed. Git -n version, git command not found. Now if I do the yum install git -y for auto approval. So now it has started installing the git. It will take few seconds only and git is installed. Now if you do the git version, you will see git is installed over this. Now you can run any git command over here. So if I type the git, you will see you can run the git commands. These are the commands which are available to run. So this is how you can launch your first EC2 instance, and you can install the softwares manually. So we just wanted to make it short video. The user data example we will be covering later on. This one what we want to cover, like how can you run the user data, how can you utilize this. So in the next day 8 video we will be covering this. So till the time, thank you, bye bye. Welcome to the day 8 of the AWS tutorial, where we are learning about the DevOps journey, and we are going through the AWS Cloud, where we have started learning about the AWS EC2, and till now up to the day 7 we have studied about why cloud came into the picture, what were the challenges before the cloud, and how EC2 helps you to run your applications, correct? So we have theoretically talked about the EC2, the different classes of the EC2 instances, what are the public IP addresses, what are the private IP address, what is the EIP, elastic IP address. We have talked about all these things, correct? And in today's video we will be talking about the EC2 user data, and we will be covering the demo as well in this particular video. So this is what you will be learning particularly in this video. So what is the use case of the user data? Let's understand from that first, and then we will move to the demo part. So just suppose that you have launched your first EC2 instance, correct? And on that you have you require to run your Python application. So you will be installing Python on that particular server, you will be running your application, and you also want to create your pipelines. So you install Jenkins as well on that particular server, you created your pipelines, your work is done, and you terminated that EC2 instance that time, because you can't keep your EC2 instances running or even in the stopped state for a long time, because there will be a cost associated with this elastic IP address or for the storage what you will be keeping, correct? So you will terminate the EC2 instance to save your cost. So once again, if you have to do the same thing tomorrow, you have to run your Python application again, you will be launching your server, you will be installing the Python software, you will be installing your Jenkins, and you will be creating pipelines. So all the steps you have to replicate every day, correct? So to overcome this particular challenge, to give the solution for this, there is a user data. So while launching your EC2 machine, you can pass the script, whatever the software installation or whatever the regular steps you have to do. All those kind of things you can pass in the script, and it will be performed before your EC2 instance comes up. Correct. So when your server will come up, when your EC2 instance will come up, it will come up with all these prerequisites done. So that will save your time, and you can create an image out of that, and you can reutilize it. Or even if you are launching EC2 instances on the daily basis, your EC2 instance will come up with all those requirements. So manual execution of the commands and waiting for that particular time period, it will be saved from you for you. Correct. So that time duration particularly you can save. So let's move to the demo part now. So let's move to the demo part here on the EC2 side, and here we will be launching one EC2 instance, and we will see how this can help you to reduce your time to do the manual execution. Correct. So let me launch one EC2 instance called as demo. Then the networking and the sorry the OS side, we will be selecting Amazon Linux as usual what we do, and here we'll be selecting Amazon Linux to 2023 AMI, that is free tier eligible actually. And then instance type, we will be selecting T2.micro as usual. And on this T2.micro, you can see there is a one core of CPU, there is 1 GB of memory. That will be completely enough for us to utilize it. Correct. And then moving forward, we will be selecting the key pair. So key pair, I will be selecting the one what we have created earlier. So I'll be using the public key pair. Correct, that I have given the name. You can, if you don't want, sorry, if you don't know how to create public key pair, you can just click on this. You will just give a name, and you will click on the create key pair. That will be created, and it will come here. I just selected, or from the drop down you can select the existing one. Correct. So that you can utilize. Then in the network settings, you have to pass the networking configuration. So you'll be passing your VPC. Right now I'm selecting the default one. If you have created any other VPC, that you can select, and then you can pass the subnet details. So I'm selecting AP South 1A. What are the subnets? What is the VPC? That we'll be talking later on. So here we more focused towards user data. Then auto assign public IP enable, because I will require this public IP address to access our EC2 instances or to communicate with the internet. Whenever we will install software, we will require the public IP address to connect with the internet. Correct. So let's create one security group as well here. So I will give the name as demo SG, the same name what I had given before. So let me select this one as description. So whatever the description, if you want to pass that description, you give. And security group rules. So I'll be doing the SSH to this EC2 machine, and even though I'm not going to use this SSH rules, but yeah, we are creating one inbound security group rules that you can create SSH port 22. If you want to add any other rules, you can choose the protocol here, TCP or HTTP protocol, or you can enable all traffic as well here, all traffic, or the HTTP or the HTTPS protocol, and the port you can mention here 80 80 80, whatever the port you want to allow to come to your server. Then now the main focus, where the focus is of this particular video, so that we are covering on the user data. So here I'll be just copying the script what I have on the PPT side, and that we will utilize here. So let me copy this particular script. Let's move to the EC2 instance and just paste here. So I'll be just removing this last line. Correct. So bean bash sudo su sudo yum update sudo yum install docker sudo systemctl start docker enable docker and check the status of docker. And after that, if you want to do, I will install as well sudo yum install git -y. So it will install git as well. If you want to install Python, you can install Python as well, sudo yum install python -y. So what this user data will do, whenever my EC2 instance will come up, it will come up with docker installed, docker running. Correct. It will start and enable docker. Then it will install git, and it will install python as well. So my EC2 instance will come up with all these three software installed: the docker, the git, and the python. Correct. Because you can see in the earlier videos in the day 7, we talked that if you do the git on just launch a EC2 instance and you run the git command, it will not identify that. It says that unknown commands. Correct. That means the server is not the software is not installed on that particular server. So now let's launch this EC2 instance and we will verify whether these three software has been installed or not. So let's click on the launch instance. Let's wait for a few more details. Okay, TCP, I will have to remove this security group rule because I don't want to add this right now. Let me remove. Let's click on the launch. The security group demo already exists for VPC. Edit instance config. Okay, so let me just remove this security group or select this demo SG if it is there before, correct, and all the details same. So let's go there, click on the launch instance. EC2 instance has been launched, it's running. Let's connect this, and from here EC2 instance connect with the help of public IP address and the connect button on the console. If you want to do the SSH, you can use this command from your local. You will require this public PAM key and then public IP address or the public DNS, and you can connect from local system as well. I will be using the AWS console here, and this one I will show you in another video how to do the SSH from your local system to your EC2 instances. So let's click on the connect, and here you will see that one user data execution, what we were thinking of the user data, what we have run, correct. So that that should install all the softwares which we require on this particular platform. So let's do the sudo su, and then if you want to check whether git is installed or not, you can check git version. You will see git version is git is installed. You can see the git version. Then if you want to check for your python that we installed, so you run the python hyphen version. You see python 3.9 is installed here. Now we also enabled the docker, so let's check for the docker as well. Sudo systemctl status docker. You will see docker is running, it's active and running, correct. So you can see that this particular user data helped us to install all those softwares without running any command on this particular server, correct. So this user data helps us to identify us to actually install the software which are required on the server side for our day-to-day task or for our automation. So this user data helps you in that particular way, correct. Now let's move to the PPT once again. And if you want to install your nginx server, correct, so basic user data script for setting up Apache, you can run the script in the similar way. You can use this bean bash, that's the starting point of your user data script or the linux script, sorry, the bash script you can say. This is the here we will be using the bash terminal. So for writing your bash script, this is the syntax what you will be using, same line. And then you will be doing the update package manager, yum update. Yum is a package manager for your linux server, so yum update -y that you will be doing. Then you will be installing your nginx the Apache one, httpd, and then you will start that and you will enable. If you want to print any message on your IP address, so that you can do. This will print welcome to EC2 instance when you will be clicking on the public IP address of your EC2 instances. In the similar way, if you want to make it based on particular path or that kind of thing, so you can create a directory at the runtime. And then this one we will cover when we will talking about path based routing. So then we will creating multiple paths, and on that particular path we will see how this will work. Or if you want, I can just create this. Let's try this out as well. So let me do the control C, and then let's go to the control, click on launch instance. Let me click one more instance, test. Let's select the same keep here, public one, and the AMI here I have selected the same, Amazon Linux. Then t2.micro networking configuration, let me do the same, subnet episode 1A. Create security group, no, let me select the existing one, demo SG, and then let's directly move to the advanced details. And here I will be passing the same script, has something bin bash, yum update, yum install httpd, systemctl start, systemctl enable, mkdir to create a directory, html first, welcome to first EC2 instance, and here first /index.html. Let's click on the launch. your EC2 instance has been launched. Let's see. Let's click on the IP address, and it should give you some of the details after this slash first. Okay, for that I will have to enable this security group port 80 as well. So let me add that. Edit inbound rules, custom TCP port 80, that I will have to allow 00. Save rules. Welcome to first EC2 instance, that you can see, correct? So when you allowed in the port 80 and the TCP protocol with the HTTP, because we have not secured HTTPS, we don't have right now, we don't have any SSL certificate, so it gave you the particular message what we wanted to print: welcome to first EC2 instance, correct? So this way you can run your user data, you can deploy your services, you can deploy your application on the EC2 instances, that means you on your virtual server. So that's all. In this particular video we saw the details about the user data. In further videos we'll be talking about the other details about the user data, how to run your scripts. Then we will move forward with the different launch template, auto scaling groups, and all those details. So thank you for watching this video. Let's meet in the next video. Everyone, so welcome to the day 9 of the AWS tutorial, and here we are more focused on the DevOps journey. So we are learning how to move towards the DevOps, and while learning the DevOps we are learning the AWS Cloud here, and even in the AWS Cloud we are learning the AWS EC2 machines, that means your virtual server in terms of AWS Cloud, correct? So if you have not come to this point up to day 9, you can watch out the videos from day 1 to day 8, and then you can come here and you can understand in more details. So today in this particular video we will be talking about the EC2 user data, and we will be talking about how can you write your script on your EC2 machine and you can execute that script, how can you modify the permissions of your files, and how can you execute that in on your server with the EC2 user or your root user. So if you have not watched about the user data what we have covered earlier, so you can watch out the day 8 video, and you can understand how can you enable the user data script and you can install the software as a prerequisite on your server. So today talking specifically about here, we will be launching one server EC2 machine, and there we will be creating our files, correct, local files, where we will be writing the script to add two numbers, the simple one, and then we will execute it, and we will see that how it can add two numbers. So it's just a simple process to write your script and change the permissions of that script and execute that. So let's directly move to your AWS console here. So I'll be creating one EC2 instance over here, that we will see what can we give the name, test. So let's create a test EC2 instance, and the AMI as usual I will be selecting the Amazon Linux to 2023 AMI, which is free tier eligible, and instance type I will be selecting t2.micro, which is also free tier eligible, and with 1 core CPU and 1 GB of memory, which is enough resource for our demo purpose. Key pair, if you have not created before and if you have not watched out the video like how to create key pair, you can watch out other video, or simply you can click on the create key pair, and whatever the name you have to pass, you can pass that name and you can create your key pair. To know in details, you can watch out the other videos which are available on the same channel. Here I will be selecting the one which I do have already. In the network configuration I will be going with the your default VPC, and for the subnet, out of these 3 subnets which are available in the VPC in 3 different availability zone, I will be selecting AP South 1A, which is my preferred one, AP South 1A. For public IP address I will enable because I have to use this public IP address. If I want, I can install any software, I can make the communication with the internet. So I will be selecting the auto assign public IP as yes, that means enable one. Security group, if you want to create, you can write down the name, you can add the different inbound rules, SSH, HTTP, or any other protocols, whatever you want out of these, but I will go with the existing one because I do have already created. And how to launch your first EC2 instance, if you have not watched the video, you can watch out the same one, correct, which is available on the channel. And then we are not going with the advanced details because user data we have already covered in our earlier video. So I'm just directly going with launch instance, and then we will create file which we will execute on the server side. So instance has been launched and it should be available as well. Let's wait for a few seconds till that moment it becomes available and in the running state. So you can see instance ID is there, public IPv4 address is there, public DNS is there, and AMI ID is there. See, in terms of security, there is a security group what we had attached, and you can see the protocol as well. The 80 protocol, sorry, the 80 port and 2022 for the SSH is added here. I hope it should be running. Yes, let's click on the connect. There are two options to connect this EC2 machine. If you want to connect it from the local, you can use your public PAM key what you have created, and then EC2 user at the rate public DNS or public IP address, and you can connect it from the your local command prompt or your terminal. I'll be using this AWS console only to connect my EC2 instance. I'm not going to connect it from the local. If you want to connect it from the local, you can watch out other videos which are available on the same channel. How to connect your EC2 machine doing from your local. That means doing the SSH. So that you can watch. So let's click on the connect. And here I will be doing sudo su. Why sudo su? Because I want to change the user from EC2 user to root user, which will have the higher permission. That means root user, correct? So it has been changed up to the root user. Here I will be creating one file. So to create file on the Linux server, you can use the touch command and you can pass any file name with your extension of the file, and that it will create a 0-byte file. But if you want to directly get in the file with the edit kind of thing, that's notepad kind of thing, you will directly go with the vi and then file name, whatever the file name you want to give. So I will be giving sum.sh. Why sh? Because I want to create a shell script here. So for the bash shell script, I will be using the .sh extension. So vi sum.sh. File or notepad kind of thing is open. Here you see there is nothing to write down, correct? So to get the insert mode, that means the edit mode, I will be clicking on the shift and then I button. So it will change to insert mode. Here I can write anything whatever I want. So I will start writing my shell script. So to start your shell script, this is the initial command, or this is the initial syntax for the shell script. Hashtag and then your exclamation mark and then /bin/bash. So that sets your terminal, which terminal it will use. So it will use the bash terminal. This is also called as clang, and this particular thing is called as clang, and then bin-bash. Then you can write down your script whatever. So we are going to write a script which will add two numbers here. So I am going to define my function. So that I will define add, or let me add right from here only, add numbers, then the small brackets, and then one opening braces and then closing one. Let's do the enter, and here I will be defining two variables, sorry, local num1 equal to 5, that will be my first value, then local num2 equal to 10, that will be my second value. So here I am defining two variables within the script only, and I am just giving the hardcode value. We just want to see how we can execute, correct? So local num1 equal to 5, local num2 equal to 10. Then I have to add this these two values. So I will be defining sum equal to, and it will be your dollar. Where is it? Yeah, dollar, and then to bracket opening one, and then I will be typing num1 plus num2, and then I will just close these two brackets. And after that I will be, let's check it from the script as well. And yes, oh, I just forgot this local I, that's why, yes, that is also a kind of variable only, local. Yes, it will be local equal to sum, sorry, this will be kind of local sum equal to, I just mistyped this, local sum equal to dollar num1 plus num2. Perfect. And then I'll be writing the next message, echo, and here we will write a custom message whatever we want to print. So I'll be printing the sum the sum of dollar num1, that means the first number, the sum of 5, and your second number, that means your num2, so dollar num2. So what will it print? The sum of 5 and 10 is dollar sum, that means the number which will come. So that's this should be the message. And then once I have written down this echo message, I will go with the calling of this function. So add numbers. So here we have defined the function clang bin bash, that's the terminal where we have defined the function local num equal to 5, local num equal to 2 equal to 10. Then the logic, how to add the numbers num1 plus num2, and then echo the sum of num1 and num2 is dollar sum. Add numbers, that we have called the function, and just do the change the mode of writing, correct? So right now we are in the insert mode. Now I will be clicking on the escape button, that will change the mode, you can see. And then you will type shift colon. So here you can write your commands. So I'll be writing W Q and then exclamation mark. What does that mean? W, that means write, Q, that means quit. So it is write plus quit, and then do the enter. You are done with writing your files. If you do the LL, you will see sum.sh has read write permission, read. So this, what is this? Just to understand this, let's go to the PVT once again. So here you can see read, write, then write, and then write. This was what was on the terminal side as well. Let's see. This one stands for your file owner, that means the user through which we are creating the files. The user, that means which are available on the server, so root user, or initially it was EC2 user, correct? So this is permission for your file owner, then the permission for your groups, then permission for other users other than the one through which we are creating, correct? So this is all the permissions are divided into three parts: file owner, group, and other users. For read kind of permission, we represent it with the 4. For write permissions, we represent it with your number 2. And for execute permission, we represent it with 1. So if to the file owner, if I have to give the complete permission read, write, and execute, I will add these three numbers 4 plus 2 plus 1, and I will mark it as 7. If I have to give all the permissions to all file owners, to all groups, to all other users, I will give 777 for all these three. So I will give chmod 777 to everyone. So let's do the chmod 777 sum.sh, and if you do the LL now, LL, that means list down your files. Read, write, execute for everyone, to file owner, to group, to other users as well. Now to execute this script, you will go with dot / because we are on the same directory where my file exists. So dot slash, and then the file name sum.sh. You will see the message, the sum of 5 and 10 is 15. Okay. So what was the content of the file? It was bin bash, add numbers, num1 equal to 5, num2 equal to 10, and then logic to add the number, and then we had printed the message that sum of num1 and num2 is dollar sum. So it has printed the message, the sum of 5 and 10 is 15, correct? So this is how you can write your first script on your EC2 instance. You can change the permission for that particular file, either read, write, your any execute permissions, and then you can just to execute that, you can you can execute this command dot slash and then sum.sh. If it has something some other path, you can just do the pwd, that will show you the directory, the home EC2 user, and then you can type your commands, and that will, you can give the full path rather than just passing dot / you can give the full path and then your file name, that will also execute your script. So in this particular video, I just wanted to explain about how you can write your script, how you can execute that script, and you can see the output as well. In the next video, we will be talking about launch template and other auto scaling groups and other details as well. So stay tuned with the videos and the channel, subscribe to the channel, and we will meet in the next video. So till the time, thank you, bye bye everyone. So welcome to day 10 of your AWS tutorial and the DevOps journey both. So right now we are talking about the AWS tutorial and the AWS Cloud specifically, and here in this particular AWS tutorial we are talking about the AWS EC2 instance. And in the AWS EC2 instances, till now we have talked about why cloud came into the picture, what were the challenges associated before the cloud, and how cloud has resolved those issues. We have talked about how to set up your free AWS account and how to get started with your AWS cloud journey. In this particular video, we will be talking about EC2 launch template and the EC2 auto scaling groups, correct? Before that, in terms of EC2, we have talked about your user data, we have talked about static IP addresses, and we have also talked about elastic block storage, and we have also talked about different EC2 instance available. We have talked about multiple availability zones and the regions, and here as we mentioned that we will be talking about your auto scaling groups and the launch template. So just moving to the launch template now. So our launch template is similar to a launch configuration in that it specifies instance config information. It includes your ID of AMI, instance type, key pair, security group, and other parameters used to launch EC2 instances. So when you have to launch EC2 instance, what we do, we come to this AWS platform, we click on this launch instance button, correct? If you have not watched the video how to launch EC2 instance, you can watch out the other videos which are available on the channel itself. So here you come and you pass the name, you pass the different configuration, you pass the details, instance types, key pair, networking configuration, then other configuration, whatever you have to pass. So in the similar way, while going to the launch templates, you will create a template where you will pass all this configuration, but you will not be launching the server in actual in reality, correct? You will just create a template and you will keep that. Now with this particular template, whenever you want to create a certain number of servers, you will just specify the number of servers and it will create that, correct? So this launch template will be treated as a template where all the configurations will remain in that template, and you have to just click on the go ahead kind of button and it will launch the number of servers for you. So with versioning of launch templates, you can create a subset of the full set of parameters. When we say the versioning, what will be the benefits of versioning? Just suppose in first version you selected your instance type, the instance type in the configuration as a t2.micro. In the next versioning, you want that this instance type should be promoted, and you go from t2.micro to your c5.xlarge or something t3.medium. So you can enable this versioning for the different you can enable the versioning for your launch template, and you can launch the your instances, your number of servers with the same configuration but with the different resources, the different resource capability, correct, with the a higher number of CPU, with the higher number of memory associated with that particular server, while associating the same security group, while associating the same key pair, associating the same networking configuration and everything, correct? So there your versioning will help you to keep the track of your launch templates, what kind of modifications you are doing and all those things, correct? For example, you can create a launch template that defines a base configuration without an AMI or user data script. After you create your launch template, you can create a new version and add the AMI and user data. So that's the another use case. In first version of your launch template, you can just create a simple template, and then in the second version of template you can write down some of the scripts which can be utilized to launch your servers, correct? This will we will see in the demo as well. Now moving to the next topic, that's your auto scaling group. So auto scaling group will help you to launch your server. So now you have the template. This template will be associated with your auto scaling group, which will ultimately launch your number of servers according to your configuration, how many number of servers you want at a particular moment. So as per the definition, an auto scaling group contains a collection of EC2 instances that are treated as a logical grouping for the purpose of automatic scaling and management. So based on the based on the some traffic, based on the some number of requests, based on the CPU utilization, or based on the memory utilization, you want to scale down or scale up your number of EC2 instances to handle the traffic, correct? To handle the performance in optimized way. You want to do the scaling, the dynamic scaling of your number of server. So for that you can create a group that will be called as a auto scaling group, and this group will consist of number of EC2 instances on which your application will be running, correct? So the next point out of this ASG, auto scaling group, the short term referred as a ASG, also lets you use Amazon EC2 auto scaling features such as health check, replacement, and scaling policies. So within auto scaling group, you can create the different kind of policies that we will be talking in next slide. It also maintains the number of instances in auto scaling group, and automatic scaling are the core functionality of the EC2 auto scaling service, correct? So automatic scaling that we are talking about, and even the name suggests, this is the core functionality of your auto scaling service. Moving to the different policy, what we referred here, it auto scaling group also lets you create different scaling features and different health check and scaling policy. In the next video, we have covered the policies as well. So it has three kind of policies that we can create. Target tracking scaling. When we say target tracking scaling, a very simple example here we have kept it. It increases and decreases the current capacity of the group based on your temperature, Amazon CloudWatch metric, and a target value. Just to understand, it works similar to the way that your thermostat maintains the temperature of your home. You select a temperature and the thermostat's done the rest. So you don't have to worry about anything. You just set 20 degrees Celsius and it will maintain the 20 degrees Celsius temperature, whether it's cold or it's hot, correct? It will maintain the same temperature. In the similar way, target tracking scaling works in the auto scaling group. If you set a target CPU utilization of 50%, that means you say that whenever my CPU utilization for server goes up to 50%, you just scale, correct? So auto scaling adds or removes, or when your CPU utilization comes up to 50%, after like it was being utilized up to 70 and now it has come to 50%, auto scaling will downgrade the number of servers, correct? So auto scaling adds or remove instances as needed to keep CPU usage around 50%. Now the second kind of policy which can be attached to auto scaling group, that is step scaling. What does this step scaling does? Step scaling adjusts the capacity of the auto scaling group based on the magnitude of the alarm breach. Larger breach lead to larger scaling adjustment. Just for the example, if your CPU utilization exceeds 70%, you can configure the policy to add 2 instances for a small breach and 5 instances for a larger breach. So you can create the different criteria. If it goes up to 50, launch 2 more instances. If it goes for 90%, launch 10 instances. If it goes for 95%, launch 15 instances. So that kind of step by step scaling you can configure in auto scaling group. Next, simple scaling is increase and decrease the current capacity of the group based on a single scaling adjustment with a cooldown period between each scaling activity. What does this say? Let's understand this through example. If an alarm is triggered when CPU utilization goes above 70%, auto scaling adds 2 instances and waits for a specified cooldown time before allowing another scaling section. So once it will scale, it will wait for a few time duration, and after that it can scale up again. But in between that particular time, it will just wait for few minutes, correct? The according to your configuration, even that particular time duration is called as cooldown period. So that's the term in auto scaling group. From where you can see this launch template and the target groups. For that you will have to come to the AWS console. Here in the left side you will see there is a option of creating your launch templates here, correct? So you can click on the create launch template. You can just give the name demo or template. Let me call it as a demo template. You will just give the description, it used for demo, or whatever you want to say, used for demo. Source template, if you want to do from anywhere, like source template you can give, or we are creating the first one, so I'm just going with that. If you want to add any tag, you can just give the name and the value demo template. I'm just passing that name. Or if you want to add any product, so let me just say that product and you say that my app, that will be my product, anything whatever you want to pass, correct? So product my app. Then application and OS images don't include in launch template. If you want to use it, you can just go with the quick start. You can select your Amazon Linux, which is free tier eligible. So with the help of this particular AMI, your instances will be launched whenever you will be selecting the launch template. Then for instance type, which kind of instance you want to launch. Just suppose that want to go with t2.micro, so I selected t2.micro. Key pair, I'll be selecting the one which way I'm using every time, so public key pair, or if you want to create new one, you can create it from here and you can associate the same. In the network settings, you can select your AP South 1A, that is your subnet. Then existing security group you can use, or you can create a new one according to your wish. I will be selecting the demo SCA. Then if you want to pass any other configuration, you can pass. You can either, if you want to add any user data here, you can add that user data, and you just simply click on the create launch template. Your launch template has been configured. You can just click on the view launch template, and here you go with your launch template here. Correct. So you can see there's a versioning enabled here. So first one has come as a default. If you create one more template, like you get into the action, you modify template, correct, you just change anything, any value, or t2.nano or from t2.micro to something else, then you can just click on the create template version, and that will be your second version, correct. So that kind of configuration you can do. After that, once you have launched your template, you can go to this auto scaling group, and you can create one auto scaling group where you will be configuring this template as well. Click on the create auto scaling group, just give a name. So I'm just giving the name demo ASG. Launch template, which kind of server you want to launch. So I've already created demo template, so I will be launching the servers from this template only. Click on the next, and then you go with the networking configuration. So the default VPC and the availability zones. So I'll be selecting all these three availability zones, the three subnets where my instances will be launched. Balanced best effort, correct, so that the traffic will be distributed in all these availability zones. Click on the next, and just go with the default behavior, no load balancer, nothing. And right now we have not created any load balancer, that we will be talking later on. So just go with the default configuration. Click on the next, and the desired capacity, how many number of EC2 instances you want to launch. So just suppose that I want to launch 2 number of EC2 instances. How many minimum number of EC2 instances I want to launch? 1. And how many max? I want to launch 4 max, but 2 as a desired. So 2 should be running. I can go up to 4, but the minimum should be 1, correct. So that kind of thing I have attached. I'm not creating any policy right now. I just want to show you the demo on the auto scaling. Furthermore, moving ahead, you can create your target tracking scaling policy or other things. I'm just going with the default one. Click on the next, and you are done. Tag I won't be creating. Just click on the next. You review the things. Create auto scaling group. So when I have created auto scaling group, in the instance management section, you will see two EC2 instances should be launched here. Correct. So one is in pending state. Second one will be ready in few seconds. Correct. So here also let me open the instances tab as well. Just get into this EC2 instances. Two EC2 instances are running. Correct. That even you can see in the instance management within the auto scaling group section. So you can see that from the launch template we created the template, and in the auto scaling group we configured this launch template, and with the help of that, without clicking on the launch instances, auto scaling group itself uh, launched the number of instances what we wanted. So our desired was 2, max was 4. So a scaling will happen between 1 to 4, but it will maintain the desired state. So that desired state has been matched. Now I will just terminate this. So I'll mark it desired as 0, and it should go sorry, so I will have to mark this mean as 0 as well. So let's click on the update, and now these two EC2 instances should get terminated as well. So within a few seconds both of them should get terminated, because I have just updated my auto scaling as a 0. So the moment it will be, yeah, you can see that it's terminating. Here also you should see that it should get terminated, shutting down, correct. So this is all about your launch template and auto scaling group. And in next video we will be talking about load balancers and other details what we have left in the EC2. So let's meet in the next video. Till the time, you can subscribe, you can stay tuned with the channel, and you can enjoy the content over this particular platform. So till the time, thank you. Bye. Hi everyone. So Welcome to day 11, where we are talking about the AWS tutorial, and we are more focused on the DevOps journey. So we are covering the different technologies as well, Terraform, CI/CD, and the Kubernetes as well. So right now we have covered few of the tutorials on the Terraform side. So like we have completed complete course on the Terraform side that you can watch out on the channel. And we have started covering the AWS tutorials as well. Few videos on the AWS side are already there, but we are conducting a complete course on the AWS now. So what all we have talked till now? We have talked about your what were the things before the cloud, before the AWS cloud and the different clouds. Why cloud came into the picture? Why different cloud vendors came into the picture, and what kind of solutions they are providing. We have also talked about how to set up your free AWS account, and you get started with your DevOps journey. You get started with your AWS cloud journey. We have started with AWS EC2 service, and till now we have talked about your different properties of the EC2, and we have talked about what are the different instance classes, what are the different instance types available, what are the naming conventions, what is the elastic block storage. We have talked about the what is EC2 IP address, what are the different type of IP addresses are available, and what's the need of all this, correct? So what's the properties of this? So we have talked about private IP address, public IP address, and elastic IP address. Then we have talked about the user data, for how user data can be helpful for your day-to-day automation, and how can it save your time and effort both for launching your server, launching your software over the servers. Then we have talked about what how can you write your first shell script on your EC2 instances, and after that we have talked about what is the launch template, what's the use of launch template, and we have covered the demo as well for all these stuffs till now. And we have talked about the auto scaling groups, and CloudWatch alarm setup you can see in the video, and you can see how to set up the CloudWatch alarm as well. Then we have talked about the EC2, we will be talking about the EC2 target groups. So till now, if you have not watched out all these details, all this content, you can watch out the videos up to day 10, from day 1 to day 10, and then you can jump in directly from here from the target groups. So let's move from here onwards. So target group, like just to get understanding of the target groups, let's understand with one of the example. So if you have one e-commerce application, you see there are multiple services available, correct? You have profile segments, you have your order segment, you have your cart segment, you have your payment segment, you have your different products and category segment over the e-commerce application. You want that for your order system, there should not be only one EC2 instance, but for your order system there should be at least 5 number of server which will serve the traffic of your orders, correct? So different endpoints are coming, different path, user is navigating from one endpoint to another endpoint, from profile segment to order system, from card system to order system, then payment system, everything. So for one particular kind of request, there will not be only one EC2 instance which will serve the traffic, but there will be multiple EC2 instances to serve that particular traffic. So the group of EC2 instances which will serve one kind of service, that will be called as a target group, correct? So it's a target group is nothing but a combination of EC2 instances. It's a group of EC2 instances which will serve a particular business need, correct? So where it can be utilized? It can be utilized to route traffic to different servers. It can be utilized to route traffic onto different path, like slash order, slash cart, slash profile, slash payment, everything. So that kind of for path-based routing, it can be utilized. Then your target group can be utilized in application load balancer. ALB stands for your application load balancer for path-based routing, correct? We will be talking about application load balancer and different kind of load balancer which are available in the AWS later on, moving to the next slide, correct? So before that, let's talk about the EC2 multi-tenancy as well. So if you remember, when we started with the AWS tutorial, we talked that whatever the EC2 instances, whatever the servers you are going to run, all these things run on your physical machine, correct? Ultimately, even the AWS vendor, AWS Cloud is having its own data center into different regions, into different availability zones. So all these things which are available on the cloud as a managed services, that are ultimately being launched on a physical systems. So EC2 runs on top of physical host machine managed by AWS using virtualization technology. And which technology supports in the virtualization? You can say about the hypervisor. Hypervisor is one of the technology which running on the host machine is responsible for sharing the underlying physical resource between the virtual machines. So just suppose that you have 100 GB of physical host machine. You have physical host machine which has the capacity of 100 GB of memory, 100 core of CPU, correct? And then you want to segregate this 100 GB memory into 10 different EC2 instances. So you will be using the hypervisor. You will segregating this resource into 10 segments, and then 10 segments, that means 10 GB of memory, 10 core of CPU. You will just create 10 different spaces within this physical host machine, and these 10 spaces can be utilized by 10 EC2 instances. So hypervisor will be helpful for you. This idea, this idea of sharing underlying hardware is called multi-tenancy, correct? Hypervisor is responsible for isolating the VMs from each other, like all these 10 EC2 instances which will be on one physical machine, that will be segregated from each other, and hypervisor will be the one which will segregate it from the networking perspective, from the resource usage perspective, correct? This means multiple EC2 instances running on the same host are secure and separate from each other, correct? Its networking will be separate, its data storage will be separate. So ultimately the EC2 instances will be separate for everyone. Like I am launching the EC2 instance, that I can manage, that I can handle. If you are launching the EC2 instance, that might be on the same physical host machine, but that you can manage, correct? I cannot manage that. So it's a separate and the virtual. So this particular property is called as multi-tenancy. Talking about the target groups, what we talked here, we will be saying about the your different kind of scripts that we will be utilizing to launch your target groups, and how path-based routing will happen, that we will see in the next video. In this particular, we will be talking about the different load balancers as well, which are available in the AWS in the EC2. So mainly there are three type of load balancer: application load balancer, network load balancer, and gateway type of load balancer. We will be focused more on the application load balancer and the network load balancer, because these two are being utilized extensively. So what are the differences between these two load balancers, that we will see over here. What's the purpose of load balancer? Application load balancer and network load balancer. Both of them will be used for routing the traffics only, but there are differences. So your application load balancer works on layer 7. When we say the layer 7 or the layer 4, we are talking about the OSI model, correct? So on the layer 7, this application load balancer support, and it supports the protocol HTTP and HTTPS. Network load balancer while supports your TCP protocol, UDP protocol, TLS protocol, and it runs on layer 7, sorry, layer 4. And it's ideal for extreme performance and low latency. When we say the low latency, that means we are talking about the slowness. Low latency, that means very low slowness. Protocol support: application load balancer HTTP, HTTPS, WebSocket, while network load balancer support you TCP, UDP, TLS, correct? Performance wise, application load balancer request at the application layer, that we talked about the layer 7, introducing a slight latency for routing decisions. When we say the slight latency, that means there will be a bit of latency, there will be a bit of slowness. While network load balancer process request all the at the transport layer with ultra low latency. When we say the ultra low latency, that means it will be very minimal kind of slowness while using the network load balancer. Talking about the routing features, application load balancer supports your path-based routing. When we say the path-based routing, the same example, you have your e-commerce application, you have your profile segment, your order segment, your cart system, and user is navigating from one particular path to another path, correct? So application load balancer can be most suited for the path-based routing, correct? Slash path, slash order, slash cart, slash profile. So for that kind of feature, application load balancer can be most suited. While network load balancer does not supports routing in that way, it supports routing in based on IP and port. Sticky sessions, like how or up to how much time duration your session will be maintained, that can be supported by application load balancer while using cookies. Network load balancer supports but using source IPA. Performance under the load, net application load balancer can be suited for a moderate volume of traffic for the web applications, while the network load balancer can serve million of requests million of traffic, correct, with very low latency, with a very bit of low slowness. Use cases for these two load balancer: application load balancer can be utilized for web application having the microservice based architecture, or for the serverless architecture, while the network load balancer can be utilized for application requiring ultra low latency, static IP or high throughput, example gaming and IoT. Other examples for the network load balancer can be your real-time streaming, data streaming, your real-time data streaming for your live election news, correct. So the all the counting and other things, your satellite launching for the defense system, where you have to manage or monitor the system 24/7, correct. For those kind of stuffs, your network load balancer can be utilized, correct. So uh, till now we have talked about the your load balancers details, and we have talked about the target groups. In our next video we will see how this target group scripts can be utilized to launch the different EC2 instances on the different paths, and how it can be mapped with the load balancer to get on the to serve the traffic based on the different path. So we will see how path-based routing can be seen while using the load balancer, correct, with the different servers. So that's the thing we will see in the next video. So till the time, let's say thank you and bye bye, and stay tuned with the channel, and try to subscribe if you want to watch out the more content, the technical content over the channel. So that will be helpful for me as well. So thank you, bye bye everyone. So welcome to day 12 of AWS tutorial, and your journey with the DevOps, correct. So we have started talking about the AWS Cloud here, and till now we have covered what were the challenges before the cloud, what were the solutions cloud provided, and cloud vendors came into the picture. We have specifically talked about how to get started with the AWS free account, and talking about the AWS service, we have started with the AWS EC2 instances. What all we have covered till now, while talking about the EC2, we have covered what are the different instance types, what are the different instance classes. We have also talked about what are the EC2 like different kind of IP addresses associated with your EC2 instances. So we have talked about private IP address, public IP address, elastic IP address. We have talked about your EC2 multi-tenancy. We have talked about EBS bandwidth, EBS block storage. We have also talked about your user data, correct. So what is the user data, how user data can be helpful for automating your day-to-day tasks, installing of the software on your machines, how to run your shell script on the server. We have talked about all these things. We have talked about how you can change permissions, you can change the write read permissions on your for your file. We have talked about launch template, auto scaling groups. We have talked about CloudWatch alarm setup. We have talked about multi-tenancy. We have talked about the target groups and the load balancer. Here, in this particular video, we are going to talk about path-based routing using the load balancer, application load balancer. But before that, we are going to create two EC2 machines where we will configure the default path for those two, and we will see how your load balancer distributes the traffic to the different servers, correct, in the round robin mechanism. So let's directly move to the AWS console, and here I have already created your EC2 instances to save the time, correct. So we do have first EC2, second EC2. I have created one target group. So this target group I have named as default. How can you create target group? You can just simply click on the target groups instance, correct. Then you can select your target group. You can pass your target group name here, just like the demo. Then the port and protocol is already there. Protocol HTTP port 80. Then you just go with the default, and for normal, like if you are not specifying any path, so you will just go with the slash, that's it, on the health check path. You will click on the next. You will be selecting your EC2 instances from here, like you will be selecting all these three. You will click on the include as pending below. These three EC2 instances will be selected, and then you click on the create target group, and your target group will be created. I already have the target group named as default one, and these two EC2 instances I have attached here, the first EC2 instance and the second EC2 instance, correct. You can see from here these two EC2 instances, first and second. These two are created in selected in my target group. And path for these EC2 instances I have given just forward slash only. Why forward slash? Because I have not created any particular path on this server. So when I'm saying I have not created any particular path, what does that mean? Let's click on this IP address and you will see a custom message on this particular IP address. So let me go with the port 80 and with the protocol HTTP, and you will see one custom message over here. Welcome to first EC2 instance for default path with round robin mechanism from LV. Then let's move to the second EC2 instance, and here also you will see the same kind of message. So that means there is no particular path on this EC2 instance, correct? So let me go here. Let's remove S from here. Welcome to second EC2 instance. So on this IP address you see welcome to second EC2 instance. On the first IP address you will see the welcome to first EC2 instance. Now in according to that we have one load balancer I have created called as demo LB. This load balancer, just to save your time, I have already created all these resources. You can create later on as well. You to create load balancer you have to just go here on the create load balancer. You have to select this application load balancer. Why this LB? Because ALB only supports your path based routing. You can see from the PPT when we have covered application load balancer supports your path based routing, correct? So that's why we are creating application load balancer. Just click on the create, give your name load balancer. Just go with the default configuration. Second options, you select your availability zones. You want to make your load balancer and the services highly available, so go with all the availability zones which are available. Select your security group, like any security group what you want based on your inbound rules. So that security group you will be selecting, and then just click on the create load balancer. Your load balancer will be ready to use, correct? Then in this load balancer you will be selecting your target group. So here I have already attached my target group forward to target group default, correct? And in this default target group is the same which one we are talking about, correct? So here we have this default target group. Now when we are on the load balancer side, how the traffic will be distributed, see. So this is the load balancer, this is the DNS for the load balancer. I'll be using this DNS and I will hit it in the browser. Let me hit it with port 80. You will see this message, welcome to second EC2 instance for default path with round robin from LB. How this message has been printed over here? Because this is the message which is coming from this second EC2 instance, correct? And the same message is coming from the load balancer as well. How traffic is being distributed? Here we have the load balancer. This load balancer has the protocol HTTP and port 80. On this protocol and port we have the target group associated at the default, correct? This target group default, this is the target group which is here. This default target group has two targets, first EC2 instance and second EC2 instance. So when any of the traffic is coming to your load balancer, that is being moved to your target group. Your target group has now two EC2 instances, and now traffic will be distributed from one to another. That means once traffic will be given to this first EC2 instance, then second time to second EC2 instance. So if I hit this load balancer URL for the first time, it will go to any random EC2 instance out of these EC2 instances which are configured in this default target group, correct? So you can see for the first time the message is welcome to second EC2 instance. If you refresh, you will see welcome to first EC2 instance. Once again, if you refresh, you will see welcome to second EC2 instance. So the traffic is being moved from the first to second, correct? So these two targets are associated here. So the number of EC2 instances you will be attaching here, the traffic will be distributed between those number of servers. Now I have created one more EC2 instance here, you will see, and that is called as third. So what is the difference between the first EC2, second EC2 and third? First EC2 and second EC2 instance is running without any particular path. That means just on its IP address, correct? While my third EC2 instance has its own IP address and path as well. So let me show you the message. Port 80, and when you click it, you will see one custom message, welcome to EC2 instance. But when you give a path here, I have associated a path here as well. When you give a path, you will see this is third instance which is being routed on third path from LV. This is the custom message what I have printed, correct? From where I have used this script, you can see. So what I have done, I have used this script where I have created directory named as third rather than this hello, and I have passed the message. This is third instance, and then here I also have passed third slash index.html. So that path is created here, correct? Now I will be creating one target group for this third EC2 instance, and then from the load balancer we will see how path-based routing can be implemented. So now even the load balancer is routing your traffic without any path, correct? It's just a DNS of the load balancer, correct? Load balancer DNS. Now we will see how your load balancer can route traffic to the different paths. So let me click one more target group here, and I will give the name here, the third target group name will be third, just according to the EC2 instance, so it will be more readable. The third, and the protocol will be 80 only. Path here I will be giving health check path as third, because my IP address, sorry, the path is coming on this slash third, correct? So I will give the same path slash third, and then let's click on the next. EC2 instance, I will be selecting the third one, include as pending below. Let's create target group. So this target group has been created. Now we will, it's unused. As you can see, the health status of this target group is unused. So now we will have to attach this target group to the load balancer as well. So here I will get into this. I will click on the HTTPS, and here let's click on the add rule. In the add rule, I will just give the name, any name, whatever we want. So I will just give the name third here. So my rule name will also be the third. Click on the next. Condition, we want path based condition, so path based routing, correct? So I will select the slash path. Here I will pass the slash third slash, click on the confirm, then go to the next. Target group, on which target group you want to send the traffic when you have the path as slash third, correct? So I want to move it to the third target group. Click on the next. Priority, I will just give it first priority. Click on the next, and you are okay to go ahead. I have associated here, correct? So what's the traffic distribution I have configured here? When the load balancer URL will be hit, it will come to the default target group. If, and what's the condition here? If no other rule applies, that means if there is no any path, so it will come to the default rule. In the default group, it will go to the default target group. The default target group has these two EC2 instances, so traffic is being distributed between these two, as you can see from here as well. Welcome to first EC2 instance, welcome to second EC2 instance. But the thing is, when you have the path pattern is slash third, that means when I will be configuring the load balancer DNS, and after that slash third, it should go according to this target group. Yes. So if path pattern is slash third, it should go to the target group third. What is there in the target group third? In the target group third, you can see here, where is the target group? Yeah. So in the target group third, you will see there is a one EC2 instance attached. On this EC2 instance, what's the message? The third EC2 instance, what is the message it has? It has this message. This is third instance which is being routed on third path. So now let's see whether it is working or not. So let me put slash third after the load balancer URL. You can see the message. This is third instance which is being routed on third path from load balancer, and the same message which we can see on the server side as well. So what has happened here? Now your load balancer is able to route the traffic based on the path as well. So if I remove this particular path, it will go to the normal target group, correct? It will go to the normal target group where these two EC2 instances are there, and it's routing the traffic between these two EC2 instances. Welcome to first EC2 instance, welcome to second EC2 instance. Now when I attach the path here, correct? So where is the load balancer? Yes, here is the load balancer. Sorry. So to the demo LB, if I attach any path here, you can see the rules here. If there is a path slash third, it should go to the third target group, and your third target group has that third EC2 instance which has this custom message based on its path. This is third instance which is being routed on third path from LB, correct? So you can see the message which is coming from your slash third, correct? This is third instance. So this is how your application load balancer can help you in path-based routing to the different servers. If you are not passing any path, you have just configured the default one, it will go to the default target group, and it will distribute the traffic between those two EC2 instances. If you have attached any path, it will go to that target group based on the rules what you have configured in the load balancer side, and it will go to third EC2 instance or any specific EC2 instance, and it will distribute the traffic to that particular server. So in this particular video, that's what we wanted to cover, and stay tuned for the other technical videos, other DevOps related videos. And while we are completing this AWS tutorial from scratch to end, correct. So stay tuned and subscribe to the channel to get more content, to get more clarity. If you have any questions related to this video, just put it in the comment and I will try to clarify that. So thank you. Let's meet in the next video. Welcome to day 13 of your AWS tutorial, where we are moving ahead with DevOps journey and we are learning about the AWS Cloud from the scratch. So what all we have covered till now, we have covered how to get started with your AWS Cloud, how to set up your free AWS account. Also, we have talked about how to get started with your AWS EC2 instance and the different properties of the EC2 instances, including your elastic block storage, elastic IP addresses, private IP address, public IP address, your scaling groups, your launch template, load balancer, different kind of load balancer, and path-based routing. So till now we have completely covered the AWS EC2 instance. We have also covered the user data use case in AWS EC2 instance, which can be helpful for you to do the automation. So till now we have covered all these concepts. If you have not gone through all these videos, you can go up to these videos like up to day 12, and you can watch out all the complete content, and you can directly come to the next AWS service, which is called as AWS IAM. So today we will be talking about the AWS IAM service. I will encourage you to go with all those contents and start your journey from the scratch, from the beginning itself, so that it will be easy for you to understand all the concepts. So in this particular video, we are starting our tutorial, our video with IAM service. IAM stands for Identity Access Management. So what is this service actually does? So this service is particularly used for the security purpose. Whenever you have to give certain permissions to different users, to different members of the organization, or to the different organization, you can create one IAM role. You can assign that IAM role to either a group, to either a user, or to a single member. Correct. So this particular service is used for the security. Let's move to the pointers. AWS Identity and Access Management. That's the full form of this particular service. What does it enables? It enables you to manage access to AWS service and resource securely. Correct. What does it create? It can create and manage AWS users and groups. Correct. It can attach. The permissions can be attached with this IAM role or with the IAM service, and policies to the group, users, and role. What are the different types of the IAM? It's programmatic access or AWS management console. It might be that you don't understand from the points, correct? So these are the features of the IAM. We will do the demo part as well. I will go to the AWS console. I will explain it in more detail so that it will be easy for you to understand what are we talking about, correct? So let's move to the next slide that will give you more detail, that will make you more visualization kind of thing. It will be more easy for you to understand. So you can say there is a user block, there is a group block, then there is a roles block, and there is a green block which is called as policy. So what does the policy means? Policy means the kind of permission you want to give to certain number of users or certain number of groups or to certain number of roles. When we say the permission, we are talking about like if you are using any of the AWS service. So on that particular AWS service, either you will be having the read kind of permission. That means you can only see the content on that particular service. You won't be able to change anything. Now if you get the modify kind of access, you can do the modification, but you will not have complete privilege to do any kind of changes. So that means you will not be having the admin kind of stuff. You will not be having the administration kind of stuff. So according to the permissions, according to the policies which will be attached to the users or to the groups or to the roles, you will be having those kind of limited permissions only, correct? Either delete, create, read, modify, that kind of access. These policies can be attached to us for a single user as well. It can be attached for a group as well, like for within a team, correct? There are dev group, there are within a project there is a development team, there is a operations team, there is a customer support team, or there is a particular user as well. So for a user you want a limited permission. You will create a one user. With that user you will attach the policies, and the user will have those kind of access. For the development team or for the operations team, you created a group. Within this group there will be 10 users of that particular team, correct? And this group will have the certain kind of access. So whatever the access you will grant to the group, the same access will be granted to all the users which are part of this group, correct? And then similarly goes for the roles. You create a role, and that role will have certain policy attached, correct? So whatever the policies will be attached to roles, this role can perform only those kind of actions. So talking about the differences, correct? So what are the technical definitions of all these? IAM users, groups, roles and policy. IAM users, user created in AWS account, root user or IAM user. So root user is the one who has the all administration power for all the AWS accounts which are created within the root account, and the IAM user is the one which is created within a particular account. So let's say here I am on the console. So if I search for the IAM service here, you will see IAM will be here. IAM identity access and management. So this is the AWS service. So within this AWS service, I have the privilege to create, like right now I'm the owner of this particular account. I'm the root user, correct? Because I have this my personal account. So you can see I have this AWS account ID, and I can do the sign out, or I can get into the organization, correct? So you can see identity center management, I have that kind of access as well. Let me search IAM identity center, correct? From here you can see that I do have the AWS management kind of access as well. I can get into the different AWS accounts. I can create the permission sets for the different AWS account what I do have, correct? So all those kind of actions I can perform AWS accounts here, correct? So you can see this is the root account. Within this root account I have created DevOps demo within to the account in which I am working, DevOps demo, correct? So here I can either create I can create a user. I will be clicking on the create user. I can create one user. I can attach the, like, just suppose that I want to create a demo user, so I will just click on the next. So this user already exists, so let me call it test user. Next, then you have the options to attach the policy to this user. So any kind of access, like just suppose that I want to give the administrator access, so I will give this particular access. What are the all the actions this administrator has? It has all the actions. A start, that means all the actions. On which resources? On all resources. A star, that means on all, correct? A star represents your all. So that kind of action permission you can give to any user. Or if you want any read access only, so you can see there are only limited read access, like just suppose for this ACR, and I just want to give the registry read only access. So get authorization token, get repository policy. So you can see most of the things are kind of get. See, with this particular policy, either it can list down the things, it can get the details, but it cannot do any kind of modification, correct? So you can see the policy. So the things which are there here, version, statement, effect, action, this is called as policy or the permission sets. And then the user, what we are going to create within this user block, correct? You can see there are few users. So let me get into here. You might see few users, cancel, sorry, continue. So you can see there are two users named as the demo. These are the policies which I have attached to this demo user. Then you can create role. You can see the different roles here as well. Demo role, correct? So within the demo role, I have attached a one policy with the S3 full access. So this is a kind of policy. This is the kind of role, demo role. This role has this particular policy permission, correct? Then you can create the policies. Then you can create groups as well. So if you want to create group, you will just give a name to this group. So you can say the test group. Then you can add the user. So if you want to add multiple user, you can select it from here. Or if you want a particular user, you can select all those. Then which kind of policy you want to attach with this particular group, you will be selecting that, and you will click on the create user group. Your user group will be created. So these are the things from the AWS console perspective as well. We have seen that. So what is IAM users? User created in AWS account, that we have already seen. IAM groups, it's a collection of IAM users, correct? You might have already seen here. So in the group you can add multiple users, correct? Then what are the roles? It's temporary identities. It does not have credentials attached, expires after a set period of time. So whatever the time period you will be attaching with this particular role, it will be available for that particular time duration. The policies, it defines the permissions. So as you can see in the policy, what kind of actions can be performed, it describes all those things, correct? So if I get into the user sections here, if you see, for the demo user I have the certain limit, certain permissions. So I have this KMS inline policy, then AWS Lambda full access. So these kind of permissions, it can be this user can perform with this particular policy. So one more difference, you if you see what I have mentioned here in the PPT as well. So policies are of two type, either AWS managed policy or the customer managed policy. What is the difference between these two? Here is PC. These are labeled as AWS symbols as well, and type is AWS managed. What does that mean? All these policies are created by AWS itself, correct? But the policy what I will be creating here, that will be called as customer inline policy, and I can do the edit kind of thing, correct? Whatever the changes I have to do, I can do. So if you see here as well, here in the IAM full access, you don't have any options to edit. You do have only copy JSON. While if I have created the policy, I do have the option to edit as well. So this policy will be managed by me, correct? It's the customer inline policy. So that's the difference between the policy, AWS managed policy, and customer inline policy. And for example, here also you can see the same thing. And in the IAM role, if you see the important thing, or from the user sections as from the user perspective as well, you will see there is a permission boundary. So what does this permission boundary means? It sets a permission boundary to control the maximum permission for this user. So for this particular user, or for any particular role, here also you will see the permission boundary. If I get into any role, you will see the permission boundary. What does that means? In the user perspective or in the role perspective, it simply means that you will be assigning certain kind of permissions to this different users or to this different roles. But if you want that this particular user or this particular role should have only limited access, it should not go uh, up to those services which you don't want to allow, correct? So that kind of permission boundary you can select, you can configure from here. Permission boundary to control the maximum permission this role can have. So if you set anything over here, so anyway if you allow that policy from here, it will not be allowed, correct? Because it has the permission boundary set. So this is all the concept from your IAM service, from the IAM perspective. Here is identity access management, your different users, groups, and the roles. Then you have some different kind of policies. You can create AWS managed, your customer managed, correct? And then there is a trust relationship. There is a permission and revoke sessions. You can see with your role there is a revoke session as well. Maximum session duration 1 hour, and after that it will be signed out, correct? So and here in the trust relationship, you can see that which kind of role or which role can assume this role and it can work. So this is all I wanted to cover from the IAM perspective in this video. Stay tuned for next coming videos on the AWS BPC side and on the different topic. And if you like this content, you can subscribe to the channel, and you will be getting the more content on this particular channel only. So till the time, let's meet in the next video. Till the time, thank you. Bye bye. So welcome to day 14 of the AWS tutorial, where we are learning about the DevOps journey, and particularly we are learning about the AWS Cloud, where we are talking about the different AWS services, correct? So till now we have covered how to set up your free AWS account, how to get started with the AWS Cloud, why cloud came into the picture, what were the challenges before the cloud, correct? And to start, we have talked about AWS EC2 instance, where we have covered your different kind of instance classes, different kind of instance types, different kind of IP addresses, private, public, elastic IP address. We have talked about elastic block storage. We have talked about launch template, auto scaling group, user data, your path-based routing, application load balancer, network load balancer, and the different properties. Also, we have talked about IAM role policy and the groups and the users, correct? Today we are going to start with AWS VPC. That's the one of the main component of the networking where your all AWS services, maximum AWS services lies within the VPC only. VPC, when we say, that means virtual private cloud. So within the cloud it's a sub area. So let's go with the simple explanation, a very simple example which can be very much helpful for you to understand. So let's suppose there are these five members. Actor 1, when we say the actor 1, just suppose that it's a random member. So there is a one member from the UP, there is a second member from the Mumbai, there is a third member from the Kashmir, there is a fourth member from the Andhra, and the fifth member is from the Bihar. They all are looking for a job. They all are looking for a job from the different location. They all have received a job opportunity from Delhi NCR. That's your metro city, correct? And that's the capital of India as well, correct, our country. So they all are looking for a job. They all got a job within the Delhi NCR. It might be your Gurgaon, it might be your Noida, or anywhere, or it might be in Delhi, correct? They got a job. Now they have to get into here in Delhi NCR. They have to work. It's not work from home, correct? Either it's a hybrid mode or your work from office, the new one, correct? The new culture. It might be a hybrid or work from office. It's not COVID call, so no work from home. They all have to come to here, Delhi NCR. So what's the basic thing? They have to reside here, then they can perform their job here. They can perform their duty. They can get into the office on the daily basis. Correct. That's the simple thing. Now, what does that mean? If you relate this with the cloud perspective, this is the on-prem time. Correct. When you had to purchase the infrastructure, then you had to run the application. So you had to actually purchase. So if there were no cloud, if there were no rental systems available in the, Delhi NCR, what this UP member will have to do? He will have to come. He or she will have to come to this particular place. He or she will have to purchase a place, and he will have to reside here. Same goes for the Kashmir member as well, for the Andhra member as well, for the Bihar member as well, for the Mumbai member as well. He will have to come to this particular place. He or she will have to purchase a house or purchase a plot, and he will have to be here for the permanent time. Correct? But this is not the efficient things. You cannot purchase everywhere. Today you are in Delhi NCR, tomorrow you will be in some another city, in the Hyderabad, in the Mumbai, in the Pune, in the UK, or somewhere else. Correct. So you cannot go everywhere and you can purchase a land, you can build your house and you stay there. You cannot do this. Correct. So out of these five members, one of the wise member, you can say the UP wala wise man. Correct. So the UP wala wise man thought that, why don't I purchase a particular land in this Delhi NCR region here, and I will build a house and I will sell to these people. Correct? You can correlate with cloud vendor. We will come to the cloud perspective as well. Let's go with the example. Here, everyone has to come to Delhi NCR. They had to purchase their own house and they had to live. Correct? Now, apart from that, because they had to move from one place to another place, this Mumbai person has to come here. He has to look for the particular place. He has to build the house. Then he has to live. So it's a long process to be in Delhi NCR. Correct? You purchase, you look for the property, you purchase that, you build your house, then you come here and start living. Now this CPO wise man thought that, I will just give the comfort to these people. I will purchase a land and I will build the houses for all of them, and then I will start selling these houses to these people, or I will start providing rental system here. I will build the house and I will start providing the rental. Correct. So this Kashmir people will come, it will rent a house and it will start living. This Andhra people will come here in NCR, it will rent this house and it will start living. Same goes for the Haryana people, Punjab people, and Bihar people as well. They will come here, they will rent a house and they will start living, and they will perform their job here for 2 years, 3 years, for the time duration they want to live. Correct. And once they will, or they want to go back, they can just end their rental system, they will go back to their hometown. and this place can be rented back to the someone else, correct? But there was an issue here. When you have purchased a house, you all are living together, so there is no security till now here, correct? So there are different houses. This Kashmir people is living, this Andhra people is living, Bihar people is living, Punjab people is living, and the Haryana people is living. So right now there is no security, everyone is living together. So just suppose that one of the member from one of the guest for Andhra member is coming, the relative of this member is coming. All the houses are built within this particular block. So, if the guest is not aware about this particular member house, he can go to the Haryana member house, he can go to the Kashmir member house, he can move anywhere, because the guest who is coming is not aware of the route, correct? Where he has to go or where she has to go for this particular Andhra member, correct? So there is no security kind of a stuff here. Now the picture got changed. Now the UP wala wise man, rather than just building a house in 50 acres land, he thought of, I will build a society. The society, the high-rise society, which is the new concepts in the market, correct? He just thought of that. What did he do? He built a society of 25 floors with multiple flats, like 4 flat on one floor. That's that kind of construction he has made, the UP wala member, correct? Now still the people are from Punjab, Telangana, Goa, Kerala, MP, correct? These are the 5 states now. We are considering all the states maximum, Kashmir, Andhra, we are. So you might not, you should not think in a way that I am just considering few states only. There are multiple states I am considering for my examples, correct? So now there are Punjab people, Telangana people, MP people, Kerala people, and Goa people as well. The UP wala wise man has built a society with 25 floors with multiple towers and multiple flats on one floor. Now, when any of the guest is coming for this MP member, correct? This MP member house is there or the flat is there in this particular tower. If any of the guest comes, he has to go from the guard, correct? He will meet to the guard. He will tell that I have to go to this Punjab people house or Telangana people house or the Kerala people house or the Goa people house, correct? The guest will tell to this guard. This guard will now directs you that you have to get into this first block or the second flat or the third flat or the fourth flat. So whatever the request you will make to this guard that I have to go to this particular flat, you will be directed to that flat only, correct? You cannot go anywhere else, correct? And the same, the flat owner will be notified that your one of the guest has come to meet you. So you will be notified by the for the guest, and guest will be notified for your particular flat. So you will directly move there, and flat owner can directly communicate with that guest. So no one else will be interfered here, no one else will be disturbed here, correct? So that's the security stuff has been implemented here. So no one is now disturbed. Same goes for your cloud. So now let's understand the same example from the cloud perspective, correct? So till now you have understood that how things worked from on-prem to cloud. So now let's see the cloud perspective. Earlier, when there was no cloud, everyone, the e-commerce application, like just suppose these are the 5 businesses rather than UP business, Mumbai business, Kashmir business, Andhra business, Bihar business. So these are the 5 people who are trying to launch their businesses, correct? He has gone to the market, purchased few infrastructure, and he has started running his application, correct? Everyone has to come to the market, they had to purchase their own infrastructure, they start using infrastructure, and they were running the application. Now few of the organizations thought of, why everyone has to purchase everything, correct? I will purchase the cloud infrastructure, I will build that infrastructure, I will build the data center, and I will start renting system, correct? I will start renting system, people will come to me, they will utilize my infrastructure, they will provide me the rent for that. Kashmir businessman will come to this particular place, he will just rent the infrastructure, correct? The built houses, he will just rent the infrastructure in terms of cloud, correct? He will rent, and he will utilize, he will run applications, he will run his business. Once he is done with the businesses, he can release the infrastructure that can be now rented for someone else, correct? So that's how your multiple cloud vendors came into the picture. Your AWS as a cloud, your GCP as a cloud, Azure as a cloud, correct? So Microsoft, your AWS, then Oracle, then IBM, multiple cloud vendors came into the picture. They started renting system, correct? But the security was missing here. So now when you have the cloud, like we are talking multiple times about the AWS cloud. So within the AWS cloud, you have a one account. Within one account, you you can have multiple VPCs now. So these smaller blocks are kind of VPC. So just suppose this is one of the AWS account. Within this AWS account, you have multiple VPC. That means multiple particular private areas. Within that you can perform your actions accordingly, correct? So if any of the request is coming, any of the thing is coming, they had to go from the guard. That means some kind of roles or permission will be there to log in into your AWS account. It will be accessed through access key, secret access key, or your management account role, whatever the kind of permission suits you have created here. So then you will be able to log in into this AWS account. Once you are in the AWS account, you have different regions. You have AP South 1, Mumbai region. You have US 2, London region. You have US East 1, North Virginia region. There are different regions. Within the different regions, there are VPCs. Correct? You can launch VPC A, VPC B, VPC C, and so on. For each VPC, there will be some security. There will be some guard associated with that VPC. Correct? If you are allowed to get into that VPC, you will be getting into that VPC, you will perform the action and you can come out, correct? So every VPC will have some guard. So this is how the cloud came into the picture here. It has started renting system. Then the cloud provided you one AWS account. While we are talking about the AWS, same goes for GCP and Azure as well, and other cloud providers as well. You have one account for in that particular cloud. Within that cloud, you have multiple VPC. That means for your private networking area. Within that particular private networking area, there will be some security stuffs through which you can get into that particular area and you can perform the actions. Now let's come to the real picture of the AWS. Here you have a user, correct? This is the VPC block. The bigger one is the VPC block. If you have to get into the VPC from the external world, from the internet side, internet gateway should be associated with this VPC. This internet gateway will only allow any request which is coming from the internet to this VPC. It's just a high level overview how your security stuffs, how your VPC looks like, correct? So any request which is coming from the outside, that has to go from the internet gateway. This internet gateway will be the part of some of the route tables. So just suppose this internet gateway is associated with one of the route tables. So now with the help of internet gateway, you have get into the VPC, correct? You have to go up to the server here, public EC2 or private EC2, correct? Your application is running over here on the EC2 side, either on private EC2 or on the private public EC2. You have to go up to the server when you are making any www.abc.com, that kind of request that is coming from the internet. It has to go up to the EC2 machine. So how your traffic will go? It is coming from the outside, so it will go through the internet gateway. Internet gateway is attached with one of the VPC, so it will get into that VPC. From the internet gateway, this internet gateway will be part of the sum of the route table. It will go to the route table. This route table will have association with the subnets, public subnet, private subnet, and the different kind of subnets. Based on the request from where it is coming, on which IP address it has to go, it will route your traffic to the subnets, either to this subnet, public subnet 1 or private subnet 1, based on the configuration what you have configured, correct, and based on the request which is coming. But before getting into the subnet, it will go through the NSCL. So this is kind of the first level of guard within the VPC. So this NSCL will now check whether this particular request which is coming from the route table, whether it is allowed to go into this subnet or in the second subnet. It will check. The NSCL will check here. Based on that, it will allow to get the request into this subnet or this subnet, the second one. The request will go up from the subnet to your from NSCL to your subnet. correct? I just suppose that it has come to this first one. Now before getting into the public EC2 machine, then public EC2 machine, second guard is here, that will be called as security group. Security group will check whether this request is allowed to get onto the server or it's not allowed. If it's allowed, it will go to the server, and the same request can come outside as well, and it can come to the internet here. If it's not allowed, it will be just denied over here and your request will be blocked here, correct? So as if you can see, to get into the VPC, the first layer of access is internet gateway, then it will come to the route table. From the route table, it will be decided in which subnet it has to go. But before getting into the subnet, NSCL will check whether it's allowed to get into that or not. If NSCL approve that it can be allowed, it will go. If NSCL does not approve, it will be blocked here only. The request will be blocked over here only. It will not go anywhere within the VPC. If NSCL approves that request can go, it will come here. Once the NSCL has approved, the request will come to up to subnet only. After the subnet, security group will check whether it is allowed to get into the server or not. If it's allowed, it will go up to the server. So one major question comes from here as well. Where does NSCL work? Where does security group as well? Your security groups work as a guard system for your server, for your EC2 instances, while your NSCL works as a guard for subnet, correct? So NSCL operates on the subnet level, security group works on your server level, correct? Security group is stateful. That means it allows all inbound and outbound. Whatever the request you allow as a inbound, that will be auto accepted as outbound. That request can go outside. While NSCL supports stateless. Whatever you configure to get into that subnet, it should be allowed as outbound as well. That means that request can should come outside as well. So in NSCL you have to define inbound and outbound both, while in the security group you don't have, you have to define only inbound rules. Outbound rules it remembers automatically. That means it's stateful. So this is the high level of overview of your VPC. How does VPC works? What is the VPC? Why? How VPC helps? What's the rental system for the VPC here? Correct? That you can understand. So I hope I'm able to explain how your VPC works, how security groups, how NSCL works on a very high level. Correct. So in next video we will be talking more into the demo side on the AWS console, how your VPC can be created, how your different route tables, IGW can be created, how one of the public EC2 instance can be launched within this VPC, and we will talk about the subnets and other details. So let's meet in the next video with the details. Till the time you can subscribe the channel. I hope you like the videos as well, and if you are liking this video, you are good with this content, you can hit the subscribe button, and that will be helpful for me to create the content as well. So till the time, thank you, bye bye. Welcome to the channel, and today is the day 15th where we used to learn about the DevOps journey and specifically about the AWS Cloud. So today we'll be covering about the Amazon VPC. That's one of the important service of the AWS Cloud itself. Till now we have covered about the cloud perspective, why cloud came into the picture, and the different properties about the cloud. The use case of the cloud we have seen, and we have also talked about the AWS EC2 service in detail. We have talked about the user data, elastic IP addresses, public IP, private IP, elastic block storage, then the different classes of the EC2 instances. And at the same time, we have talked about how to run your first shell script on the EC2 instances. We have also talked about your IAM roles, user policy, and all these topics. And we have talked about the load balancer, the different kind of load balancer, and path-based routing. In today's video, we will talk about the Amazon VPC and kind of subnets and the internet gateway. Then we will try to see one demo as well, how to create first VPC. So let's start with the VPC itself. So let's go with the point itself, and the first point in terms of VPC. If you have not understood the VPC, you can watch out the previous video, day 14, where you will understand in details what's the purpose of VPC and what's the VPC in actual. Correct. So let's start from here. The first point, allow you to establish boundaries around your AWS resources. So whatever the AWS resources you want to launch, when we say the AWS resources, that means the different AWS services. So if you want to launch your AWS EC2 instance, if you want to launch your AWS RDS instance, if you want to launch your AWS Lambda function, so all these services can be bind within, or a boundary can be set for all these different resources, so that the networking will lie within a particular area only, and that particular area will be called as your virtual private cloud. So the VPC will set a particular area. Within that particular area you can deploy your the different services, as you can see from the diagram as well. So this yellow diagram is a kind of VPC, and within this VPC you have all these resources deployed, the EC2 instances, the routers, and the different resources which are there. And if you want to connect it to from the on-prem, there is you can see the customer network. That's the on-prem kind of thing, your data center kind of thing. And if you want to connect it through your cloud, there is a secure VPN between the cloud and between on-prem data center as well. So is AWS VPC creates a boundary for your resources. Then whenever you launch your AWS account, you get a default VPC in each AWS region. So now when we say the AWS region, that means your Mumbai region, your North Virginia, your Sydney region, your US to London region. So in all these regions, you get a one default VPC. You can launch your AWS resources into this VPC. When we create VPC, specify a CIDR block range of, for example, 10.00/16. CIDR is nothing but it's just a kind of your pool of IP address ranges. So whatever the CIDR you mentioned, there is a particular calculation that we will talk about, that how many number of IP addresses will be there. So based on that, a set of IP addresses allocated to that particular VPC area, and these IP addresses can be further utilized for networking within the different resources. A VPC span all of the availability zones in the region. So the VPC will be having your like if you are creating your VPC in AP South 1, that's your that is in your Mumbai region. So this VPC will be available throughout the complete region. That means it will be available within the different availability zones which are part of that region. Then moving further, you can see VPC stands for Virtual Private Cloud, which is a secure, isolated private cloud that is hosted within a public cloud. Correct. So the public cloud, when we say that, that means your AWS cloud, your Google Cloud, or your Azure, all these public cloud where we create a VPC. When we say the AWS, it's VPC. In other cloud provider, it will be with the different names. Then there are few more pointers about that the same. Now let's move to the different features of the VPC. So a VPC is a virtual network that closely resembles a traditional network that you would operate in your own data center. So like if you have your own data center, you will do all the networking, all the wirings, and the maintaining of those wirings and all these stuffs in your own data center. While if you create a VPC, you don't have to be much worried about this networking configuration. VPC will take care of that, and you have to just go with the, like you have to just play with the console where you will be creating the different subnets, you will be passing the different CIDR. So those kind of console play you have to do. A subnet, let's understand about the subnet as well. So within this VPC, if you see the previous diagram, this is the area of VPC. Within this particular VPC, if you want to segregate this area into two parts, so you can mark one part as a and second part as a B. That we have talked in earlier video as well, day 14, where I have explained the concept of your subnets, the different subnets, the route tables, and all those things. So a subnet is a range of IP address in your VPC. A subnet must reside in a single availability zone and within the VPC itself. Correct. So whatever the IP address range will be there for the VPC, a subnet will be the part of that. That means it's a kind of subset for the your VPC. After you add subnets, you can deploy AWS resources in your VPC. Correct. Let me do Control Z. Yeah. Then use route tables to determine where network traffic from your subnet or gateway is directed. Gateway connects your VPC to another network. So it might be your internet gateway or customer or different kind of endpoints or gateway. But the purpose of gateway is to route your traffic from one place to another place. So it defines or it connects your VPC to another network. For example, use an internet gateway to connect your VPC to the internet, or you can use a VPC endpoint that we will talk about later on. VPC endpoint to connect to AWS services privately without the use of internet gateway to or NAT device. So VPC endpoint we use for creating your private network within your to establish the connection between two AWS resources while keeping your networking as a private one. Then moving forward, the different features of the VPC. Use a VPC peering connection to route traffic between the resources in two VPC. So just suppose that you have one database in first first VPC, and then you have the application lying in the second VPC. And now you have to make the connection between these two VPCs so that your data can be retrieved either the right kind of thing or the read kind of thing. Then you can establish the VPC peering connection to read the data or to write the data into a second VPC. Then there are a few other top features of the VPC as well. The transit gateway, flow log. Flow log will capture information about the IP traffic going to and from network interface in your VPC. So whatever the network logs will be generated, that will be stored in your VPC flow logs. So that either you can create a S3 bucket, you can store all these flow logs in that bucket, and whenever you want to analyze that based on some issues or something, you can do that. Moving forward, let's talk about the subnets here. So subnets are nothing but just a subset of the VPC itself, you can say. So as per the diagram, you can see the first block stands for the AWS Cloud. Within this AWS Cloud account, there is a second green box which stands for your VPC. And within this VPC, we have two subnets, public subnet and private subnet. So subnets are just part of the VPC. That means if this particular VPC has 1000 number of IP address, so your public subnet might have 700 of IP address and 300 subnets for private subnet, 300 IP address for private subnet. So this kind of allocation can be done within the VPC to make some of the resources your public and to make some of resources as a private. Correct. So within a VPC, you can organize your resources into subnets. A subnet is a section of VPC in which you can group resources based on the security or operational needs. So when we say the security, that means which kind of traffic can come to this subnet, which kind of traffic can go outside this subnet. So that will be that we can control within this subnets. Each subnet must reside entirely within one availability zone and cannot span zones. Correct. So your public subnet might be in episode 1A, your second subnet might be in episode 1B, or any particular availability zone. Your subnet may lie at one time. Your subnet may lie in one availability zone only. Then let's talk about the public and private in details. So if a subnet is traffic is routed to an internet gateway, the subnet is known as a public subnet. So it's just like that property. Like if you are requesting your any kind of request you are making to the public, and your traffic is being routed to internet gateway from the subnet, so that subnet will work as a public subnet. Correct. And for that, to make that particular subnet as a public, you will have to add a route in your subnet route table. So your subnet will lie somewhere in a route table. It will be having net subnet association with some of the route table. To make that subnet public one, you will have to mention the route in your route table where your subnet is associated as a 00. That means the route table will have the association with the internet gateway, and route table will be having the association with your subnets as well. Then your subnet will be public one, as you can see from the diagram itself as well. Here if you can see IGW is attached here in the custom route table 000, and IGW is there. So now your subnet becomes as a public subnet. While for the private one, you can see for the private one, NAT gateway is mentioned with the 00 destination. That means the NAT gateway is also working like this. This is mentioned in the public subnet, and from the public subnet, it's finally going to the your IGW internet gateway. So the private subnet does not have directly access through to the internet, but it has the access through the net, then from up to the internet. Correct. So that's the feature of your public subnet and the private subnet as well. So here you can see the for the private subnet the second diagram. A private subnet does not have a route to the internet gateway. You can use a network address translation NAT. Then this one stands for your NAT. NAT gateway to enable instances in a private subnet to connect to the internet or other AWS services. Then the final one is internet gateway. So if you have to make your subnet as a public one, and you have to make the connectivity with the internet, like you have launched your EC2 machine, and on that server you have to install some of the software which are kind of open source or which are publicly available. To install this software you will run few commands, and that will go to the internet, it will install the software. For that you will require the access of internet. So here internet gateway comes into the picture. Your EC2 instance live within one subnet. This subnet is a part of one VPC. That means it's a virtual private cloud, so it's a private area. Now the request has to go from this VPC to the internet. So for that there will be internet gateway which will make the connection to the internet, and it will install the softwares on your server. So internet gateway is always attached with the VPC. So you can see the first point, attach an IGW to the VPC to allow public traffic from the internet to your VPC. Sorry, without an IGW no one can access the resources inside your VPC. So to access your resources within the VPC you will have to you will have to attach the internet gateway so that request can go and come outside. Allow instances in a VPC to access the internet. That's the feature of the internet gateway. And now let's directly move to the your AWS console where we will create one of the VPC, and we will see how you can create first VPC from the console itself. So here we are on the AWS console, and you can search about the VPC this service. Let's get into there. And as you had already seen the pointer that whenever you create your AWS account in each AWS region you get a default VPC. So here also you will see there will be one VPC running, and that is the default VPC. Now we have to create VPC according to ourselves. So I will go with the VPC only configuration. If you click on the create VPC you will see you have to pass the name, you have to pass the different configuration. So just for demo purpose I am just giving the name demo -VPC. CIDR I will pass as 10.0.0.0/16. That will be CIDR. That means how many number of IP addresses will be there. Then tenancy default, and the name. This will be the name of the VPC, demo VPC. Let's click on the create VPC. So your VPC is created now. Now let's directly move to the internet gateway. So one default internet gateway is also there. Let's click on the create internet gateway, and here I am saying as demo IGW. Create internet gateway, and you can see right now this internet gateway is in detached mode. So if you see the PPT, here we talked about that whenever you create internet gateway, it should be attached to the VPC. Correct. So either you can detach or attach, but if you have to make your VPC, all the resources which are in the VPC, they have to communicate with the internet gateway. Sorry, to the internet. The internet gateway should be attached with the VPC. So right now your internet gateway is not attached to any VPC. So you will have to attach it with some of the VPC here. Right now it's empty. Correct. So let's click on the attach to VPC. Search for your VPC and click on attach internet gateway. Now it's attached. So the resources which will lie in this particular VPC, demo VPC, that can have the access of the internet because this internet gateway is attached with your VPC ID. Correct. Then if you want to create any subnets, you can click on the create subnet here. You can select your VPC where you have to create the subnets. You can give any name, like I'm just passing one name, public subnet -1. Then you can select your availability zone, in which availability zone you want to create. As we had already talked that your each and every subnet should be the part of one availability zone at one time. So you can select one availability zone here. Then you can pass the CIDR, and your CIDR for the subnet should be in the subset of your IP address. Sorry, the CIDR of your VPC. So as you can see for the VPC it was 10.00/16, and for your subnet it will be 10.0.1.0, then 28 we can give. Then let's click on the create, and your subnet has been created. So in a similar way you can create the different subnets as well. Now this subnet should be the part of route table. So for now you can see there is no route table associated over here. So let me create one route table here, and let me call it demo route, and then select the VPC what we have created. Let's click on the create route table, and within this route table you can do the subnet associations. So just click on the edit subnet association and select your subnet, save association. So your subnet has been attached in this route table. It is the part of this route table, and this route table will have the access of your internet gateway. So here you can add the route as well, 00, then the internet gateway here, and you can select your demo IGW, save changes. So now what the structure is there, if you can see where we have this public subnet. So this public subnet has the access of the internet gateway. This is the part, internet gateway is the part of your route table, and your subnet is the part of the custom route table. So now this subnet has been become your public subnet, correct? So this is what we have established here. This route table has the association of the internet gateway. This route table has the association of your subnet. So whatever resources you will create in this particular subnet, that can have the access of the internet gateway, because your internet gateway is attached with this particular VPC. So in this particular video we just wanted to cover this much only, the VPC and the different concepts of the subnet, then the internet gateway as well. And in the next video we'll be talking about the net gateway and other topics related to VPC and the different services. So till the time, stay tuned with the channel, subscribe to the channel, and let's meet in the next video. Thank you. Everyone, welcome to day 16, where we are learning about the AWS Cloud and talking about the DevOps journey. So till now we have covered why cloud came into the picture, what were the challenges before the cloud, and specifically we have talked about the AWS EC2 instances. While talking about the AWS EC2, we have covered the different instance classes of the EC2 and the elastic block storage, EC2 IP addresses, private, public, and the EIP that we have talked about. We have also talked about the user data, launch template, auto scaling groups, and the target groups that we have covered. And lastly, we have covered VPC, public subnet, and private subnet. In this particular video, we are going to cover NAT gateway, and we will be talking about the network address translation, this particular feature, which is called as NAT. So when we were talking about the private subnet and the public subnet, we talked about the internet gateway as well. So just suppose if we have a particular EC2 instance which is created inside the public subnet, and when we say the public subnet, that simply means the route table which is having the association with this subnet is also having the association or the route defined as an internet gateway there. So whatever the request will come to this subnet, that will have the access of the internet. That means it is the public subnet, correct? At the same time, we also talked about your what we say this sorry we talked about your private subnet, which is not having any association of the route as an internet gateway. That means if your EC2 instance is part of your private subnet, and if it wants to install any kind of software which is available on the internet side, or Jenkins or the Docker or the Python, any kind of software, it cannot install that software directly. But there might be a scenario where you require that no one from the outside can access your resources which are the part of your private subnet. Just suppose that there is a database which you have deployed in your private subnet, so you don't want that anyone from the outside can access your database. While at the same time you might want that if you have to install some of the software on the database side, or some of the upgrade activity on the database side, which can happen from the internet only, then uh, you might generate a request which will go to the internet. So you want the outbound traffic to go to the internet, but you don't want any kind of inbound traffic to come to your resource from the internet, correct? So in that case, you can apply the NAT gateway, which will act as a outbound traffic that will allow you to go to internet, but it will not accept any inbound traffic from the internet, correct? So as you can see in the PPT as well here, we have two EC2 instances which are the part of your private subnet, and we have created two NAT gateway which are the part of your public subnet. So every time when I create the NAT, we create it in the public subnet, and then your request is going from the internet gateway to the real internet, correct? While if anyone from the internet will try to make any request to the EC2, that will not be accepted, it will be denied, as you can see from the red cross mark as well here in the picture. So the properties of the net is allow instances in private subnets to connect to the internet, outbound internet traffic only. It ensures though no inbound internet traffic will come to your resources, correct? So that's the feature of your network address translation, uh, which is simply called as NAT, correct? Then the simple call, how it happens, that you can see whenever a client make any request, that is converted into the form of packet, and then it goes from your internet gateway to the your EC2 instances. There are some security check in between that we have talked in while we were talking about the VPC. Some of the network access control list, that means NSCL applies before getting into the subnets. Then once it goes to the subnet, it security groups are applied, and once it is verified from the security group, then your request finally goes up to the server side, that means up to the Amazon EC2 instances. So in this particular video, we are going to just understand the NAT concept, and theoretically we have covered. Let's directly move to the AWS console where we will see the demo part as well. So what are all we are going to create over the AWS console as the part of demo? We will create one VPC. We will create two subnet. That one we will call public, and second one we will call private one. Then we will create the internet gateway. We will associate in the route tables, and at the same time we will launch two EC2 instances called as public and private, and we will see what are the differences and how NAT will help you to avail the internet from the private subnets. So let me click on the create VPC. Let me create one VPC called as demo VPC. Then the CIDR I will put as 10.0.0.0/16, and then let me just click on the create VPC. One VPC has been created. Let me go to the subnet. I will create one subnet here. So for that, let me select the VPC in which VPC I want to create subnet. So demo VPC. If you have not seen how to create the VPC and other things, and if you want to get into the details, you can watch out the day 15 where I have covered in details. So subnet name I will be giving as public subnet. It's just the name. It's not the actual that this subnet will be public one, but I'm just giving a name public subnet. And then availability zone, I will select the one which I used to prefer, AP South 1A. And then subnet CIDR for this particular VPC, that will be your 10.0.1.0/24. And then let me add one more subnet here that we will call as private subnet. Private subnet and preference the same, AP South 1A. The CIDR for this particular subnet, we will keep it as 10.0.2.0/24 in the similar way, and then click on the create subnet. While these two subnets has been created, let me create two route tables as well, because we will do this association of the in these two subnets in the route tables, and we will also do the association of the routes so that the request can go up to the internet, correct? So let me create two route tables. These are the prerequisite kind of thing. So let me click on the public route, and let me select the VPC, create route table. At the same time, let me create one more route table which we will call as private route. Private route, and let me select the VPC, demo VPC, click route, create route table. That is done. In the private route, I will do the subnet association, and I will select the private subnet here, save association. That is done. So whatever the resources I will deploy in the subnet which is called as private subnet, this one, that will the request, the inbound or outbound request will go from this route table, correct? So whatever the things I will be mentioning in this route, as of now 10.00/16, this is the CIDR of the VPC. That means any request which is coming from this VPC, that can go up to the, or any request I am making or I am making from this EC2, which we will deploy in this particular subnet, that can that can route between inside the VPC network, correct? That's the destination here. So that's the CIDR block for the VPC, and that's the destination. Your request, which is coming from the EC2, can move between these. Now let's move to the public route table, and here I will do the subnet association of the second subnet which is left in the public subnet. Save association. Till now this subnet is also a kind of private subnet only because it does not have any access to the internet. So what we will do, we will create one internet gateway here, and then in that internet gateway I will attach with the BPC and I will mark it as a route here in this public route table. So let me go there and click the internet gateway here. That I will mark as demo IGW, that's the name. Right now this internet gateway is in detached mode. That means it is not the part of any BPC, correct? So let me click on the attach BPC here, and we will select the BPC what we have created as a demo BPC. Attach internet gateway, that is attached. Now in the route tables, the public route table, here I will mention as the route. The internet gateway will be mentioned as a route, correct? So let me click on the edit route, add route, and here 0.0, that means request can go up to the internet anywhere. 0.0.0, that means anywhere. Let me select the internet gateway here, and we will select the one what we have created. So let me click on the save changes, and now if you see this subnet, the public subnet is associated with your public route table, and this public route table has association of the internet gateway as well, 0.0, correct? So whatever the request will come from the EC2 which is deployed in this subnet, that will check the role which is mentioned in the route table, and that will check that this public route table has the association of the internet gateway. That means the request coming from the EC2 within this subnet can access the internet, correct? This route table will ensure you that kind of facility can be provided. So now let's directly move to the AWS EC2 console. Here you can search the EC2, and then you can switch to EC2 console. So let me launch two EC2 instances, and that we will call as public and private. So as of now we have not created any net gateway, correct? So we will see why net will be required, that we will see. So let me directly uh, click on the launch instance, and here I will be launching two EC2 instances. So let me call the public EC2, and I'm going with the default configuration for all these things, Amazon Linux image. If you are not sure how to launch your EC2 instances, you can watch out the other videos which are available on the channel, correct? And then I'm selecting the instance type ht2.micro. Keep here I will be selecting the one what I do have earlier, and I will be utilizing the same, the public keep here. If you are not sure, you can click on the create new keep here, and you can create according to your requirement or according to your wish. Let me do the network settings. Here I will be selecting the VPC in which I have to launch the things. So I will be selecting the demo VPC. The subnet I will be selecting the public subnet because I want to launch the public EC2 machine, just the name. So I'm just making it mapping with the name, correct? The public subnet will be used for public EC2 machine. Auto assign public, yes, because we want the public IP address for this public EC2 machine. Security group, either we can create or we can select. So let me create one security group here, and I will call as public SG, and the security group description, whatever you want to mention, public SG. And then let's go with the default inbound rules only, SSH with the port 22, because we will be doing the SSH kind of stuffs only. Let's click on the launch instance, and the meanwhile it is being created, let's click on the launch instance once again, and I will launch one more EC2 instance that we will call as private EC2. The same configuration, t2.micro, the public key pair, the same network settings, the demo VPC, and the subnet, private subnet, because now we want to launch the private EC2 machine. So I will be selecting the private subnet. Why private subnet? Because we don't want any public IP address, correct? Then only we can leverage the feature of the net. So let me launch it in the private subnet. Auto assign public IP, it will be disabled because anyway it will not be assigned because we are launching it in the private subnet. So that will not populate any kind of your public IP for this particular EC2 machine. Let me create one more security group here, and that we will call as private SG. the same inbound and outbound rules. Let me just click on the launch instance. Now, meanwhile, that second one is being launched. Let's select this public EC2. Let's click on the connect, and here it will be connected. So let's wait for few seconds. The moment it is being connected, and then we will run few of the commands on this Amazon Linux server, this EC2 server, correct? So here it is connected. If you want to run any command, you will see sudo su is there. If you do the git ---- version, you will see there is no git installed on this particular server. You can see bash git command not found, correct? But this is your public EC2 machine. And when we say the public EC2 machine, that means we are saying that this is the part of your public subnet, and your public subnet is the part of your route table, correct? This public route table, and this public route table has the association of the internet gateway, correct? If you can see, this is the public subnet ID. This public subnet is the part of your route table. That one is called as public route table, and this public route table has the access of the internet, correct? If you want, if you trace back it, you see the 0.0 destination is mentioned here. That simply means it can leverage the feature of feature of the internet. So let's run one command here, and you will see whether it can leverage the feature or not. So let's do the yum install git hyphen y. Let's do, and you can see the installation has started, and within a few seconds the installation will be done. Now if you do the git ---- version, you will see it is installed, correct? So this is how your public resources, which are the part of public subnet, that can leverage the feature with the help of internet gateway. But the thing is, if you have the private subnet, so the private EC2 machine, correct, which is available. First of all, it does not have any public IPv4 address. That means if you click on the connect, you will not be able to connect from the AWS console side. If you see no public IPv4 or IPv6 address assigned, that means with no public IPv4, you can't use EC2 instance connect. Alternatively, you can try connecting EC2 using EC2 instance connect endpoint, correct? So from the AWS console, you won't be able to connect this EC2 instance. So what we will do, we will connect this private EC2 machine with the help of this public EC2 machine, correct? That's what we will see the first thing, and then we will try to run the installation command on this private EC2 machine. So what will be the required thing over here? So to connect any EC2 machine, you will require to do the SSH connection. So if you see, let me click on the connect here for the same private EC2. You can run the command ssh-i this public.pam, which we use to launch our EC2 instance. We use this public.pam, then EC2 user, and then @ IP address, which is the private IP address. So you can see here, connect to your instance using its private IP, this one. So what's the requirement over here? We will have to create this public.pam on the private EC2 machine, correct, here. And then this private EC2 machine will act as a terminal from where we can do the SSH for this private EC2 machine, correct? So I do have the content of this public.pam that I will copy on this, and we will use it. So let me go to the notepad here. I will just copy this content, Control C. Then let me go to the Google Chrome here, and here I will create one file that I will call as public.pam. The same name I will keep it. Shift enter, and then I will just paste the content. Just let me save it. And if I do the LL, you will see this. It has the only read write, correct, that kind of permission. So for that, what I will do, I will just give the chmod 600 and then the file name. And now if we do the LL, you will see read write. So I can do chmod 777. Let me give the full permission, public.pam LL. So now it can be either read, write, execute. Everything can be performed on this using this public.pam, correct? So now I will try to connect my private EC2 machine here. I will give the name public.pam, then EC2-user @ and the IP address which is available 10.0.2. Whatever it was. Yes, permission denied, so I will have to change the permission. So let me give chmod 600 and then public dot pam. Yes, let me do the ll. Let me do the same command ssh. And now if you see your public ec2 instance is connected, correct? Here you can see when we did the 10.0 to 252, you can see this ec2 instance is connected. Now it has been changed from the root, because initially we were from the root on the public subnet. Now we are, sorry, on the public ec2 machine. Now we are the part we have connected to the private ec2 machine, so it is connected with the ec2 user. Here also you can run the command sudo su, and now you are on the private ec2 machine with the root user. If you do the git -n version here, you will see no git is installed, correct? And even if you want to do the installation just like on the public ec2 machine, how we did over here, if you want to run the same command on the private ec2 machine, because now we have moved from public ec2 to private ec2, that intermediate connection we have established here, correct? If you do the yum install git -y, you will see that although it will show you that it is going to install, but it will not be installing anything because it does not have any access to the internet. So you will just see this particular message that it's trying to go to the internet, but it will never go to the internet because there is no access point. If you see in the private ec2 machine here, this private ec2 machine is the part of your private subnet, correct? As you can see, and this private subnet, as we talked earlier as well, this private subnet is the part of your private route table. This private route table does not have any access of the internet, correct? So what will be the requirement here? We will have to create the one NAT gateway that will be the part of your public subnet, and that we will mark here in the route table. So let me do one thing. Let me create one NAT gateway here. Create NAT gateway, and this one I'm just giving the name as demo-NAT. In which subnet we want to create? So we want to create it in public subnet. So your NAT should be the part of your public subnet. Elastic IP allocation, yes, we will require, because whenever you are making any request to the internet, it will require one stable IP and public IP, correct? At the same time public IP as well. So this elastic IP will give you the permanent public IP to make the connection, and so NAT, whatever the request is coming, that NAT will translate it to the public IP and then it will go to the internet. So let me click on the allocate, and one EIP has been allocated here, correct? Now let's click on the create NAT gateway. So now your NAT gateway is configured here, it is created, correct? Now let's move to the route table and go to the private route. Here in the edit routes, I will add route here that we will call as your 0.0, then NAT gateway, which NAT? Demo NAT, correct? So now your request, whatever the request you will make, that request will come to the NAT. From the NAT, it will go to the your public subnet, correct? So, and from public subnet to the internet, of course. So here your NAT is configured. Let's move to the EC2 console here, and it should, let me do the control C here. Let me again yum install git. Some error should be there. Subnet association, that your private subnet is there. Edit route NAT, edit route NAT gateway there. Let me do one thing. 0.0 shape changes, yes, seems like some issues. Let me see. Subnet association, your NAT. Okay, your NAT is still being created. It's till now it's not created, that's why we are not able to run the command. So that's the issue. So let's wait for a few seconds till the time your NAT is available, and then the same configuration what we did, that will work for sure. So let's wait for a few seconds till the moment it's being created. So let me navigate through the route tables. Meanwhile, your NAT is created, NAT gateway. So what will happen? Let's go to the PPT side meanwhile. So this is your NAT gateway, correct? So NAT gateway will allow you to go to the internet. As you can see from the diagram, whenever we have to create any net, that will be the part of your any of the public subnet, and that NAT will help you to forward the request to the internet gateway, correct? And this then this internet gateway will send your request to the internet, real internet, from where you will do the installation of software. Let me move to the AWS console here, and let's see whether it's ready or not. So now it's available, correct? Let me do here. Okay, you can see as soon as we did the installation, it has been installed on the private subnet as well. So now if you do the git hyphen version, you will see it's installed on the private subnet, correct? Now if I run any command to install other software, yum install hyphen python, just a point, python I want to install, hyphen y, it's started installing, installed. So let me check the python version as well. Python is installed. So what happened, the moment your net gets ready here, a state is available, and at the same time you have configured this net into your private route as well, that whatever the request which will be coming from this private subnet, correct? Your private EC2 instance is the part of this private subnet. So whatever the request will come from private EC2 to this private subnet, and this private subnet has the rule configured as that whatever the request will be coming, that can go from the net, using the net it can go up to the 00 destination. How this net will ensure the internet gateway? Because this net is the part of your public subnet, correct? This net is deployed in the public subnet, and this public subnet is, of course, it's the part of your public route, which is the having the access of the internet with the 00 and the internet gateway, correct? So that's how your private resources, which are the part of your private subnet, can access the internet using the using the NAT gateway. But not a single request can come from the outside to the inside up to your private resources, correct? So that's what the demo part we wanted to cover, and that's the concept what I wanted to cover in this particular video. Let's meet in the next video with the new content and with the new topic altogether. Moving forward, we'll be talking about your security group, and then we'll be talking about the different scenarios of the security groups and other stuffs, correct? So till the moment, thank you, bye bye, and stay tuned. Subscribe to channel to get the more technical contents. Till the time, thank you, bye bye. Welcome to day 17, where we are learning about the AWS tutorial, and at the same time we are also learning about the DevOps journey. So in this particular video, we'll be talking about the security group and NSCL. These are the kind of inbound and outbound roles that we'll be talking in details. So what all we have covered till now before the security group and NSCL, we have covered how to set up your AWS account, why cloud came into the picture, what were the challenges before the cloud, and why like how cloud solved your problems, the existing problems, correct? And specifically we have talked about the AWS EC2 instances, the different types of the EC2 instances, the different classes, the different families. We have talked about the user data, we have talked about elastic block storage, the different kind of IP addresses, private IP, elastic IP, or public IP. We have also talked about the launch template, auto scaling group, your load balancers, the different kind of load balancers, how to do path-based routing, and target groups. All these things we have covered till now. We have also covered VPCs, subnets, the private subnets, public subnet. We have also covered internet gateway and NAT gateway till this point. If you have not watched all this video and you want to get the knowledge of that, you can go back to the channel. You can start from the day 1 and you can come up to day 16, correct? And then in the day 17 we will be talking about security group versus NSCL. So what are the difference between these two, and what's the definition of these two, correct? So at the same time you can subscribe as well. So let's start with the security group, and then we will come to the NSCL part. So security group, if you remember the day, the class where we talked about the BPC, with the example we were talking about that NSCL exists at some point as a guard, and security group exists at the instance level as a guard. So even you can see the same picture over here as well. This is the bigger blockage of the VPC. Then inside this bigger block of the VPC, there is a block for the subnet. You can see that, correct? And within this subnet, there are two rectangular kind of block. The you can consider it as a chip. This is EC2 instance, or you can say the virtual server of the AWS Cloud, correct? So now if you see on the BPC level, there is internet gateway associated. This internet gateway is associated on the BPC level. That means it will allow that whatever the request is coming from the inside, that can go up to the internet and it can communicate. And at the same time, whatever the request is coming out from the outside, and that has to that is coming from the internet, correct? When we say the outside, that means the internet. So that request can go up to the resource. Correct. So that kind of facility internet gateway will provide, which is on the VPC level. We are just seeing the attachment where it is attached. Correct. Then if you see on the subnet level, there is a NSCL block. That means NSCL will check whatever the request is coming from the outside within the VPC as well. Correct. Is that request is allowed to get into this subnet or not? If it's allowed, NSCL will pass. Otherwise, it will block at the NSCL level here as well. This is one guard here. If NSCL allows and the request comes up to the subnet, then there is a security group before the EC2 instances. These two blocks are the EC2 instances, as you can see from my cursor as well. Then the security group will check whether the request which is allowed from the NSCL is allowed from me as well or not. If it is allowed, it will go to the EC2 instances. If it is not allowed, it will be blocked here only. And it can be for both the security groups, correct? Both the security group will evaluate, and based on that, it can go up to this EC2 instance or the first EC2 instance. But it has to be passed, correct? So if you see, after the BPC on the subnet level, NSCL works, which checks for the real rules, inbound rules and outbound rules. Then security group is there, which checks for the rules, inbound and outbounds both. Then your request comes to the server. Now let's move from this picture and let's go through the points as well. A security group acts as a virtual firewall for EC2 instances. So it's a kind of firewall or kind of guard, you can say, which checks for the traffic which is coming or which is going outside. By default, a security group denies all inbound traffic and allow all outbound traffic. What does that mean? That means in this security group, we define two kinds of rules. Inbound, that means which kind of request can come to this server, and outbound, that means which kind of request can go outside this server. Correct. So by default, security group allow all the requests to go outside. That means whatever the request EC2 instance will make, that is by default allowed to go outside. That can transverse between this BPC, or even internet gateway is associated, it can go outside as well if this is a public subnet, correct? When we say the public subnet, you should remember that we are talking about the route table having the internet gateway access, the route table in which this subnet is associated, correct? So if you are not understanding this, you can watch out the previous video where we have talked about the net gateway, route table, subnets and other stuffs, correct? So if my subnet is public subnet, it can go up to the internet. So by default, all the requests are allowed to go outside. But while at the same time, if you don't explicitly mention anything, no request can come to this server. That is the by default configuration. So you will have to explicitly mention all the things which kind of request can come to this server. Then next point is, you can modify the rules for a security group at any time. That we mentioned that you can modify inbound and outbound both the rules. One security group can be attached to many instances, vice versa. What does that mean? This single security group can be attached to this instance as well, to this instance as well, or to multiple instances as well. So this is what it is telling. One security group can be attached to many instances and vice versa. Let's get into the details. So I do have the examples of the security group, and after a few slides, I will directly move to the NSCL block. So in the security group, as you can see, EC2 security group and the Google, and the this is the picture of the your system, correct? So if you see, the request will come to this TCP, SSH, HTTP protocol, and the EC2 security group is there, which will check and it will pass it to go to the internet. That is the Google symbol, correct? Security groups are most basic, native, and important firewall. Security group has inbound and outbound rules both. Why we are highlighting this? Because we will be talking about the NSCL as well, and you will have to understand the concept there as well. So just remember, security group has inbound and outbound rules. That means it defines both which kind of request can come inside, which kind of request can go outside. Both the rules are defined here. Security graph has only allow rules, does not support deny block rules. Where why we are talking about this as well? Because in NSCL it differs. Correct? So you just remember security group has only allow rules. So whatever the rules you are mentioning, it has only one type for the security group. It has only one type. What does that mean? That means you can only write the rules which kind of request, which kind of rule traffic can be allowed. You cannot mention anything that which kind of request can be denied. So security group only supports allow. Correct? The default security group in each VPC, yet it is already created. Whenever you launch your AWS account, it comes with your one default VPC, default security group, and all other default stuffs. Correct? Authorized traffic for both IPv4 and IPv6 traffic. You can reference another security group as a source. So while mentioning the port and other details, you can mention the same security group as a source into another security group. Correct. Let's go into the detail. So here if you can see in bound rules, TCP protocol is mentioned. So that is allowed. It can come. But in the outbound rules, nothing is mentioned. Correct. But if nothing is mentioned, so that means all is allowed. So return traffic is allowed. Correct. It can go back to the VPC. Outbound rules is allowed. Correct. Let's move to the next topic. Sorry, next PPT. Inbound rules, nothing is mentioned. No request can come from 1 2 3 4. In the last picture it was mentioned 1 2 3 4. That's why request was coming, and return was outbound is already allowed, so it was allowed. In this next video, sorry, in the next slide, there is no inbound, that means no request is coming, but outbound is allowed because it is mentioned TCP 8000. Similarly, in the next picture, inbound 2345 is the system IP address, while in the inbound it is mentioned 1234 as a source. Correct. So this request cannot go up to the EC2. Why? Because this is not allowed here. 1234 is allowed, while the system has 2345 IP address. So no request can go there. In the similar way, if 2345 is mentioned, the request can go up to there. It can come up to the system, but it cannot go to the internet or somewhere else, because in outbound there is nothing mentioned. Correct. In the similar way, you can mention the security group from one EC2 to another EC2. If you can see in the EC2A inbound rules, nothing is mentioned. In EC2A outbound rules, it is mentioned that this EC2 instance can send the traffic to the second server 5678 up to this destination. So if you can see, this is making a request, TCP request, that is coming to your second server. While for the second server security group, it is mentioned that this second server can accept the 1234 rule, the traffic from 1234. Correct. So it can accept the traffic from 1234. Correct. So this is allowed. EC2 to EC2 communication, this can make a request that can go there, and then this can make the request to go from here. Correct. Now let's move to the second other PPT of this block. Allow all traffic from within the VPC. So here you can see within the VPC, there is a one EC2 instance which is part of private subnet. So in this the security group which is associated with this EC2 instance, it can be allowed that no request can come from the outside, while the request can come from the inside within the VPC. So what is mentioned here? All traffic, all port, while the destination is the source is 10.0.0/16. In the outbound, the destination is 10.00/16. This is the CIDR for your VPC. That means whatever the request is coming within the VPC from any of the EC2s, from anywhere in the subnet, from any of the AWS services, that can be allowed to this EC2. And the same, this EC2 can make the request to go anywhere within the VPC. That's your destination as well. Correct. So this is how your security group works. Now let's directly move to your NACL block here. This is the default security group you can see in the picture itself. Correct. Now let's move to the NACL block here. A virtual firewall that controls inbound and outbound traffic at the subnet level. By default, your account's default NACL allow inbound and outbound traffic. It allows all, but you can modify it by adding your own rules. What does that mean? Initially, NACL does not support or does not block anything. It allows everything. Correct. So you can see the internet gateway, then NACL, then public subnet, and security group. Example, passport control officer as a network in NACL. Just leave this. You can directly understand from the picture itself. Let's get into the picture, other PPTs. Network access control list NACL. works at a subnet level, hence automatically applied to all instances, contains both allow and deny rules. So if you remember in the security group here, while we were explaining the security group, we talked about that security group only has allow rules, correct? It does not support deny or block rules. While when we talk about the NSCL, we say that it all keeps both allow and deny rules. The rules are numbered. So if you can see here, 100, 102. So this kind of rule number you will see, and it supports allow and deny both kind of rules. So when we say the deny, that means this the request which is coming from this source 180.151, that will be blocked. It will not be accepted. So now let's see. Rules are evaluated in the order of rule number. So first 100 will be evaluated, then 101 will be evaluated, and then 102. Statelets, we need to explicitly open ports for return traffic. What does that mean? This is one of the major point. So when you define security groups, whatever the request you mention in the security group that this request should come, correct? That will be by default allowed. So if you are not understanding this, let me go back here. So you have mentioned in the inbound that 1, 2, 3, 4. This request can come from here. At the same time, security group has that stateful kind of feature. That means whatever the request you will make as inbound, that will be by default outbound. So it automatically remembers that whatever the request is coming from a source, that the request can be sent back to that particular source or to that particular destination, correct? So this request can the whatever we mention in the inbound, that will be by default allowed, correct? While NSCL does not support in this behavior. NSCL you have to explicitly mention that which request can come inside and which kind of request can go outside. So the same thing you have to mention multiple times in NSCL, correct? So this feature is called stateless as well. So stateless, we need to explicitly open ports for return traffic as well. Default NSCL allow all inbound and outbound traffic. Let's move to the picture here. Here you can see in the inbound rules, 100th rule TCP port 80 1234, that is the port the IP address of your system. It is allowed. So the request is coming from here and it is allowed, correct? It is going outside as well. Out in the outbound also you have mentioned that this from this port 1234 up to this destination it can go. If you don't mention it, it cannot go, correct? That what does that we talked. So that you have to explicitly mention allow in both inbound and outbound both. So it is mentioned, that's why the request is going outside. Now let's further move to the next. Here you can see the request is allowed from 1 to 3 4, while it is not allowed from this port to, 9 10 9 this IP address 9 10 11 12. So it is blocked here only, correct? And here also you mentioned all traffic is blocked from the internet as well, correct? So this is also blocked. Now in the outbound, all requests which should go up to the internet, that is also blocked, and that 1 2 3 4 is also blocked. So no request can go and no request can come from this 9 10 11 12. Now let's moving forward. Let's see one or two picture as well. Here in the 112 9 10 11 12 is mentioned now. So the request can go up to the EC2 instance, while we have not defined that same source 9 10 11 12, that the request can go up to this destination, that is not mentioned here. So now you can see the request has come to this particular point up to the EC2 instances, but it cannot go back, correct? You can see the request is coming up to the NSCL and it is blocked here. It is red symbol. It is blocked up to the NSCL. It cannot go up to the system once again, correct? So you have to explicitly mention both the things. In the similar way, we have the other examples as well, like how you can allow, how you can deny. So here if you see 9 10 11 is allowed, 9 10 11 is allowed in outbound as well. So the request is coming and going outside as well. In the similar way, here if you see 0 0 is allowed and denied as well. So the requests are evaluated, a star is there, so nothing is coming, nothing is going outside. Now let's see the difference between these two, security group versus an SCL. Let's summarize this, correct? Security group operates at EC2 instance for our ENI level, elastic network interface, while NSCL operates at subnet level. It's the security group supports only allow rules, while NSCL supports both allow and deny rules. Security group is stateful, return traffic is allowed by default. Whatever you mentioned in the inbound, that is automatically returned, correct? While NSCL stateless, return traffic needs to be authorized in outbound rules as well. That means you have to explicitly mention in outbound as well. Security group, all rules are evaluated before making a decision. That means you have mentioned 5 rules, so all 5 will be evaluated at one time, and then it will be either allowed or denied. Correct. In NACL, rules are evaluated in the order lower to higher, and first matching rule is applied. So for the 1, 2, 3, 4, if we have mentioned initially that this will be denied, 1, 2, 3, 4 request will be denied, and later on after 5 rules you mentioned that 1, 2, 3, 4 will be allowed as well. So it will be denied first, because the first rule will be applied there. So this is what it is mentioning. Rules are evaluated in the order lower to higher, and first matching rule is applied. So in this particular video, we just wanted to talk about this security group and NSCL in detail, and we have covered the comparison part as well for the security group versus NSCL. In the moving video, we will be talking about in detail subnet, route table, internet gateway, and other features. We will be talking about the route table. So till the time, thank you, bye bye, and let's meet in the next video. And till the time, you can subscribe, you can watch out the other contents which are available on the channel related to AWS Cloud, related to your CI/CD, related to your Terraform, and other stuffs related to your Linux as well. Even you can prepare your interview, because we have covered most the real interview questions which I have gone through, and I used to ask. So that kind of interview questions I have covered on the channel. Even you can subscribe, and you can watch out those content as well. So till the time, thank you, bye bye. Welcome to day 18, and in this particular video we are going to talk about the route table. Till now we have covered the AWS EC2 instances, AWS load balancers, the different kind of load balancer, the VPC, subnets, NAT gateway, internet gateway, and security groups, NSCL. All these we have covered till now. How to set up your free AWS account, how to launch your first AWS EC2 instance. Everything is covered. The basics of the cloud, everything is covered on the channel. So you can start from the day 1 up and you can come up to day 17. In this particular video, we are going to cover about the route table. So route table is a table which contains all the rules that how your uh, traffic will flow within the VPC, between the VPC, and through the VPN as well. Correct. So whatever the destination source you want to mention, that all you can mention within the route table itself, and that will decide how your network or how your traffic which is coming from the outside or from somewhere from one of the EC2 instances will transverse between the different VPCs within inside the VPC, or even from outside the VPC. Correct. So that route table will decide. So let's go from the point to point. What is route table? So it contains rules to route the traffic in or out of subnets. So subnet is the part of VPC. Correct. Every resource lies in the subnets. Either you deliver your Lambda function, either you deploy your database RDS instances, or the different EC2 instances. Correct. So most of the AWS services, if we are going through the networking, that will lie within the route within the subnets. So this route table defines the route the traffic in or out of subnet. That means which kind of request can come inside the subnet and which kind of request can go to the subnet. Correct. So that kind of routing will happen through the route table. Main route table at VPC level. So at a VPC level, whenever you create a VPC, you will see there will be one main route table that we will see on the AWS console side as well. I will show you that as well. And whenever you launch your one AWS account, you will get one VPC, default VPC in each region, and you will also get one default main route table in region. Custom route table at subnet level. But other than the VPC, you even can create one custom route table for your subnets as well, for subnet A, subnet B. If you have seen my previous video, when I was talking about the VPC and the NAT, we had created different route table for the different subnets. Correct. If you have not watched, you can watch out that as well. Each route table contains default immutable local route for VPC. So whenever you create a route table, it will be having default route. Correct. That will be having the all the request can all the request can route or can be distributed between the VPC. That local route will always be available there. If no custom route table is defined, the new subnets are associated with the main route table, which is up to your VPC level. Correct. We can also modify the main route table. Yes, there is a option of edit records, and you can change the routing there as well. So let me go to the AWS console, and here you can search about the AWS VPC service. And within this VPC service, you will see there is a one route table which is already created. So you will see on the AWS console side, you will see one default VPC which is already there, this VPC, and at the same time you will also see one route table, this route table, correct? This is the main route table. Yes, if you see the property, is it main? Yes, it is main route table, correct? Yes, marked route table ID. And there you will see one internet gateway is associated. It was created by default. The VPC is created by default itself when we launched the AWS account itself. You will see 000 as a destination attached with the internet gateway. That means any of the subnet which is associated here, and that subnet has some resources. If that particular resource, just suppose one of the EC2 instances associated with the subnet which is here, and this subnet is the part of this route table, correct? And this route has the definition of getting access up to the internet, correct? With the help of IGW, internet gateway, it can go up to the 00 destination. That means anywhere, that means up to the internet, correct? So that request can go up to the internet. So that's the route defined here. And the local route is also defined here, 172.31.00/16. That is your CIDR of the VPC, 172.31.00/16, correct? So you can see the local route, that's what the point we covered, correct? This one, if no custom route table is defined, sorry, each route table contains default immutable local route for VPC. So that's the point. You can see the default local route for the VPC, it is already there in the route table. So this is how. And if you want to edit anything, you can click on the edit routes. You can add any route here. Just suppose it if I want to 00, correct? I want to NAT gateway, so I will have to create one NAT gateway, and I can attach over here. So if you want to attach any instance, so you can mention the instance ID, AWS EC2 instance ID, correct? So if you want to do, we will say peering, so you can create a peering request, and that peering request will come here, correct, as a pop-up that you can mention. And you can mention the CIDR of the second VPC, correct? So you can modify the route tables, you can create the route tables, you can create the different custom route table. This is the main route table, correct? So just suppose that if I want to create any other route table, so I will just call as demo route, and I will select the default VPC only. I'm not going to create any VPC, and you will just create route table, correct? I have created demo route. You will see that local routing for the VPC has already come. Then you can create subnet, and you can associate your subnets here as well, correct? If you want to subnet, associate any subnet, I can just click on any of the subnet, just subnet association is done, correct? So this is how you can create your custom route table. You can associate subnet, you can define routes here from here, correct? You can add any like 00, I'm just saying, and then internet gateway I can attach over here as well. Let me select the IGW which is already available, correct? So this is the route table. Now if you see here, this is not the main route table. The first one was main route table. The route table what I created is the demo route, correct? That is not the main route table. So this exists on the VPC level, but this one exists on the subnet level, correct? This is not the main route table. So this is the definition of the main route table. This is the definition of the route table, where where it tells that how your traffic will be distributed, how your traffic will flow between the VPC and across the VPN as well. So here you can see in the destination it is mentioned 10.10.0.0/16 from the local. So this is the VPC level, correct? That means instances can make the communication between these two, because your traffic can go between this inside this VPC. That is your destination, correct? Now moving forward, you can see it can go up to the internet as well, 10.10.0/16, that means local. So it can go up to the VPC, any request made from anywhere, and even it can go up to the 000 as well, that means internet gateway. So if you see the EC2 instances which are making the request, then can go up to the internet over here as well. In the next PPT you will see 10.10. So for this subnet A, that means this for this subnet, it can go up to the VPC level. That means it can make the request up to the VPC level. Even it can go for the your internet gateway as well. That is also mentioned for the subnet A route table. While for the subnet B route table, it can go up to the your VPC only. It cannot go beyond the VPC. So if you see, if it's try to connect with the your internet gateway, that is cross marked. Why is that there? That means that is clearly because it is not mentioned in your route table. So that's the difference or that's the property how route table routes your traffic between the subnets, between the VPCs, between the VPNs. Correct. So this is all what I wanted to cover the route table specifically in this particular video. In next video, we will be talking about the VPC connectivity option, VPC endpoints, VPC peering connection, transit gateway, and all other stuffs I will be covering in the next video. So till the time, thank you. Bye bye. Welcome to day 19, and in this particular video we are going to talk about how to connect your EC2 instance with the S3. That means how your virtual server will access the S3 bucket. Correct. Why we are covering this particular topic? Because we want to understand the VPC endpoint as well. And when we will talk about the VPC endpoint, the concept what we will cover, how VPC endpoint will help you to access your S3 buckets from EC2 instances. Correct. That we will see. So before jumping directly on the VPC endpoint, we will see how you can connect your public EC2 machine with the S3. Correct. And then we will come to the VPC endpoint. So in this short video, I will just cover how to connect your AWS EC2 instance with the S3, and in the next video, the long video, I will be covering the VPC endpoint in depth. So let's directly move to the AWS console because we don't want to waste any time on other things. So let's directly move to the AWS console, and we will create one EC2 machine, and we will create a S3 bucket, and we'll see the connection between these two. So let me go to the console here. Here I have already created VPC here. So what all the things we do have? So I do have one demo VPC. With this demo VPC, I have created one internet gateway, and I have already associated. I have created one route table here, public route table. In the public route table, I do have the internet gateway association. I have the the subnet association. Subnet I have created called as a public subnet. Now the networking part is done. I have to create one EC2 instance here. So now I will be launching one public EC2 instance here. So let me launch a public EC2 instance that will be called as public EC2. Let me select the Amazon Linux AMI only, the default one. If you are not aware how I am going with this in a very fast speed, you can watch out the videos which are available on the channel, how to launch your first VPC, how to launch your EC2 instances, and the route tables and other stuffs. Correct. Here we are focused on connecting your AWS EC2 with the S3. So public EC2 I have created, Amazon Linux as a AMI, then t2.micro as an instance, and the keep here I will be selecting the public one what I am using every time. Sorry. In the networking part, I will be creating within this VPC, demo VPC, what I have created, public subnet only, and the public IP I will enable because I want to create one public EC2 instance. Correct. So security group, let me create one. This one I will call as public SG. Description also I will keep the same, public SG, and the port 22 protocol TCP and type SSH is okay for me for now. Let's directly click on the launch instance, and your EC2 instance will be launched with the public IP. Why the public IP is required? Public IP is required to connect it with the AWS console or even to do the SSH. Correct. So let me click on the connect. Let's click on the finally connect. So this is the AWS console through which we are trying to connect. It will take a few seconds till the moment it will be ready to connect. That's why it's not connected yet. So let's wait for a few seconds, and it will be allowed to connect. Let me refresh it again. And the moment it will be okay, yes, it is ready, and now we can use it. So let me run the command sudo su. Let's go with the sudo permission, the root user. So we have connected this AWS EC2 instance, and now if I run this AWS S3 ls command to list down my buckets, it will not be able to list down any bucket. Correct. Unable to locate credentials. So you can configure credential by running AWS configure. So let's try one alternate way to connect your AWS EC2 AWS S3 bucket with the help of EC2, and we will see the alternate way as well. So let me search for the IAM role here. IAM, identity access and management. So from here you can control which service can access which of the other AWS services, or what kind of permissions you can give to the different users, to the different roles, to the different groups. Correct. So I'll be creating one role here, and I think I already have that role, demo role, called as with the S3 full access. I should have, yes. So I have already created one role that is called as demo role, and permission I have already attached, which has the Amazon S3 full access, S3 star, S3 object Lambda. Correct. So I'll be attaching this role, demo role, with my AWS EC2 instance, correct? And then your EC2 will be able to access. So now let's come to the AWS console here. Click on the security, click on the modify IAM role, and here you can select your demo role, correct? So it's already there. Let me do the update IAM role, correct? So your EC2 instance now is associated with the demo role, and this demo role has the permission of accessing S3, correct? Now if I want to run AWS S3 ls over this command here, this one is terminated actually, so let's go here. So if you want to run the same command AWS S3 ls, now it will not result in any error, unable to look at credential. It does not result into the same. Why? Because now this EC2 instance has the access to S3 buckets. If I create any S3 bucket, or if I run any command here, AWS S3 and MB, then S3 colon double forward slash and the bucket name, I will keep it as and demo -1. Bucket name man demo -1 should be created on the S3 side. So let me search for that as well. Let's get into the S3. This was actually the command to create your bucket in the S3, AWS S3, and the MB, that means make bucket, and the bucket in which service, S3 colon // and the name of the bucket. So this is the unique name you have to provide. Let's move to the AWS S3 console here. You can see man demo 1 is created. When it was created, 23rd of Feb 2025 17:30. It's the time duration when I am recording this video, correct? So your demo bucket has been created. If I want to run one more command to create one more bucket, you can see man demo 2, I just want to create, that should also be created. Let me refresh it here. You will see the second bucket has already been created, correct? So with the help of command. So this is one of the way through which you can attach your IAM role and you can access your S3 buckets. Now let me remove this IAM role. I don't want this IAM role to be there, and I want second stuff to be there. So let me click update as no IAM role. Let me mark here detached. Correct. Now if I want to run the AWS S3 ls, again it will result into an error, correct? Let me do the AWS S3 ls. Unable to look at credential, you can configure credential by running AWS configure. So that was the one way you can attach one IAM role to your AWS EC2 instances, and you can give the permission that then it will be allowed to connect with your S3 service. The second option is to connect your AWS EC2 instance with the S3 bucket. You can run the AWS configure command here. When you will run the AWS configure command, it will ask for the access key, secret access key ID, correct? So for that, we will have to create one user here. So let me create one user, and that user I will call it S3 user. So let me call it S3 user. Provide user access to the AWS management console, no. Add user to group, attach policies directly. So I am attaching directly one policy, S3 full access, Amazon S3 full access. Click on the next, create user. And when we create the user, S3 user, you will see one credential should be there. So security credentials, assign, console sign in, access key. So let me create access key. What's the uses? CLI. You plan to use this access to enable AWS CLI to you access your AWS account, correct? So or for the local code development, so let's see the local code development. I understand. Let me click on the next. Description demo. I'm just keeping that description as demo. Your access key is created, your secret access key is also created. So let me copy it, the secret access key, and I will paste it over here so that we can use it for the secret access key. And then let me move directly to the access key as well. Access key will be there while secret key access key can be viewed only once, correct? So I'm just copying it. Let's directly move to the AWS console here, sorry, AWS EC2 console. Let's run the AWS configure command here. AWS configure. It will ask for the access key. Let me copy it from here, create access key. Copy it from here. I will just pass it. Then secret access key. Let me copy from here only. Secret access key, copied. Let me pass it. The default region name. Sorry, AP South 1 I will put as AP South -1. The default output format JSON. Your credential is configured, correct? Now if I want to run AWS S3 LS, again it can list down the buckets without any error. Correct, you can see. So AWS S3 LS has given you the access to your, like, what we did AWS configure, we ran that this command. It asked for the access key, secret access key, and the region. Correct. So with the help of access key, secret access key, now it is able to connect with your AWS console, AWS account ID, and from there you can run, it can grab the other AWS services which are available in this particular account. Correct. So when I run that AWS S3 LS command, it has fetched all the bucket which are available in this region, because we gave the region AP South 1 as well. Correct. So it fetched the buckets which are available in this region as well. Correct. If I want to create one more bucket here, you can do the same thing. AWS S3 MB S3 colon double forward slash man demo, and let's create the third bucket as well, man demo -3. It will create make bucket demo 3. Correct. So let's refresh here as well. You will see third bucket will also be created. So this is how the alternate way are available for you. With the help of that, you can create, you can make the connection from your EC2 to S3 in a different way. Either you can attach one IAM role, you can give the permission, or you can create your config file here. Correct. You can run the AWS configure command. You can pass the access key, secret access key, and you can access the AWS S3 bucket. So this is what I wanted to cover in this particular video before moving to the VPC endpoint. And in the next video, we are going to cover the VPC endpoint, where we will try to connect your private EC2 instance with the AWS S3 bucket. Till now, this was your public EC2 instance, correct? Because it has the public IP address as well. If you see, the public IP before address was there. So in the next video, while talking about the VPC endpoint, we will create one private EC2 instance, and we will see how VPC endpoint will help you to make the connection, correct? So for this particular video, you can watch out from the scratch, and till the time, thank you, and stay tuned with the channel. Do subscribe so that I can provide more content to you in as a free content. So till the time, thank you. Bye bye. Welcome to day 20, where we will be talking about the VPC endpoint. So in day 19, what we had covered this particular specific use case, where we saw that how to connect your AWS EC2 instance with S3, and there were two options to connect this. Correct. So one option was, we had created one public EC2 machine with the internet gateway attached in subnet, like it has the route tables where AGW was configured. Then we created config file over there, and with the help of the config file, we were able to connect with the S3 bucket. So we passed the access key, secret access key, and other stuff. After that, there was alternate solution as well. We had one EC2 machine, which was the public EC2 machine. We attached one IAM role, and to that IAM role, we gave the permission of S3 full access, and we were able to run the AWS S3 LS command. We were able to connect with the S3 buckets. Correct. So there were two ways to connect your EC2 instance, public EC2 instance, public EC2 instance. This one you have to notice. Public EC2 instance, we were able to connect with the help of IGW and the IAM roles, with the help of configuration, and with the help of permission of the S3. Correct. So there were two ways. Now we will be seeing how to connect your private EC2 machine with the S3 buckets. Correct. So you have to establish the communication or the networking from your server, virtual server, that is your private EC2 machine, to AWS S3 buckets, which are the other AWS services. Correct. So we have to establish the networking from EC2 to S3. You can give any kind of permission, but you have to make it private only. You don't have to go up to the internet. So internet gateway will not come anywhere in the picture. Your NAT gateway will not come anywhere in the picture. So what we will see now, we will access S3 from private EC2 without internet and without NAT. We will create one VPC, two public subnet, with one subnet will be having association with the IGW. Why we will create public subnet and one public EC2 machine? To use it as a bastion server, because when we will be creating your private EC2 machine, that private EC2 machine we will try to connect from somewhere. We will do the SSH. Correct. Because then only we will be able to run your AWS S3 LS command on private server. So for that, we will create one public EC2 machine. So let's directly move to the AWS console. There we will be you will understand in a better way. Correct. So what we are going to do, creation of private EC2 machine, and then making private connection with the S3 buckets. So let's directly move there. AWS console we have come up. Here what I have covered or what I have created already, I have created one VPC, demo VPC. I have two subnets here, private subnet and public subnet. In public subnet, I have the route table defined. In the route table, I have this IGW associated only. Correct? Route table you can see. There are public route and private route. In the public, I have already IGW associated. In the private route, I have only local route. Correct? Local route. And then this one I will be removing it. Edit routes. Let me remove this. Sorry. Let me cancel. Let me click on the edit routes. Local. No propagated. Okay, this one I will have to remove. So I will have to delete this endpoint what I have already created. So let me remove this demo endpoint. Delete. I will create it for you from the scratch. Now let me go to the private route here. Just let's refresh here. You will see only one route, local, correct? So there is no endpoint till now. So I do have this private route and public route. Now we will be launching one public EC2 machine that I have already covered to save the time. Public EC2 we have, and with the help of this public EC2 we will be connecting our private EC2. So now let's directly create our private EC2 instance. Let's click the launch. This one I will be called as private. I will be calling as private server. Private server. The same configuration what we used to create every time. The Amazon Linux AMI, the T2.micro instance, and the other networking stuffs we used to keep the same one, correct, every time. So I'm going with the same one. If you are not aware about how to launch your EC2 instance, how to launch your route tables, how to launch your subnet, how to launch your VPC, you can watch out the other videos which are available before this, correct. And then you can come directly here. It will be more easy for you to understand. So I'm selecting the key pair as public key pair. Click on the edit net VPC. I will be selecting the demo VPC where I am trying to create. I'm trying to create private server, so I will be going with the private subnet only. Correct. So I have created private subnet. Then this is if even if I enable, this is of no use because I am creating my resource private EC2 instance in private subnet. So there will not be any public IP address. So let's go with this. Disable security group. I will be selecting one the private SG what I have already created. So it does not have anything other specific other than the port 22, and with the help of this I can do the SSH, correct. So I'm just clicking on the launch instance, and our instance is ready to our instance has been already launched, correct. Our instance is already launched. Now I will connect this public EC2 machine. Click on connect. It will be connected within a second, correct. And then we will it is already connected, correct. Here if you see I have already created this file. If you see public.pym I have already created. This kpair is nothing but this kpair is for this particular EC2 machine, public.pym, correct. This kpair is assigned at launch with this private server. So I have already created this public.pym, and the content of this public.pym file is here. I have already created it on the console side so that we can save the time. So what I will do, I will now connect my private EC2 machine ssh-i, then the key pair name public.pym, then EC2-user and the IP address of your private server, this one, correct. With the help of this private IP, now you will be able to connect your private server as well, because it does not have any public IP address. That's why we have to use the public server. So right now we are on the public EC2 machine. From this public EC2 machine we want to connect our private server. So if you see 10.0.132, this is the IP address of public one. Now we are trying to move to 10.02.218. Let's do the enter. I will do the yes, and you have been connected to the private server 10.0.2.218. This is the private server IP address, correct. Even you can see from here as well. So we have connected to this private server. If I run the AWS S3 ls command over this private server, you will see it will result into unable to locate containers. Let me do one more thing here. I will give the access to this S3 bucket, to this private EC2 machine. I will click on the actions. I will get into the security. I will click on the modify IAM role. I will attach this demo role. What does this demo role have? Let me open the IAM role here. Click on the IAM. And I will go to the demo role. You will see that demo role has the permission of accessing S3 bucket. This is the demo role. I have already created to save the time. Amazon S3 full access. It has the access to it has the permission to access your S3 bucket, S3 colon star, correct. What does that mean? If I attach this role to AWS EC2 instance, that means your EC2 instance will have access to communicate with your S3 buckets. It has the permission. We have not established the networking here, but it has the permission right now, correct. So let me click on the update IAM role. If I run the same command once again here, AWS S3 ls, now you will see it does not say unable to locate credentials. You can configure credentials, correct. Now it has the permission to communicate with your S3, correct. It is not it is not denied at the initial level that you does not have permission to connect with S3. Now it has the permission to connect with S3. We have already given the permission, but there is no networking established here. So now your VPC endpoint will come in the picture, where from where we will allow this communication to happen in actual. So let me do the control C. We will break the command here. Let me move to the VPC console here. Let me click on the endpoint here, the one what I deleted before. So I will create as demo endpoint AWS service we want to connect, correct. Connect to service provided by Amazon with an interface endpoint or a gateway endpoint. I will be selecting this S3 here because we have to connect with S3 bucket. Gateway type we will be selecting here because we have to connect our S3 bucket. In which VPC we have this private server? We have this private server in the demo VPC. So I'm selecting this demo VPC. In which route table our subnet belongs, the subnet in which our private EC2 instance is there, that is the part of our private EC2 is the part of private subnet, and from private subnet we want to connect our S3 bucket. So private subnet that is associated with your private route. So we will be selecting the private route table here. Let's click on the create endpoint. Endpoint is created. Now if you see in the private route, you will see one entry will be happen here. Click on the refresh button and you should see one of the entries. So one of the entry has been automatically created here when we created the VPC endpoint. You saw that, correct. There was a route table association as well while creating the VPC endpoint. Now if you run the AWS S3 ls command here, you will not see any error. What does that mean? We have already given the permission. With the help of that, it removed that error. That means it has the permission to access the S3 buckets, but it was not able to do because there was no communication, though there were no bridge established between the EC2 to S3. Although your EC2, which is at one part of your bridge, it had the access to get to the S3, but it had the license, but there were no flight, there were no bridge to go over there, correct. So your VPC endpoint creates a bridge or a flight kind of thing, you can think of in that way, and it established that it just filled the bridge gap, correct. And now your EC2 is able to make the communication with S3. So here I will just try to create one bucket. So if you see, let me search for the AWS S3 service as well. Right now you will see there is no bucket, general purpose bucket, there is no bucket, correct. Let me go there and I will be creating one bucket here. AWS S3 MB is used for make bucket, S3 colon // and the bucket name we will give as demo -1 MQN. So anything, any unique name you have to pass, correct. So let's refresh here and you will see that bucket has been created. Let me go to the buckets. Where is the bucket? General purpose buckets. MQN demo 1 anything with the random name what we given. So if I want to create one more bucket, so I will just give a better name here. So I will just call as Manish demo -1, correct. It is also created. Let me refresh over here and you will see that second bucket is also created. So now your VPC endpoint has come into the picture. This endpoints that what we have created, this VPC endpoint act as a gateway, and it has established the communication from VPC to AWS S3 bucket, correct. So this let's understand from the picture perspective as well how this works, correct. This is the VPC endpoints. So here you have the private subnet. In the private subnet you have the private EC2 machine. There was other way that you can create NAT gateway. That NAT gateway will go to the internet and it will help you to communicate with S3 buckets. While in the VPC endpoint, what we are doing from the private EC2 machine, we are making the request to the BPC endpoint, and this BPC endpoint is going up to the S3 bucket. So this one is working in the BPC endpoint, correct? Private to S3 with the help of your BPC endpoint. So this is what the use case of BPC endpoint. This is what we wanted to tell you, and thank you for watching this particular video. Stay tuned, subscribe to the channel, and we will meet in the next video with the next another topic. Probably we will be covering BPC peering connection. So till the time, thank you. Bye bye. Welcome to day 21, where we are learning about the AWS tutorial, AWS course, free course actually, and we are starting our, like we have already started our DevOps journey. In this particular video, we are going to talk about the BPC peering. So before BPC peering, what we covered? We covered the BPC endpoint, the type of gateway where we tried connecting our S3 bucket with the help of EC2, correct? And we understood the BPC endpoint. If you have not watched out the video till now, you can watch out the other videos which are available on the channel. In this particular video, we are going to talk about the BPC peering. So what we will do in the BPC peering, we will establish the communication between the multiple BPC. So let's directly move to the AWS console, on the browser side, and we will see the flow diagram, how we will establish the communication. So in the BPC peering, we are going to create two BPC, and in these two BPC we will launch two private EC2 instances. So if you can see, this is the VPC block for the first one, this is the VPC block for the second one. Within this VPC block we have private subnet, public subnet, and in the second VPC I will keep only one private subnet and one EC2 instance which will be the part of private subnet, correct? Here I am creating one public subnet as well. Why I am creating one public subnet as well? Because I want to launch a VSN server from where I will try to connect this private subnet EC2 instance and the second EC2 instance which is available in the second VPC as well. Initially, when you will try to do the communication between the private EC2 instances from the first one, you will be able to do. But the moment you will try to connect your private EC2 instances which is in the second VPC, you will not be able to do. For that, you will have to establish the peering between these two. So BPC peering is used for making the communication between two BPCs, correct? So that we will establish here. Let's directly move to the AWS console and we will see how to implement the same thing, correct? So you have understood the purpose of creating this BPC peering. It will establish the communication from BPC 1 to BPC 2. It might be in the same region, it might be in a different region. If you don't create any peering or networking between these two, you will not be able to communicate between these two. We will see that thing as well, and we will see the solution part as well. Now let's directly move to the BPC console. Here I will be creating two BPC, create BPC. So the first one I will call as BPC1. CIDR I will be putting as 10.0.0.0/16, and let's create VPC. Let me create one more VPC here. The create VPC, and this one I will call as VPC2 with 11.0.0.0/16. That will be my CIDR for second VPC. Two VPCs are created, correct? You can see VPC1, VPC2 are created. Now let's get into the subnet creation. So we will create one subnet for the second VPC and two subnet for the first VPC. Let me create subnet. Let me select VPC1. So according to the diagram here, in the VPC1, I am creating one public subnet, one private subnet, so that I will be launching one bastion server as well, and then one private EC2 machine. So let me create two subnets here. For the VPC1, I will be calling it public subnet, and availability zone I will keep as episode 1A. CIDR I will keep it as 10.0.1.0/24, correct? Let me add one more subnet here. This one I will call as private subnet. Preference I will give episode 1A availability zone, and CIDR I will give as what I have given 10.0.1.0. Here I will be passing 10.0.0.2.0/24, correct? This one will be called as private subnet. Create subnet. So in this particular VPC 0451 VPC1, I have created two subnets now, public and private. Till this time, these subnets are neither public nor private, correct? It's just a private subnet now, as of now, because you know the concept. We have to attach the internet gateway, correct? Then only your subnet will be private subnet. If you see, there is a communication between the public subnet and the internet gateway. There is a route table as well. So we will have to create route tables here as well. Let me create route table. So I'll be creating two route table here, public route, and VPC1. Let me give the name as well. Select the VPC1, create route table. So this is the route table for the VPC1 public route. Let me create one more route table. This one I will call as private route VPC2, sorry, VPC1, because we are creating the private route for the VPC1 only. I will be launching one private EC2 machine, VPC1, create route table. This is done, correct? Let me create one internet gateway, and this internet gateway will be attached to the VPC1, correct? So let me create one VPC K1 hyphen IGW. Let me create internet gateway. Let me attach this to the VPC, and here I will be attaching it with the VPC1. Attach internet gateway. Now let me move to the route table. In the public route VPC1, I will be attaching this, I will be editing the route, and I will be adding the internet gateway here, 0.0. I will select the internet gateway. I will select this IGW, save changes. I will do the subnet association as well. So I will edit the subnet association. I will select the public subnet, correct? I will do the save association for the public subnet. So what I am trying to do here, I am covering this part right now. I have created the VPC. I have created two subnet, public, private. For the public subnet, to make it as a public, I have created one route table, and I have associated the internet gateway. So I have created one VPC. I have attached to the VPC1. This internet gateway I have passed in the route tables, correct? You can see I have passed in the route table here. Then I have associated this subnet into this route table. That means this one has become the public subnet now. The subnet which is associated here now is the public subnet, correct? So you can see that. Now let me rename this public subnet name as well. So let me mark it as VPC1, save. And for the private subnet as well, let me mark it as VPC1. So these all the things are of the VPC1, correct? Public subnet VPC1. Route tables I have created VPC1, VPC1. So now everything is segregated. Now I will be creating second VPC as well, correct? Let me create, VPC2 we have already created, I just forgot. Let me create subnet for the VPC2 as well. Let me create VPC2 I have selected. Let me create one subnet. So I will mark it as a private subnet VPC2. Reference, let me give the episode 1A, and CIDR for the second VPC subnet I will be passing it 11.0.1.0/24, correct? 256 IP address. That's it. I will keep this subnet as a private one only. So for that I will require to create one route table. So let me create one route table, and this one I'll be calling as private route and the VPC2. Select a VPC. Let's select the VPC2 here. Create route table. Route table is created. Let me associate the subnet as well. So edit subnet association, private subnet VPC2. Save association. Now everything is fine. From the networking perspective, we have done everything. In the second VPC, I have created one subnet. I have associated this subnet with I have created one route table, and I have associated this subnet as well, correct? Route table is there. We have created public subnet, we have created private subnet, we have created internet gateway, route table, and we have done the association here as well. Now we have to launch the AWS EC2 instances, one public, one let me remove this, and we can use this one only. Command C, Command V, and let me drag it over here, correct? Yeah, that looks nice. So EC2 we have to create here. So let me put it somewhere here, over here, correct? Let me drag a bit. You can see, yeah. So we will create this EC2 in the public subnet, then we will create one in the EC2 in the private subnet, and we will establish the communication between these two. Then we will see to establish the communication between these two using the VPC peering. So let me go there and create two of the EC2 instances. Launch instance, and here I will be creating one public server. So let me see if there is any server right now. No. So let me call this as a Bastion server. This one will be our public EC2 instance. Let me select the Amazon Linux as a AMI. The free tier t2.micro. Keep here I will be using the public one. That's what I am going to use throughout all the three machines what I will be creating. for this private EC2, public EC2, and this other VPC EC2 as well, I will be using the same public key. You can use the different one. This is just for the demo purpose. That's I don't want to repeat the same steps, so that's why I'm using the same key. You can create different one. It will work in the same way. So let's do the networking configuration here. VPC, I'll be selecting the VPC1 for this purpose. I'll be selecting enable because I want to create the public EC2 machine. So here also I'm selecting the public subnet VPC1, correct? Then security group, let me create one here. So I'll be creating as Bastion SG. I'll be naming this, and here I'll be passing the Bastion -SG security group, correct? Let me don't do anything. Let me directly move to the launch instance. Your public EC2 instance is created. The moment it will be ready, let me create one private EC2 machine as well. This one I will call as private EC2 VPC1. Remember, it's a part of the VPC1. Same configuration, T2.micro, same key pair I will be selecting. Networking configuration I have to just change. So I will be selecting the VPC1. I will be selecting the private subnet now. And while I am selecting the private subnet, that simply means it will not be having any public IP address. So I will be going with the auto assign public IP as disabled because that is of no use. Either you can select the same security group or you can create new one as well. Let me select the Bastion SG only because it has nothing to do anything, correct? So it will be of the same rule. Or let me create the new one, or you might get confused. So let me call it private EC2 hyphen SG. Sorry, EC2 hyphen SG. And here, one thing will change here. Private EC2 SG. It will change one thing here because I will be using the user data, and that user data message will be prompted on port 88. Correct. So I will be using the custom TCP port. I will be mentioning as 80. Source type I will be mentioning as custom. Correct. And source I will be mentioning as 00. Correct. Description just demo. I will be just mentioning as 00 port 80 custom TCP. Correct. So that's it. And in the user data, why I am using this protocol or the rule, because I will be passing the user data here, and this user data message will be printed on the IP address of server, correct, while I will be using the IP address. So let me take the user data from here. Where is that? Let me select this. Come on, see. Let me go to the browser here. I will be just pasting over here. Welcome to VPC1. Here I will be putting the message as welcome to VPC1 EC2 instance, correct? VPC1, and even let me put a private EC2 instance, VPC1 private EC2 instance. So that message will be printed while you will be clicking on the public IP address. When you will be clicking on the private IP address of this EC2 machine, correct? Welcome to VPC1 private EC2 instance. This should get reflected. So let me go there. And let me click on the launch instance. Okay, that's done. Let me refresh it. Let me connect this Bastion server. Connect. And this Bastion, the moment your Bastion server will be connected, what I will do? I will create this PAM key file over my public EC2 machine, that means your Bastion server, and with the help of that I will try to do the SSH into this private server, correct? So this one is connected. Let me do the sudo su. Here I will be creating one file. As of now, if you see, there is no file here, correct? I will be creating one. So I will do the vi public .pam. I will give the name. Here I will do the shift insert. Let me go to the text edit here. I have this public content of this public.pam key file. Command C. Let me move there. Do the Control V. Escape, save, and that's it. Why we choose the public.pam? Because it is this is the key which is associated with our private server, and this is the key what we have to configure here so that we can do the SSH into our private server. Correct. So let me give the permission here, chmod 400 read permission to this file public.pam, and we are done. Now let me do the ssh -i and then the name of the file public.pam, then ec2 -user @ the private IP address of this EC2 machine. because it does not have any public IP. So let me do the copy, and you just do the paste, and you are ready to connect. Correct. So you have connected to this private EC2 machine. Correct. Now we are able to connect to this private EC2 machine with the help of your public EC2 machine, which are in the same VPC. These two EC2 instances, the private server and the public EC2 machines are of the same VPC. Correct. So we were able to do the communication between these two. Why? Because in the route tables of both there was local configuration, so from the local it can make the request in this destination, and this is the destination for this VPC 11.0 for the for the VPC 1 10.00/16, and this is the route table. That was the for the VPC 2. So in the public route VPC 1, if you see 10.00/16, local can make request up to this destination 10.0. That this is the VPC for your first one. Correct. This one. So this route table can make the request for this one as well, this one as well too. The public route VPC 1. Let's check the public route, the private route VPC 1 as well. Even this can make the request from local to this destination. Correct. Now let me try the same for the VPC, for the EC2 instance, which we will create in the second VPC. Will we be able to make the communication between this EC2 instance, which is in the VPC 1, to the VPC 2 or not? Let's see that. Let me click on the launch. Let me create the private EC2 VPC 2 now. Private EC2 VPC 2 now. Same AMI, same T2.micro we will be selecting. Key pair I will be selecting the public one. Same one. We can use the same public key pair anywhere. So key pair anywhere. The same configuration. If you are not sure how to launch all these EC2 instances, you can watch out the videos which are available already on the channel. Correct. You can come through the tutorial, the course itself. Networking, I am selecting the second VPC here, VPC 2. Private subnet, we do have only one subnet in the second VPC. If you see, private subnet, only one. Let me go to the auto assign public IP, disable, because we won't require any public IP. We are just trying to establish the private communication between these two VPC. Let's go with the disable one only. Security group, let me create one here. So I'll be calling as private EC2 VPC 2 SG. Correct. Here also I'll be using the user data, so I'll be going with the port 80. Sorry, not 100, port 80. Custom 00 CIDR. Request can come from anywhere. Description, let me put as demo only. And in the user data, I'll be using the same script here as well. Command V. Let me remove this. I will have to go to the PPT here. Yes, on the PPT side, and here I will have to copy this content. Command C. Let me go to the console browser. And here I will be printing the message, welcome to VPC 2 private EC2 instance. Welcome to VPC 2 private EC2 instance. Correct. That's fine. Let's do the launch. It is launched here. Now we had used the same key pair, private EC2 VPC 1. Let me go for the third one. This one, private EC2 VPC 2. Now even this is running. It also has the same public key pair. Correct. What is changed over here? It is now it is launched in the second VPC. So we have to do the private IPv4 address and the SSH part. Correct. That's it. Now let's try to do the same. Here we are on the we have connected from the public EC2 machine to the private EC2 machine here. Correct. Now let me connect the the public EC2 machine once again in the different browser. So let me click on the machine. Let me click on the connect. One more tab is open. This one is the first. This one is the first one. This is the second one. Correct. Now let's do the sudo su here. We have this public.pym already. So what I have to do? I have to run this command only. ssh-i. Then public.pym, already that file is there. ec2-user @ and the IP address, the private IP address of the second VPC. Let me just copy this private IP address on this browser, command V, and you can see that now you are not able to establish the communication. Why? Because here you had these two EC2 instances, the public one 10.0.1.2.32. If you see from here in the detail, let me open this bastion server in one. Uh, so let me open this bastion server. Let me open this private one. This means VPC1. This bastion server is the part of VPC1. This private EC2 BPC1 is the part of BPC1. So you were able to establish the communication from 10.0.1.2.32, which is the bastion server 10.0.1.2.32. From the bastion server IP address, you were able to move to this 10.0.250. Correct? You 10.0.250. You were able to do the communication. Correct? Why? Because both of them were the part of the same BPC. As per the diagram, also you can see these are the part of the same BPC. But when you try to establish the communication from the VPC1, which is the Bastion server 10.0.1.2.32, correct? 10.0.1.2. From Bastion to the EC2 instance, which is the part of second VPC, you are not able to do the communication. Why? Because this is of the second VPC. Here you can see second VPC, correct? So till that time we have not created any peering connection, so it's not able to communicate with the second VPC EC2 instance, correct? What we will do now, we will create one VPC peering connection and we will establish the communication between these two as well. Now let's move to the VPC console here. Here you have the option to create the peering connection, correct? So let me go here and let's find out the peering. Where is the peering option? Let me check for the peering. Virtual private gateway, transit gateway. Sorry, let me do the command F. Peering. Sorry, yeah, I just forgot where to see. So let me create on the peering connection, and here I will give the peering. Peering VPC1. VPC1 to VPC2. Select the VPC ID. So here you have to select one VPC as a requester and the second VPC as acceptor. So I will mark VPC1 as requester. It will request to the VPC2 that I am requesting you to make the connection between us. So VPC1 will be requester. Either you are trying to establish the communication between the same account or the different account. So from here you can select the either my account or another account. So right now we are in the same account, so let's select the my account, whether in the same region or different region. So you can establish in the different region as well. Here in the demo we are covering for the same region, so this region only. Select the VPC, VPC2. VPC1 will be requester, VPC2 will be acceptor, correct? Let's establish the connection VPC1, VPC2, pending acceptance by this one, correct? So status, let me do the accept request as well. So you will see requester VPC, VPC1, acceptor VPC2, accept the request as well. Active. So VPC1 to VPC2 communication has been established now, correct? Now what you have to do, you have to get into the route tables. In the route tables, you have to define that these two VPCs can communicate with each other. So let's go to the private route VPC, the public route VPC1. Here in the edit routes, you have to click on the add route. You have to go for the CIDR. CIDR of which? Of the second VPC, correct? As per the diagram, second VPC 11.0/16. So that you have to select. Sorry, where was it? Yeah, 10.0/16. So let me just copy this. Command C. I will just remove this search bar. Here I will just paste it, and for the second VPC our CIDR was 11.0. So I will be just adjusting it. Use 11.0. Here you will be selecting peering connection and the peering connection what you have established. 11.0. What does that means? It will now able to communicate this 11.0. That means second VPC. Let's do the save changes. And the same route I will create for the private one as well. We will see the use case of this one as well. So let me click on the add route. Let me add the same destination here. I will just edit this one as well, 11.0, and the peering connection here. Same peering connection I will be establishing. Save changes. So what I have made till now, from the BPC1, BPC2 can be requested. Now let's do the same changes for the BPC2 as well. BPC2 can communicate with the BPC1, correct? If I am communicating from here to there, I would also like to do the communication from here to there as well. So let's do the second part as well. Let's select the CIDR for the first one, 10.0/16. Use this one, peering connection, and here select the peering VPC 1 to VPC 2. Why we have used 10.0? Because for the first VPC CIDR is 10.00/16. So let's save this peering VPC 1 to VPC 2, save changes. Correct? So we have created the VPC peering, we have established the communication between these two. Now you will be able to do the SSH. So let's try to do here. What we are doing, we are trying the same thing. Now we are trying to do the bashing, connect our second EC2, sorry, the second VPC EC2, the EC2 which is the part of second EC2. We are trying to connect that from the bastion server which is the part of VPC 1. Correct? If you see the IP address 10.0.1.2.32, this is the IP address of this bastion server which is the part of VPC 1. What we are trying to connect, we are trying to connect this 11.0.1.135, which is the IP address of private IP address of the EC2 of the VPC 2. Correct? Now let's try to see whether it will be able to communicate or not. It's able to communicate. You can see EC2 user 11.0.1.135, it has been connected. Correct? So with the help of VPC peering, you are now able to communicate between these two. If I do the curl from these two, just remove the public bastion server from the picture as well. If you want to communicate between these two as well, you can do the communication. Correct? So let's do the curl from this private EC2 instance for this private EC2 instance. Correct? So let's do that. So what I will do, I will run this curl command from this. This is the EC2 instance IP address of the private EC2 instance which is the part of VPC 1, 10.0.250. If you see 10.0.250, this is the private EC2 of the VPC 1. From here I will make the communication for the second VPC EC2 instance, private EC2 VPC 2. So curl 11.0.1.135. Let me try doing that, and you cannot see any message. Okay, so the user data message should come on the public IP side. Correct? So anyway, we are not able to do the curl here, but the thing what I wanted to cover, that you are able to do the communication between these two VPCs. You saw that. Correct? So we have done the communication from public subnet to the public EC2 machine to private EC2 machine which is of the same VPC. Then we have created the VPC peering connection, and we established the communication from this bastion server to this private EC2 machine of the second VPC. So this is what I wanted to explain in this VPC peering demo, and let's talk about the theory part as well here. In the theory part, what is there in the VPC peering? Let's see that as well. So let me go there. In the VPC peering, these are the few terminology. A networking connection between two VPC that enables you to route traffic between them using private IPv4 address or IPv6 address. Instances in either VPC can communicate with each other as if they are within the same network. So we have just established the communication between these two. Correct? You can create a VPC peering between your own VPC or with a VPC in another AWS account. That's what we talked about. So in this particular video, we just wanted to talk about the VPC peering. In the next video, we'll be talking more in details about another properties, VPC transit gateway or something else. So stay tuned with the channel, subscribe to the channel, and we will come up with more technical content as well. So till the time, thank you. Bye bye. Welcome to day 22, and here we are talking about the AWS tutorial and specific to the DevOps journey. In this particular video, we will be talking about the transit gateway and the use case of the transit gateway. Before this video, we had covered the AWS VPC peering, where we talked about how to establish the private communication between two VPC. And till now, we have covered the S3 to EC2 connection, the VPC peering, the route table, security group, load balancer, EC2 service, the auto scaling group, launch template, and so on. Correct. In this particular video, we are going to talk about this transit gateway. So before coming to this picture, let's understand the theory part of the transit gateway. So let's start from here. This one. So transit gateway is a network transit hub used to interconnect virtual private clouds and on-premise networks. The following are the key concepts for transit gateway: attachments, transit gateway maximum transmission unit. These are the theory parts, and we do the route propagation and all these stuffs. Now let's move to the demo itself. diagram itself, and then we will move to the AWS console to do the demo. So if we do have this VPC pairing, we were able to connect the two VPC with each other, correct? When we were trying to do this, we were able to do the same things. Now, when you have to establish the communication between multiple VPC, just suppose that I do have four number of VPC here. Just let's consider that I do have four VPC, correct? And these VPCs are A, B, C, and D. So how many connection you need to establish when talking about the VPC pairing? So for that you have to do the one-to-one mapping, correct? So for one-to-one mapping you have to do A to A to B. Then you will be doing the connection between A to C, then A to D, three connection. Then you have to establish the connection from B to C, then B to D. Then you have to establish one more connection, that will be C to D. So total becomes n star n minus 1 by 2. That becomes your formula to do the VPC to have the VPC pairing connection. N star n minus 2. That means if we do have the 4 number of VPC, that becomes your 4 star 4 minus 1 divided by 2. That means 4 into 1.5, that becomes your 6. So to establish the communication between 4 VPC, you have to make the 6 connections. While this becomes much complex, your transit gateway helps here. In the transit gateway, you have to just create one transit gateway hub and multiple attachments. So whenever you have to make the connection between the VPCs, you will just create one attachment between the VPC and the transit gateway, and in the similar way for the other VPCs as well. And that will this transit gateway hub will act as a hub point where the communication will happen. So every communication between the VPCs will happen through this transit gateway attachment to the transit gateway hub and to the second transit gateway attachment that will pass the network to the second VPC, and so on for the third VPC or the multiple VPC as well. So what we will do, we will create these 3 VPC and we will launch 2 public subnet. In these 2 VPC, we will launch 2 public EC2 machines, and in the third VPC, we will launch 1 private subnet and private EC2 machine as well. And the use case we will be covering, we will try to see the message on these 2 public EC2 instances, and then from the first public EC2 we will make the connection into the third VPC, which is having the private EC2 machine. Correct. So let's see this concept, and let's move to the AWS console directly. So what I have covered to save the time, I have just created this particular first VPC. I have created this public subnet and the internet gateway, route table, and public EC2 instance. This one I have covered to save the time. Rest of these 2 things I will be covering right now. So let's see directly. Here I have already created VPC1 and I have also launched the public EC2 VPC1, and this one is running. What is there on the message? This is the public EC2 machine is having the message, welcome to VPC1 public EC2 instance. So till now this part is covered, the first one. Let's create for the second and third. So let me launch one more VPC here, that will be called as VPC2. VPC2, and then CIDR for this one will be 11.0.0/16. Let's click on the create VPC. Then I have to create the subnet as well. Here we are creating the public subnet because I have to launch public EC2 machine as well for the second. So I will be creating one public subnet in the VPC2. This one I will be calling as public subnet VPC2. Preference I will give the availability zone AP South 1A, and the CIDR once again 11.0.1.0/24, so that 256 IP address will be there. So your second subnet is created. For the second VPC, we will require this internet gateway as well, because we have to launch the public subnet. So we will be creating this internet gateway as well. Let me create the internet gateway here for the second VPC. So I will be just calling it as IGW VPC2. Correct. Let's create this, and we will have to attach this as well with the VPC as per the diagram as well. This internet gateway needs to be associated with the VPC. So let me associate this with to the VPC. Attach to VPC, and which VPC? VPC2. Attach internet gateway. That's done. Now let's move to the route table. Here I need to create one route table as well. So this one I will be calling as public route VPC2, and the VPC I'll be selecting one VPC2 here. Create route table. Now let's do the subnet association. Edit subnet. You will be selecting public subnet VPC2. Save association, done. And the routes you will be passing this internet gateway here as well, because I have to launch this public EC2 machine. Let me select this 00. So the internet gateway and the IGW VPC2. Save changes. So your EC2 machine can be here launched in the public subnet. That will be your public EC2 machine. So let's launch the second EC2 machine as well. So let me click on the launch instance, and here I will be launching public EC2 in VPC2. T2.micro, the same configuration. If you are not aware how to launch your VPC, how to launch your EC2 machine, you can watch out the other videos which are available on the channel. Here I'm just going a bit fast to save the time. So I'm just giving the public EC2 VPC2, then T2.micro. Keep here I'm just giving the public one, for which I do have the content on the notepad, so that I can use it in our own pace. So I'll be launching this. In the network settings, let me click on this, and let's select the VPC2. Public subnet VPC2, that is by default, because we do have only one VPC subnet here. Auto assign public IP, let me do the enable. And then security group, let me click on the create, and I will be just creating one more security group here. That one I will be calling it public SG EC2 VPC2. That's just a random name, and here I will be passing the same. Let me just do the copy and paste. Rule here I will be allowing port 80 as well, custom TCP and port 80, because I have to use the user data. Then let's move to the, I hope I enabled this auto assign public IP. Yes, advanced details, and here I will be passing the user data as well. And to paste the user data, I will be going to this PPT. Where is 38? Yes. So let me just copy this particular script. Command C. Let's move here and just paste it. Here I'll be just typing welcome to VPC2. Sorry, this VPC2 public EC2 instance. That will be my message when I will be clicking on this public IP address of this EC2 machine. And I hope it's enabled. Yes, it's enabled. Let's click on the launch instance, and it should be launched. Okay, the CIDR I had to add, so let me add this 00. Click on the launch, and your second EC2 is being launched. So that will be done anyway, correct? Now let me launch the third VPC and the private subnet and private EC2 machine as well. So let me click on the VPC here. Let me click create VPC only, and here I will be launching the VPC3 as well. Then 12.0.0.0/16 create VPC, then subnet, and here I will be creating one private subnet, so VPC3, and this one will be called as private subnet, and the name will be VPC3 as well, just to make it readable. Availability zone AP South 1A, and the CIDR for the subnet will 12.0.1.0/24. That's it. Create subnet, and your subnet is created. Now let's create one route table here as well. Create route table, and the route table name will be private route VPC3. Select the VPC, so VPC3 is selected. Create route table. Here we are not creating internet gateway, because I have to launch this private subnet only and the private EC2 machine. So there is no use of internet gateway. So now let's do the subnet association. Edit subnet, and your private subnet VPC3 is there. Save association, that is done. Now we are okay to launch our third EC2 instance as well. So let me launch the third EC2 instance. This one I will be calling as private EC2 VPC3. So let's select the T2.micro, and the same key pair I will be using. So just let me select this VPC the public key pair, and VPC3 from here. Private subnet, because we do have only one subnet, that's why it's coming as a private subnet VPC3, and there is no use of enabling public IP because we are launching it in a private subnet. So let me create one security group now, and this one I will be calling it private SG EC2 VPC 3. The same name I will be just copy and just let do the paste here. Port I don't have to allow anything other than this SSH, because I will be just doing the connection from first EC2 to the third EC2 in the one which is private one. So let me go to launch instance and your instance in lot. So let me just refresh here. Let's see the message which is on the second VPC, and I will be just clicking on the open address. I will do the port 80 here, and then let me remove this S, because we do have the path on HTTP, and you will see that welcome to VPC2 public EC2 instance. So what is there on the message for the first EC2, which is in the public subnet, that is having the message welcome to VPC1 public EC2 instance, and the EC2 which is in the second VPC, that is having the message welcome to VPC2 public EC2 instance. Correct. These are the two messages. For the third one, we are launching the private EC2 machine, so it will not be having any public IP address even. So let's see for that as well. This one does not have any public IP address. Correct. Now, if you want to do the curl between these two EC2 machines, from the first to the second, curl from the private IP address, you will not be able to do. Correct. So let's do connect this public EC2 first. So I will be connecting this public EC2, the first one, from the console itself, public EC2 VPC1. So let's click on the connect, and here I will be just clicking on the connect, and your EC2 should be connected. Let me open the other instances as well here. Let me click on the instances, and we have this public EC2 VPC2. What I am trying to do here, let me do the sudo su as well, and from here I just want to do the curl for the private IP of the second VPC EC2, the public EC2 which is in the VPC2. So I will be just doing the curl of this message. What should be the message over there? This message welcome to VPC2 public EC2 instance, this one should be printed. So what I'm trying to make the connection from the first public EC2 to the second EC2, and through the private IP address, not from the public IP address. So let's try to do the same thing. I just copied this private IPv4 address of the second EC2 which is in the second VPC. Let's do the curl here. Curl, and now you can see that you are not able to see any message. It's not making the connection. So, and for the same in the similar way, if I do the control C here, if I want to make the connection between the first EC2 to the third EC2, the private public EC2 which is in the VPC1 to the private EC2 which is in the third VPC, even you will not be able to have the connection between these two as well. Correct. Let's try doing this same thing once again. So for that, what is required, I will have to pass the PAM key which is associated with this public EC2 on this public server, and then we should be able, if it is available, correct, then we should be able, but we will not be. So let's try to create this PAM key on this public server, and we will try to establish the connection. So let me do the vi here, vi public.pam, and here I will be just pasting the content. Let me just copy here, command C, let me move here, command V, then let me do the save, WQ, and save. Let me give the permission chmod 400 and the file name public.pam, and let's do the let's try making the connection ssh-i, then the key public EC2, public.pam, then EC2 -user, and the at the rate, and then the IP address. Let me open this the private EC2 VPC3. Let's try making the connection. You will not be able to do even this that thing as well. So neither we are able to do the connection between these two public EC2 using the private IP address, and now we are able to do the connection from public EC2 to the private EC2 which is in the another VPC as well. So both the things are not allowed as of now. So let me do the control C here and just break the connection. What is left here, and why it is not working? Because there is no communication between all these three. So we will have to create one transit gateway. Then we will be creating transit gateway attachment with all these three VPC, and then we will be modifying the route tables to establish the communication between these three, and then we will be able to do the same thing. So let me create one transit gateway and these three transit gateway attachments. Let's move to the VPC console, and here I will be creating one transit gateway. Let's click create that. Let's just wait for a few seconds. The time your console will be already. Yes. So let me call as demo tgw description demo, and configure the transit gateway. Let's go with the default one, all the default configuration. Transit gateway CIDR blocks, all these are options. Let me click on the create transit gateway. Your tgw uh, is in pending state. In few minutes it will be available to use. Correct. So meanwhile, let me create the transit gateway attachments as well. So let me create this transit gateway attachments. Create transit gateway attachment, and this one I will be calling as tgw bpc1 transit gateway ID. So we need to wait for the moment this transit gateway will be available. So let's wait for few seconds. The moment your transit gateway will be available, we will be able to use it. Till that time we will have to wait. So let's understand the concept till the time. So transit gateway attachment will be created, then we will be modifying this route table, and we will be giving the CIDR of these two BPC in this first route table. That route table will tell that you will be able to communicate with these two BPC, and similarly we will do for the other two VPC route table as well. We'll pass the CIDR and this transit gateway attachment, and that will establish the communication between all these three VPC. So let's refresh here, and now it is available. Transit gateway attachment, transit gateway is available. Let's move here, select the transit gateway. Let me refresh here, and let me call it tgw vpc1 attachment. Even the attachment name should be there. Transit gateway ID demo tgw vpc. Yes, it is vpc only. Which vpc? I want to launch it for vpc1. tgw vpc1 attachment vpc1. Let's create the transit gateway attachment. Similarly, let's do for other as well. So tgw vpc2 attachment. Let's select the transit gateway ID. Let's select the vpc2. And why we are getting only one subnet ID and availability zone? Because we do have only one subnet which is launched in this VPC. If you launch the another subnets as well, you will be able to see the another availability zones as well. So let's click on the create transit gateway, and here VPC1 VPC2 is there. Let me create for the VPC3 as well. tgw VPC3 attachment. Transit gateway ID demo tgw VPC ID VPC3. Let's click on the create transit gateway. So transit gateway attachments we have created, transit gateway we have created. Now what is left? We have to configure this communication. So we have to change the route tables. Sorry, we have to edit the route tables now. So all these are pendings. Sorry, one is available, and the rest of these two are as well. These are in the process. So let me go to the route table now, and here we will do the modification in the route tables. So let me first modify this public route VPC1 only. So let me click on the edit routes. Here I will be adding the CIDR of the other VPC. So for other VPC we created 10.0 and then 11.0, 12.0. So I will be just passing these two CIDRs in the first route table. So I will be just copying this content. Let's do the modification here only 11.0, and then use this, and the transit gateway I will be selecting over here. Transit gateway VPC1 attachment, this one, and then we have to add the route for 12.0 as well. Sorry, let me just copy the content only, and here I will be just modifying to the 12.0, and then transit gateway once again tgw VPC1 attachment. So what we are telling that for this VPC1, it can go up to the 11.0, 12.0. That means whatever the request will be made from the VPC1, correct, which is having the 10.0 CIDR, it can go up to the 11.0 and 12.0. That's what we are trying to tell here. Correct. So let me just save it, save changes. This one is done. Let's go for the second route table and third route table as well. Let me click on the edit routes, click on the add route. and just do the command V and use. Let's select the transit gateway once again, TGW VPC2 attachment, and then let's add for the third as well. So here 11.0 is the first VPC destination itself. So here I will need to add the 12.0 and 10.0 because it's VPC is having the destination at J11, correct? 10.0, 11.0 and 12.0. These are the three CIDR for us. So let me do the modification. Let me select the transit gateway here and the TGW VPC2 attachment. Let's save the changes. Let's modify the third route table as well. And here I'll be passing the edit routes. Click on the add route. And here as well I will just passing the 10.0, then transit gateway and the TGW VPC3 attachment. Let's pass the same, and here I'll be passing the 11.0 now. If you want to make the communication between all these three, that's why I'm doing for all the VPC here. If you want to make the one-to-one, you can do the same things. So 11.0 is there, 10.0 is also there, 12.0 is already the CIDR of this VPC. Let me save these changes as well. Now we have created the attachments, we have modified the route table as well. Now we should be able to do the same thing. So what we tried first, we tried to do the curl on this public EC2 machine using the IP address of the second EC2, correct? The private IP address of this second EC2. Let's try to do the same thing here now. Let me do the curl. You can see the message now. Initially, when we did the curl 11.01241, which is the private IP address of the second EC2 machine, let me open this EC2 as well. I think this is the one. No. So let me open this. Public EC2, VPC2. You can see 11.01241. That is the private IP address of the second EC2, which is the part of VPC2. But now you are able to see the message. Welcome to VPC2 public EC2 instance. Similarly, if you want to establish the communication from first EC2, which is in the VPC1, to the third EC2, which is in the VPC3, which is the private one, you can now do the connection. So let me do the try. Let me try doing this SSH as well. You can see now you are able to do the connection as well. You have moved to 12.0.1.221. That is the IP address, the private IP address of your third EC2 machine, which is the part of VPC3. So with the help of this transit gateway attachment and the transit gateway, now you are able to make the communication between the multiple VPCs, correct? So this way, the VPC peering and VPC, the transit gateway concept helps you to make the communication between the multiple VPC, while the VPC peering becomes more complex if you are having more than two VPC, correct? Then transit gateways gives you the solution for that. It makes you your life easier to make the communication between multiple VPC. So that's what I wanted to cover in this particular video, in this demo, and stay tuned for the other contents which will be available on the channel moving forward. So till the time, thank you, bye bye. Welcome to day 23, where we are talking about the AWS tutorial, and we are specifically going to talk about the AWS Route 53 here. So Route 53 is one of the AWS services where we used to maintain the records, and that defines how to route traffic to any particular domain and its subdomain. Mainly, the Route 53 contains two kind of your hosted zones. One is called as public hosted zone, and second one is called as private hosted zones. In the public hosted zones, we define that how our traffic will be routed to the internet itself. While in the private, we define that how records or the traffic will be routed within one VPC, correct, or the within multiple VPC. So as you can see, the domain as well, in the public hosted zone, we define this kind of URLs, application1.mypublicdomain.com. While in the private hosted zone, we define the URLs like the company.internal, that kind of domain we used to put that. While talking about the pictorial presentation of this, you can see here is the client, and the client is making a request, example.com, and that is going to your public hosted zone, and that IP is getting converted according to the domain, and then the request is coming to the VPC, and then subsequently to the load balancer and to the other AWS services based on the requirement. While for the private hosted zone, all the requests which are the internal to the VPC itself, though these are being redirected to the different either the virtual servers or the DB instances. Correct. So these are the basic differences between these two kind of hosted zones, public and the private one. Now talking about the records, which kind of record we can create in the Route 53. There are mainly for multiple types of records that we can create, 6 to 7. But we will be specifically talking about the CNAME A record, 4 times A and TXT, that kind of records. CNAME basically we used to create it for mapping one domain with another domain. Like if you have abc.com and you want that your abc.com should get redirected to xyz.com and then to your VPC. So for that kind of record, you can create the CNAME. Mainly we used to create it for the, like I do have one application endpoint I called as abc.com, and then I want to move it to the load balancer. So load balancer record also ends with the .com, correct? Amazon AWS.com. So that mapping can be done with the help of CNAME. While if you want to map your DNS abc.com with any of the IP address of the virtual server, for that you can create a record, and subsequently for other records as well. Here you can see the pictorial diagram of that as well. You can create the record name. You can pass in all the values out of the options which are in the drop down, and then you can create your records. Now let's talk about the one of the important property of this Route 53, that is your region level failover. So while we create this CNAME record or other records which are mentioned over here, or even you can see in the diagram itself. So while creating the records, you have the options to select the policy as well. Why this region level failover is required? Just suppose that by any chance your one of the region goes down, your server goes down, and so you have to do the DR activity, or you have to keep your business running, correct? So you cannot afford that business going down and your application also going down. So for that scenario, you can use this region level failover concept. Here what we do, like if you have the your one server in one region, you can deploy another server in the another region, as you can see in the diagram itself. For the example.com, which is the traffic is coming to the AWS Route 53, and from there it's going to the two of the EC2 instances. One is in the region 1 and second one is in the region 2. If you see the next presentation, you see that region 1 server has gone down, correct? If you can see, the health check is in the red mode, correct? So that means the region 1 EC2 instance is now down. So the moment it will find out that the region 1 EC2 instance is down, the Route 53 will not send the traffic to the region 1. It will now start redirecting all the traffic to the region 2, and your application or your business will never go down in that case, correct? So this will be one of the helpful property of the Route 53. That for this, what you will have to do while creating your records, that we talked about the CNAME or other records, you will have to just pass this details, the policy. For the primary, you will be selecting the primary, and for the other, you will be selecting the failover policy. That will be created as a second. There will be mentioning the IP address or the other DNS. Correct. So this is what all we wanted to cover in the AWS Route 53. We will meet in the next video with another content on the probably on the CIDR and the Amazon S3 buckets that we will be discussing on. So till the time, thank you, and stay tuned and subscribe to the channel to watch out the more technical content. Thank you. Welcome to day 24, where we are going to talk about how to calculate the number of IP addresses based on the CIDR. CIDR basically we used to pass in the VPC, the AWS Virtual Private Cloud. And there for every VPC we used to pass the CIDR range, correct? And how do we calculate that how many number of IP addresses are allocated for that particular VPC, correct? Based on that you can create the different kind of subnets within that particular VPC. So just take one example that you are given the example CIDR as 192.168.1.0/24. What is the CIDR now? CIDR notation is a method for representing IP addresses and their associated routing prefix. The format IP address slash prefix length. So thus this 20/24 will be called as prefix length, and this 192.168.1.0 is called a IP address. That means this is a network code, network range, correct? Now if we explain this particular detail of the CIDR which is given here, correct? Slash 24 indicates that the first 24 bits out of all this, correct, 192.168.1.0, first 24 bits of the IP address are reserved for the network and the remaining bits are for host. As you can see here, first 24 bits of the IP address are reserved for network and the remaining bits are for host. Steps to calculate the IP address range: identify the network portion. So the first 24 are for the networks and remaining are for the host. Convert the IP address into binary and take the first n bits. So here we do have 192.168.1.0. We have to convert this into binary, correct? Here is the conversion for this binary, correct? 192.168.1.0. How do we represent it in the binary? The first stands for 1, then the double of that 2, then the double of that 4, the third one, then the double of that 1, 2, 4, 8, 16, 32, 64, and then 128. 128 plus 64, this double one, this 64, and this 128 together becomes 192. Similarly, 168 is converted into the binary using all these binary numbers 1 and 0. Then 1 stands from here 1, and for the 0 it stands for all the 0. So here out of 192.168.1.0 slash 24, the first n bits is your prefix length, and here as well you can see the first 24 bits of the IP address, this are for the network and remaining bits for the host. Here you see the total number of IP addresses which will be available to use in this CIDR. So here we are talking about, correct? After the slash 24, as you can see, so yes, this one. So after the slash 24, you see the number of host bits 32 minus 24. So how do we calculate the number of possible IP address ranges which can be used at least, correct? So you have to do 32 minus the value which is after the slash, correct? That's your prefix length. 32 minus 24 becomes your 8 bits. Then you have to do the power calculation. This gives 2 to the power 8 equal to 256 possible address. Out of this 256 addresses, there are two addresses which are already blocked. The first address is the network address and the last address is broadcast address. So you have to subtract minus 2 out of the possible addresses. So you have to do the 256 minus 2, it becomes your 254. So for this IP address 192.168.1.0 slash 24, for this one the number of possible IP address range becomes 254, correct? So the range belongs from 192.160.1.1 to 192.168.1.254. So that's in this video we wanted to talk about, and in the next video we'll be talking much more about other topics. So till the time, thank you, bye bye everyone. Welcome to day 25, and here we are talking about the AWS tutorial, and specifically we are talking about the DevOps journey. What does that mean? That means we are talking about the AWS Cloud, we are talking about the CI/CD, we are talking about the Kubernetes, we are talking about the Terraform, and we are talking about other tech stacks as well, which are the part of DevOps. In this particular video, we are going to talk about Amazon S3. That is your simple storage service. It's one of the AWS services provided for the storage, correct? So let's get into the theory part of the Amazon S3, and then we will be talking about the demo part. We will see how to create the Amazon S3 bucket. So Amazon S3, it's simple storage service. As you can see from the point, simple storage service is an object storage service. It's a this is the AWS service which stores the object. That means whatever the data will be stored in this bucket will be called as an object. It's offering industry leading scalability, data availability, security, and performance at the same time. Second point, million of customers of all sizes and industry stores. Now, whether you are a service-based organization, you are a product-based organization, or you have a different use case, either you are in the e-commerce, you are in the medical line, or you are in the metal industry or the food segment, all of them are using the S3 buckets for their storage, correct? It can be used for the data processing, it can be used for a large storage of large data, and protect any amount of data for virtually any use case such as data lakes, cloud native application, and mobile applications, correct? The third point is with cost effective storage class and easy to use management features, correct? The Amazon S3 provides you all the facility at a very low cost, which is provided by the AWS itself, and you can do the encryption, decryption, everything with the S3 bucket. You can organize the data, analyze the data, and configure fine-tuned access control to meet specific business and compliance requirements. That means you can protect all the data within the S3 buckets using the SCLs, using the S3 bucket policies, using the AWS IAM roles and policy. You can apply everything. You can do the encryption, you can do the versioning, and all these things to protect your data, to make security of the data. Correct? You can say even secure your data. All these kind of features you will get into the Amazon S3 buckets. S3 free tier offers a 12-month free trial that provides 5 GB of Amazon S3 storage in the S3 standard storage class, 20,000 git kind of request while you are developing the your API. You might be developing your API for get calls, for the post call or put call or any other call, correct? So it provides you 20,000 get request, 2,000 put, copy, post or list request, and 100 GB of data transfer out each month. That means 100 GB of data can be sent outside every month. Moving to the next slide. In the next slide, we have talked about the feature of the Amazon S3 buckets, correct? As scalability, you can store virtually any amount of data with S3 all the way to exabytes with unmatched performance. S3 is fully elastic, automatically growing and shrinking as you add and remove data. There is no need to provision storage, and you pay only for what you use. That's basically the AWS Cloud concept as well. You only pay for what you use, pay as you go model, correct? So Amazon S3 provides you the scalability feature. The second feature is durability and availability. S3 provides the most durable storage with 99.99% of your durability and 99.99% of availability by default. Security and data protection. S3 is secure, private, and encrypted by default, and also supports numerous auditing capability to monitor access required to your S3 resources. Correct. What you can do here, you can either put SCL access control layer, you can put S3 bucket policy, you can put IAM roles or the permissions kind of thing over here. So your data will be secured, and even while developing your S3 bucket, creating your S3 bucket, you can mention out of the configuration that either you want to make it public or you want to make it private, or you want to make your bucket public and the objects within that bucket private. So all those kind of configurations come on the AWS console. You can we will see that in the demo part. Talking about the price, that's the another point. Lowest price and high performance. So S3 delivers multiple storage classes. We will be talking about the different storage classes as well. S3 delivers multiple storage classes with the best price performance for any workload and automated data lifecycle management. Correct. So you can store massive amount of data, and at the same time with the resiliency, flexibility, latency, and rarely access data in a cost efficient way. S3 delivers the resiliency. What does that mean? That means if you want to store the data which will be accessed very infrequently, then you can put it in the different storage class of the S3 bucket that we'll be talking about here, and that for that you will have to pay a very little amount of cost in comparison to the normal object storage, correct? Then another feature other than these four features, the fifth and sixth feature is versioning. S3 provides versioning to keep multiple versions of an object in the same bucket. That means today you have put a one object in your bucket. Tomorrow you do some modification into that object and you still save that object into the same bucket. So now it will be versioned with another numbers, 1.0, 2.0, 3.0, 4.0, different versions of the same object, which will allow you to restore objects that are accidentally deleted or overwritten. Anytime you want to take the backup, anytime you want to do the retrieval, so you can do that because S3 supports the versioning, correct? Then the sixth point is controlled access. Buckets and the objects in them are private and can only be accessed with explicitly granted access permissions. That's what we were talking about before. You can use bucket policy. This one you can use bucket policy. You can use AWS identity and access management, IAM roles and policies. That's what we have talked earlier. S3 access points and access control list to manage access. So if you have not watched out the videos and you don't understand what is IAM and other stuffs, you can watch out the videos from the scratch on the channel itself, where we have talked about the AWS EC2 instance, we have talked about the AWS VPC, we have talked about the subnets, internet gateway, net gateway, your different CID IP address calculation based on the CI. We have talked about the launch template, auto scaling group, and other AWS services as well. Correct. Now let's move to the another slide where we have talked about the different storage class of the Amazon S3. The first storage class comes as S3 intelligent tiering. Second comes as S3 standard. This is the default storage class, S3 standard, correct. In this S3 standard, your objects are stored, and it's the kind of normal or the default kind of storage where your objects will be stored. Now just suppose that you want to put some data as a archival, correct. You don't want to fetch that data every time, or you want to keep that data as a backup. So you will not be putting all those data in S3 standard. Rather than that, you can move that data from S3 standard to S3 Glacier Deep Archive. How this will be done? It will be done through the lifecycle rules, correct. So we will see that as well, lifecycle rules, replication rules, and all those things. So these are the different 8 to 9 kind of storage classes that is being provided from Amazon S3. S3 intelligent tiering, standard express one zone, S3 standard infrequent access, that is called as S3 standard IA. Infrequent access, that means these objects will be put in the S3 bucket, that will be kind of your standard as well, but it will be infrequent access. In once in a month or two or twice in a month you are accessing this data, correct. So this kind of data will be put under the storage class S3 standard infrequent access. If you want to put archival kind of data, you can choose this S3 Glacier Deep Archive. Why there are multiple storage classes? Because every storage class has their own features and their own associated cost. If you are putting it in the archival, it will be at a very low cost, while uh, your the S3 standard will be having a higher cost, correct. So this is all the storage classes provided in the S3 bucket. Now let's talk about the demo part here. What we will cover in this particular video about the demo, we will try to create an S3 bucket, and we will talk about the pre-signed URL as well, or we might talk about the replication and lifecycle rules. Let's see. So let's move to the AWS console here, and we will be creating one S3 bucket. How do you get into the AWS S3 service? For that, you will have to search S3 here in the search bar of AWS console. Let's click on the S3, and here you go on the AWS S3 console. Here we will be clicking on the options, and we will click on the create bucket. So the meanwhile your console is being ready. Here there is no bucket as of now. You can click here, you can see the general purpose bucket, table buckets, access grant, access points, and other stuffs which are present here. Till now there is no what we can say, there is no bucket. That's why you cannot see any bucket over here. Now there is one point which needs to understand, that this Amazon S3 is a global service, while the bucket, the AWS S3 buckets are region specific. What is the difference between these two? Every time you create one AWS S3 bucket, that bucket name should be unique. Why? Because the S3 service is a global service. So if you create one bucket with one name, you cannot create the another bucket with the same name in any region, correct. If you don't understand, let's do the demo, you will understand that part as well. So just remember, or just try to understand, this S3 global S3 service, Amazon S3 service is a region, not regional, it's a global service, while the bucket we will be creating, that will be regional one. So let's try to create one bucket as well. Let me call it as demo 11. You will see most probably this bucket should exist somewhere. So let's try creating this. So I'm just passing the general configuration, AWS region. For this bucket will be SCI Pacific Mumbai AP South 1, because we are in the Mumbai region only. That's why it's AP South 1. Now let's pass the demo 11 as a bucket name, and then go for the object ownership SCL disabled. So as of now I'm just doing the demo part, so I'm just going with the SCL disabled. If you want to create SCL enabled, you can do that. Object ownership, object writer, and all those stuffs you can do that. Here I'm going with the SCL disabled, that means bucket owner enforced. So the owner which is creating the bucket, that will be having the ownership of this bucket. Talking about the block public access setting for this bucket, there are four options. If I select the first one, block all public access, it's all public access will be blocked. That means your bucket is completely private. If I remove this and acknowledge over here that I acknowledge that the current settings might result in this bucket and the objects within becoming public. What does that mean? Block all public access. I have disabled this. That means this bucket has now been made as a public. It's not private anymore. But there are certain options you can select. Block public access to buckets and objects granted through new access control list. Correct? Or block public access to buckets and objects granted through any access control list. So if you provide any new SCL or the SCL any access control list, the access to the bucket will be blocked. Third option is block public access to bucket and object granted through new public bucket or access point policy. So there are a few options. I will go with this one, block all public access as a disable, so that we can do the demo. We will see that how you can create your public bucket. Here is the bucket versioning that we talked about here. The one of the feature of the bucket, the S3 bucket versioning, correct? That's the point here. Bucket versioning, either you want to enable or disable. For the demo purpose, I will go with the disable. If you want to keep the enable, you can do the enablement as well. If you want to pass any tag for this, you can pass the tag, or then you can do, if you want to create any bucket key or something, you can go with the default configuration or any your configuration according to your choice. Let's click on the create bucket. You will see the error over here. Why? Bucket with the same name already exists. What does that mean? That means this demo 11 bucket exists somewhere by someone in any region in any AWS account, correct? Because this Amazon S3 is a global service, that's why you are not able to create this bucket with the same name while there is no bucket. It's not the region specific, correct? You can see the description over here. Bucket name must be unique within the global namespace and follow the bucket name naming rules. So let me make it as unique. So let me put as man demo 11. Now this is unique. Let's click on the create bucket, and your bucket should be ready to launch. So your bucket is ready here. You can see there is no objects as of now. If you want to upload any bucket, you can create. If you want to upload any file over here, you can just click on the upload and you will be able to upload any files. Then there are permissions, there are permissions tab, then there are properties tab, and here in the properties tab, if you see, static website hosting is there. In the next demo we will be talking about this static website hosting, pre-signed URL, and other stuffs, correct? You can see the event notifications option as well. So we will be enabling this event notification as well. And if you see the permission tab over here to create your bucket policy, then you see the matrix over here. If you start putting any objects into this, you will see all the bucket size, number of objects, and management console as well, lifecycle rule, replication rule. So in the next video we will be talking in depth about the S3 buckets, how to do the other parts like the pre-signed URL, or how to do the static website hosting, replication rules, lifecycle rules. We will see that as well. And in the last we will be talking about the few S3 related commands, the AWS CLI commands that will, with the help of that, we will be directly communicating with the S3 buckets from the CLI. So that's all in this particular video. We will meet in the next video. Till the time, thank you, bye bye, and stay tuned. Subscribe to the channel for more technical content. Thank you. Welcome to day 25, where we are talking about the AWS tutorial and specifically about the AWS DevOps journey. In this particular video, we are going to talk about one of the property of the AWS S3 bucket, and we are going to talk about the pre-signed URL. Till this time, we have talked about the AWS EC2, BPC, Lambda, not the Lambda, launch template, auto scaling group, IAM roles policy, BPC, subnets, your the different properties of the EC2, user data, and the load balancer, the different kind of load balancer, path-based routing, and many more stuffs we have talked about. All these stuffs till the time. Here in this particular video, we are going to talk about the pre-signed URL specifically. So let's directly move to the AWS console and we will see the concept of the pre-signed URL. So before talking about the direct the use case of the pre-signed URL and the demo of the pre-signed URL, let's talk about the theory of the pre-signed URL. Pre-signed URL, as you can see from the terminology itself, it's the kind of URL which will be giving which will be given to a end user or to a API call for a certain time duration. What does that means? That means if you have an object within a bucket and you want that object should be accessible from the outside for 5 minutes, you want to give that access to that particular object or to that particular file for 5 minutes to a external user, you can create a pre-shunned URL for that object and you can give the access. Let's do the directly demo and you will see the use case of that as well. So here I do have a bucket created as band demo 11, and here we will be uploading one bucket, one object within this file, and then we will do the demo of the pre-signed URL. Let me click on the upload. I will be selecting add files, and here I will go into the S3 demo. I will be selecting text demo.txt. This is the content of the file. Hello, this is S3 demo, correct? And I will be getting into the open. I will just do the upload. Here text demo.txt file is there. Let's click on the upload. The file is uploaded, correct? You can see. Let me close over here. You can see text demo.txt. This file is created in this bucket. It is uploaded, correct? March 2 2025 and all these stuffs. If you select this particular file, click on the action, you see the concept share with a pre-signed URL. Click on this. What will do this one? What kind of facility this one will provide? Anyone can access the object with this pre-signed URL until it expires, even if the bucket and object are private. So your object might be private, your bucket might be private, but if you create pre-signed URL, this particular object can be accessed from the outside with the help of the URL what you will be creating till the time it expires. How do you mention the expiry? For that you do have the options time interval until the pre-signed URL expires. So let's create this pre-signed URL for 1 minute. Let me click for the number of minutes 1. Correct? Create pre-signed URL. I have created this pre-signed URL. Just click on the copy pre-signed URL. And now with the help of this pre-signed URL, I should be able to get the content of this file. Hello, this is S3 demo file. Correct? You can see. Hello, this is S3 demo file. But this will be valid for only 1 minute. So as of now you can see it's Sunday 2 March 10:50 p.m. Just after 10:51 this content will not be accessible for you, correct? So let's wait for 1 minute, and till the time we will go to the PPT and then we will come back, and this should result into access denied, correct? So let me go to the PPT and we will come back over here. After the pre-signed URL, we are going to talk about the static website hosting. What we will be discussing over here, we will be talking about how you can host your static web application into S3 bucket, and with the help of that URL, you can launch your static web application. You can see the content of that web application. You can paste any content over that, and you can host this application with the help of your S3 bucket, correct? For that we will do the demo. We will see the code which all will be related. Then we will be talking about the replication, how you can replicate your objects within the bucket from one region to another region, and so on. Then we will be talking about the lifecycle rules, where we will be talking about how you can move your objects, that means your data, from one storage class to another storage class. Then a storage class we have already talked about here in this last PPT discussion. In the last video I have talked in the detail about all these things, where you can talk about S3 standard infrequent access, S3 standard, S3 intelligent tiering, and all these things. So let's go to the AWS S3 bucket, and here we had created this pre-signed URL. Let me refresh, and now you see it has resulted into access denied. What does that mean? When we created this pre-signed URL, we just passed the time duration only for 1 minute, and just after 1 minute this URL is no more accessible, correct? You can see that means your pre-signed URL helps you to get the access of any particular object within the bucket for a certain interval of time, for certain time duration, for an external user. So in this video I wanted to talk about this pre-signed URL, and in the next video we will meet with the another topic that there we will be talking about the static website hosting and other stuffs. So till the time, stay tuned, do the subscribe, and we will meet in the next video with the newer content. Till the time, thank you. Bye bye. Welcome to day 27 of the AWS tutorial. Here we are talking about the AWS services and we are talking about the DevOps journey as well. In this particular video, we are going to talk about one another property of the AWS S3 bucket. And in this particular video, we are going to talk about the third point, that is a static website hosting. We will see how you can host your static web application into S3 bucket. Correct. If you have not watched out other videos, you can watch out other videos which are available on the channel that are based on the AWS EC2, the different properties, user data, elastic IP address, your launch template, auto scaling group, your load balancers, the different kind of load balancer, pathway routing, AWS IAM, roles, policy, users. We have also talked about the AWS interview questions. We have also talked about the BPC, subnet, NAT gateway, internet gateway, route tables, transit gateway, BPC peering, VPC peering, VPC endpoint, and many more stuffs. We have talked about the Kubernetes, CI/CD, and other stuffs as well. In this particular video, we are going to talk about the static website hosting. Let's directly move to the AWS console, and we will see how will we host our static web application inside S3 bucket. So let's directly move to the Visual Studio Code, and before that, let me go to the AWS console for the S3. Here we are in the S3. If you are not aware how to search for the S3 service, you can simply type S3 and you will be clicking on the S3. You will fall within this AWS console for the S3 console. Let's click on the create bucket, and here we will go with the general purpose. We will give the name for the bucket, and the bucket name should be unique. As you know, if you are not much aware, you can watch out the other previous video which are specifically on the AWS S3 bucket creation. Here we will be passing the unique name for our bucket, man demo-11, and we will go with the default configuration with this one, block or public access as disabled. So I'll be just making it the public bucket, and I will acknowledge this. Rest of the things I am going with the default configuration. Let's click on the create bucket. So our bucket is created. Correct. Now within this bucket, if you get into the properties section, here you will see there is an option called as static website hosting. If you click on the edit, it says use this bucket to host a website or redirect request, and for that you need to enable the static website hosting. So I have clicked on the enable section. Correct. Then it says that index.host a static website or redirect request for an object. I'm going to host a static website. Here I'll be clicking on the index.html. Correct. That means, what does that mean? I'm going to upload a file called as index.html over here. Correct. And here I'll be not passing any rule. I will be just uploading index.html file over here. Correct. Let me do the save changes. So now in the static website hosting, I'm saying that it has to fetch the code from index.html, and right now I have not uploaded any index.html over here. So will this work in any way? Let me click on this particular URL, and you will see there is no content over here. 403 forbidden, access denied. What does that mean? This bucket does not have any permissions to get into this, and even I will be adding any permission, this access will be this message will be removed. But as we don't have any object called as index.html, you will not be able to see any message over here. Correct. You will not be able to see any web application over here. So let me do remove this error first, and then we will go to the index.html creation. So for that, I will be getting the content from my GitHub repo, which is called as Manish Krishnavimal. This is public repo as well. You can get the content. So I'll be just creating this bucket policy for my bucket. Let me do the copy, and I will get into the permission here. I'll be creating the bucket policy. Let me click on the edit section, and I will just change the policy over here. Let me do this command V. Okay, I think it's not copied. So let me just copy this, command C, and then I'm doing the command V. Here I have to pass the bucket ARN, correct? What is the bucket ARN? Earlier I had this bucket created as Manish Tiwari. Now it's called as Manish Demo hyphen 11 slash star. That means on all the objects. Man demo 11, correct? Let me do the save changes and what is the error over here? Resource ARN S3 object and expected error for API response policy has invalid resource. What is invalid? Let me select this one I need to remove. Command V, and I don't think there's any error. Okay, now it's fine. So bucket policy is saved. Now let me refresh over here, and now you see the another message, no such key. Message, the specified key does not exist. Which key does not exist? The index.html, what we have mapped here, correct? Get into the properties section. Here, while labeling this static website hosting, we passed a file name index.html. So now it is going to get the content of that index.html and display over this URL, correct? But that file does not exist, so I will have to upload that file as well here, objects, correct? So for that I will get into the my Visual Studio Code. I will be just clicking on one file that will be called as index.html. Here I will be just pasting the content from my GitHub repo only. I will be just selecting all this content from here to up to the last. So let me just select this. Command C. Let me go to the Visual Studio Code. Let me just do the Control V and Control S. Most probably this should be saved. Let me go to the AWS S3 bucket, and here I will upload this. So let me click on the add files. Let me go to the index.html here. Let me select the open, and index.html is there. Let me click on the upload. Your file is uploaded. So here we do have the index.html now, and in this static website hosting we have mentioned the same index.html name. Now you should be able to see the content of this file. Welcome to my static website. This is simple static website hosted on AWS S3. Let's work together. This was all the content of the Visual Studio Code as well. Here you can see we had this header 1, welcome to static website, and the paragraph. This is a simple static website hosted on AWS S3. Let's work together, learn more. You see the same over here. Learn more as a link. Welcome to my static website as a heading H1, and then this is a simple static website hosted on AWS S3. Let's work together as a para. Okay. So this is how you can host your static website over the AWS S3 bucket. What you will have to do? You will have to just edit your bucket policy. You will have to pass the ARN of the bucket here with the permission S3 get object, put object, whatever the you want. We are just trying to get the content, so it's get object permission. You will have to upload this file index.html, and here you will have to enable a static website hosting. Here you will have to pass the index.html. So this is all you have to do for hosting your static website inside your AWS S3 bucket. In this particular video we wanted to talk about all this, and in the next video we will meet with some other content, and most probably that will be our replication rules, lifecycle rules, and then at the end we will be talking about the S3 CORS and running AWS CLI commands for the S3 bucket. So till the time, thank you, bye bye, and stay tuned with the channel. Do subscribe to the channel to get the more technical content related to the DevOps journey. Till the time, thank you, bye bye. Welcome to day 28, where we are talking about the AWS tutorial, and specifically we are talking about the DevOps journey. In this particular video, we are going to talk about the S3 CORS, that is your second last point of the Amazon S3. So CORS stands for cross origin resource sharing, and in this CORS concept we will see how we can fetch the content from one bucket to another bucket. What does that mean? That as we see that CORS, this CORS what we talked about, cross origin resource sharing, this simply stands for you are trying to make the communication between the two domains. Like if you have abc.com and the another domain is xyz.com, Now abc.com is the application which has to fetch some of the data from xyz.com. So it will make a request to the xyz.com and it will fetch the data, correct? For that, what you have to do, you have to tell that xyz that abc.com can come to you and it can ask for the data from you. So it needs to be authorized at the end of xyz, correct? Then only it can get the data and it can show to the end user by abc.com, correct? So the similar kind of thing we will do this in the S3 bucket. That's our concept CORS, cross origin resource sharing. So what we will do in this particular video, we will launch two buckets in two different regions. As you know, S3 is a global service and bucket are region specific. So that's why I'm saying that we will be launching two buckets in two different regions. First one will be in AP South 1, that's our Mumbai region. Second bucket will be in US East 1, that is your North Virginia region in terms of AWS Cloud, correct? So this is what we are going to do. We will launch one of the application, a static website hosting we will do here in the first bucket, and then we will try to get the sum of the data which is uploaded in the second bucket for the first bucket, correct? We will launch this static website application in this bucket, and that application will try to get some of the data from this bucket, and we will try to establish this communication. So this is what we are going to do in this particular video. If you are not aware how to host the static website, you can watch out the previous video where I have talked in detail how to launch your uh, first bucket, how to launch your static website application, and even about, we have talked about the other AWS services as well on previous videos. We have talked about the your use case of the cloud. We have talked about the AWS EC2, the different concept of the EC2 like the user data, elastic IP address, your auto scaling groups, your launch template, the different classes of the instance class. We have also talked about the different kind of load balancer, network load balancer, application load balancer, their use case, their difference. We have also talked about the VPC and in VPC in details like subnet, net gateway, internet gateway, VPC peering, endpoint, transit gateway, and so on. We have also talked about the IAM, roles policy, and user. And here we are talking about the AWS S3. Now let's directly move to the AWS console to perform this demo rather than just going into much depth. So we will directly move to the AWS S3 console. We will create two buckets and we will see how to launch your application and then establish the communication between these two. So here I do have this AWS console already open. I have already logged in, and here I will be searching for the S3, AWS S3, correct? So let me search that, and you can see right now there is no bucket, so I will have to create my first bucket. So I'm in the Mumbai region as of now. I will be clicking on the create bucket. I will just give the name of my bucket. So to make it unique, I will give it man demo -11. That's my first bucket. I will make my bucket as a public. That's why I'm just disabling this block all public access, and I will be just clicking on this. I acknowledge the current settings. Just go with the default configuration. Let's click on the create bucket. According to the diagram, I have to create the second bucket as well. So let me create the second bucket as well, but in different region. So let me do one thing. I have to open this in another console as well. So in another tab. Here I will be just changing the region, and let's go into the North Virginia. And we will create another bucket over here as well. So let me try creating the another bucket. This one I will just give as man demo -12. The first one was with the name man demo -11, and the second one is man demo -12. The similar thing we will make it public as well, and I acknowledge, and the rest of the default configuration. Create bucket, that is in North Virginia. As S3 is a global service, while the buckets are region specific, you will see both the buckets are reflecting here, but they have the different regions as well. That's why you can say S3 is a global service and the buckets are region specific, correct? Now what we have to do, we have to host the static website in first bucket, then we have to establish the communication. We will see how data can be fetched from the second bucket, correct, with the help of CORS, cross origin resource sharing concept. So let's try launching first static website in the first bucket. Here I will get into the properties, and at the last you will see a static website hosting. For that I will have to click on the edit and enable this static website hosting. Here you have to pass the file name in index document. So I will just giving the name index.html, and that's it. You don't have to do anything. Index.html I have just mentioned, and let's click on the save changes. You are now fine. Now let's try clicking on this URL, and you will see some response over that, correct, we will debug and we will find out, we will go up to the end. So I don't want to do all the configuration at the same time. We will go one by one, that way you will understand as well. So let me click on this URL. You will see 403 forbidden access denied. What does that mean? This URL, the static website hosting, this particular application URL is trying to fetch the content. And which content? The content what we mentioned, index.html. But it's not able to do that. Why it's not able to do that? Because there is we have not enabled this permission to be accessed. We have not given any permission to be objects to be public, correct? So for that, what we will have to do, we will have to create this bucket policy. So I'll be getting into this bucket policy, and for that I will have to get into this what we say, this notes. So let me get into this first code deploy, and this is my GitHub repo. Actually I have to get into the notes, and from here I will be just picking up the details what I have to do. So S3 CRS concept, I have already made the document for that, so I'll be just using these contents for my use case for this demo purpose as well. So let me just copy this policy, command C, and then let's get into the edit bucket policy, command V, and here I will have to rectify this bucket ARN. So let me just change this bucket ARN AWS S3 main demo -11 /star. That's our bucket ARN. And what is there mentioned? If you can see, the effect is allow, principal is a star, action is S3 get object. That means it can only fetch the data from the bucket. As of now, we are talking about the first bucket only. We are not getting into the second bucket as of now. So that kind of policy we are adding over here. So click on the save changes. Now when we have the save changes, we have passed the access. And just refresh and you will see another error as of now. The specified key does not exist. What does that mean? Now it's getting into this static website hosting. Now it has the access to fetch the content, but this index.html is not existing. Why? Because we have not uploaded any objects over here, correct? That's true. So let's get into the upload. Let's click on the add files. We will move to this what we say, this personal docs and the S3 demo. I have to go get into that, and I will be clicking on the index.html. And at the same time I will have to upload this extra page.html as well, but let me go there, and what we will do, we will just upload here index.html. Click on the upload, close, and let's refresh. You will see some response here, static website hosted, welcome to static website hosting demo. Here you see some of the one box is there. It's trying to upload something, but it's not able to do. What is it trying to fetch? Let's see that. So let's get into this network like inspection, and here if you refresh, you will see some of the API calls. So main demo, this website is trying to hit. It's not able to find two things here, Manish pic.jpg, which needs to be here, and extra page.html, which needs to be here. From where it is trying to fetch, so it is the part of index.html. So let me go to the Visual Studio Code, and here you will see the code as well. Here we do have my first web page, that is our title of the page, static website hosted, welcome to static website hosting demo. That you can see here, static website hosted, my first web page, welcome to static website hosting demo. What is there after that? It's trying to fetch this picture, manispic.jpg, and then it is trying to fetch one extra page.html. So let me try removing this, and just let's do the comment here. Let me do the save here as well, and I will try to upload this file as well, extra page.html, correct? Let me go back there on the AWS console side, and what I need to do, I have to re-upload this index.html. Why I need to re-upload? Because I have just made a changes. I have just commented the second line, and I have uncommented the first line where it will try to fetch extra page.html, correct? So that's why I have to re-upload this file as well. So let me try re-uploading it. So let me click on the add files, let me click the index.html, open. Let me select the second file as well, and extra page.html, open. Let me click on this manispic.jpg as well, click on the open. So these three files I need to upload. Extra page.html, why? Because it was trying to fetch this extra page.html. Then manispic.jpg, why? Because it was trying to fetch that. Then why I re-uploaded the index.html? Because I have made them modification in the code. So let's re-upload this, and then we will try to hit this URL. You can see everything is working fine, 200 response code, correct? static website hosted. Welcome to static website hosting demo. This is extra HTML web page. This is the part of extra page.html. Correct. Till this time everything is working fine. We have created first bucket, we have uploaded the file objects in this bucket, and we have hosted the website, static website as well. Everything is working fine up to the first bucket. Now what needs to be done? I will just delete this extra page.html file from the first bucket, which is here, and then we will see the other use case. So let me just delete this extra page.html, permanently delete. Let me just do the control C and delete. Okay, so this second page, the extra page.html, is now deleted. You will see the 404, that's there, no such key. Correct. What we will do, I will upload this extra page.html in second bucket, S3 bucket, US EC2. Correct, in the second bucket. Now we will try to establish the communication between these two. So I do have this second bucket, main demo hyphen till 12. What I will do, I will just click on the upload, I will click on the add files, I will go to this S3 demo, I will go to the extra page.html, I will just click on the open and just upload this file, extra page.html. Correct. Will that work? No, because we have not established any communication between these two. So will that work? No, it will not work. So for that we will have to establish the communication as well. Now what I will have to do, I will have to add the bucket policy over here as well. Why? Because the object needs to be accessed by this first bucket. So and this it is trying to fetch from this static website URL as well. So the bucket policy should be there as well. So let's try giving the permission here as well. So block public access, sorry, the bucket policy, I will have to add this bucket policy as well. So the same policy with the ARN, bucket ARN. So let me do the command C and then command V, and the ARN I will have to upload from here. Sorry, I will have to modify from here. So that's our ARN, man demo hyphen 12. And then let's do the save changes. Here also I will have to enable this static website hosting, because it's the one domain. This is the one domain, amazonaws.com. This is the one domain which is trying to connect with the second domain. That is, so what does that mean? That a static website hosted over here will now communicate with the static website hosted over here. So for that I will have to host the static website over in the second bucket as well. So for that what I will have to do, I will have to get into the properties section, I will have to get into the edit section, and I will have to enable, and here I will be just passing this index.html. It's just for enablement purpose and nothing else. So I'm not going to upload any index.html over here. It's just that we just enable the static website hosting so that it can do one DNS to another DNS communication. That's what we have established through the static website hosting. Correct. So that part is done. Now what is left? The main thing is left as of now. What is that? That is your CORS, cross origin resource sharing. So everything is there, but that is not. So let me try doing that part as well. So before that, what needs to be done? Let's try another thing from the code itself. So what we need to do? Let me get into the object URL, extra page.html. This is the object URL for that. Let me go to the code. Here I need to just comment out the first line, because I have to get the data from the second line. So I will just remove this. I will just change this particular URL. Sorry. And then I have just pasted the object URL. This is the object URL for extra page.html, which is the part of second bucket. So what my code will try, this index.html, which is in the part, which is the part of first bucket, will try to get into this object URL. Correct. This object URL is accessible actually in the public. Let me try showing you that as well. So if you click on this, you will see this is extra HTML web page. So it's accessible, but when it will try to get the content from second bucket, it will not be directly correct. So for that what I will have to do, I will have to do the changes. I will have to re-upload this index.html. Then you will probably see one error as well. So let's go through the error. That will be much better in terms of learning. So let me re-upload this index.html. I have to reopen, just click on the upload, and it's re-uploaded. So what we have tried till now, we have uploaded the extra page.html in this And then in the code part where we have launched this static website, we have passed the object URL, this object URL in the index.html, which is the part of first bucket, and we are trying to see whether it will work or not. So let me try refreshing it. What do you see? There is no error over the console, but it internally, because it's the part of code, you can see here, because it's the part of code, this it's trying to fetch, this index.html is trying to fetch this particular URL, but it's not able to do. Why? There is CRS issue. As you can see here, the object URL is accessible, but it's not able to fetch that content. Why? Because we have not enabled this CRS, cross origin resource sharing. We have not told to this second bucket that first bucket URL can come to you and it can talk. Correct. So for that I will have to enable this CRS as well. So let me get into there. I have to get into the properties, not probably in the permissions. CRS, yes. Get into this edit, and let's copy the content from here, this CRS part. Command C, and then let me paste it over here. And here you need to pass the first DNS, the first origin. It's the cross origin resource sharing, correct? So here in the second bucket, while when you are enabling this CRS, you have to tell that which DNS, which origin can come to this second bucket and it can talk to. So for that you will have to pass the origin, correct? So for that I need to pass this particular origin. Command C, and here you just need to replace this, and this is the first bucket URL of the website, a static website, which is the part of first bucket, correct? That you can see. Let's do the save changes, and here from the permission you can see allow headers, its authorization, which kind of method are allowed. So it's a get method which is allowed. So let's do the save changes, and here if you refresh you should see the content of the extra page.html, correct? This is extra HTML web page. So this is how you can establish the cross origin resource sharing between these two buckets, and you can establish the communication between the two buckets which are the part of the different regions, and the DNS, the origin from the first bucket, can fetch the content from the second bucket. This is the same which works in the application development as well. You try to establish the communication between the two different DNS, and that works, correct? So this is the all concept from the S3 CRS, and in the next video we might be talking about the replication rules and the lifecycle rules. That will be our short video, and then we'll be talking about the running command for S3. So till the time, thank you, and subscribe to the channel, stay tuned to the channel. So we are uploading like the different contents on the DevOps side. So till the time, thank you, bye bye. Welcome to day 29, and in today's video we will learn about lifecycle rules and replication rules of the S3. So in Amazon S3, S3 provides the feature of replication rules and lifecycle rules. How does this work and how to implement this? That's what we will see in this particular video. So without any further delay, let's move to the AWS console, and here we will create one S3 bucket, and then we will see how to enable the lifecycle rules and replication rules, both the things. So let's search for the S3, and here we will jump on the AWS console S3. Before getting into this S3 lifecycle rules and replication rules, if you are not aware about other properties of the S3, you can watch out the other videos which are available on the channel, where we have talked in details creating how to create S3 bucket, pre-signed URL, static website hosting, storage classes, S3 CRS, and many more details. Also about the other AWS services we have covered: AWS EC2, load balancer, auto scaling group, target groups, launch template, EIPs, VPC peering, transit gateway, net gateway, internet gateway, and so on. So in this particular video we are going to talk about Amazon S3, and that too on the lifecycle rules and the replication rules. So let's create a unique bucket, and for that we will just give the name man demo-11. That will be the unique one. So let's go with the other default configuration. Here I will mark my bucket as public, just for my choice. You can go with the block this particular thing as a enabled as well. That means private bucket. And for the rest of the things, let's go with the bucket versioning as a disable, then enable, and other things. But remember to make it lifecycle rules and replication rules, we will have to enable this versioning, because according to the version only it will do the or the rules will be applied. So we will see that further as well. So let's click on the create bucket, and here we go with the bucket creation. Probably yes, the bucket has been created. Let's get into the bucket. Here you see there is no bucket, and we are not going to upload any bucket here. We will just see how to create the roles. So here in the management section, within the S3 buckets, within the management section, you have two options: lifecycle rules and the replication rules. In lifecycle rules, you can see there is use lifecycle rules to define actions you want Amazon S3 to take during an object's lifetime, such as transitioning object to another storage class. When it says another object, another storage class, what does that mean? If you want to move, like let's go to this particular slide. Where is that? Amazon S3, yes, this one. So if you want to move your objects from this S3 standard to S3 Glacier Deep Archive, you can create lifecycle rules. What does that mean? Earlier, when you create S3 bucket and you start storing the data, that goes into the S3 standard. But the moment you start thinking of making your cost much easier, cost effective solution, you can think of putting forward your archival data from S3 standard to S3 Glacier Deep Archive. So this will save your cost as well, because both the every storage class has the different cost associated with it, correct? So that way you can save the cost. So in the archive, in the S3 Glacier Deep Archive, your data will be there, and it will be non-touchable, like it will be very less accessible, and after some time even you can delete this data from the S3 bucket itself, correct? So for that you can move from here to there. So for that there is a lifecycle configuration. Here if you click on the create lifecycle rule, you pass the name demo, whether you want to limit this scope on using on some data, like based on some filter, like whatever the object starts with or end with mp4 or ends with the jpg, that this rule should be applied only on that, or you want to apply on all objects. If you click on the apply to all objects in this bucket, you have to acknowledge. Once you acknowledge, let's move to the next actions. Live transition current version of object between storage classes, correct? So object between storage classes, non-current, current version, which object you want to move from one storage class to another storage class, that all options you have here, and you can configure it according to that. Just acknowledge here, and now you have to select that in which storage class you want to move it, correct? So for that you have the option this what do we say, choose a storage class transition from standard what was there, S3 standard, correct? From S3 standard to S3 standard IA, or in which storage class you want to move. So for that you can select from here, either you want to Glacier Deep Archive on what number of days. So you can select whenever my data gets 120 days older, it should move to the Glacier Deep Archive. So for that you can select this the number of days. So if you see the current the details over here, review transition and expiration action, current version actions, day 0 object uploaded, and after 120 days your objects will move to the Glacier Deep Archive. So that's the way how you can create your lifecycle rules. Now let's move to the another one, replication rule. For this one, if you see the definition itself, which is on the AWS console, it says use replication rules to define options you want S3 to apply during replication, such as server-side encryption, replica ownership, transitioning replica to another storage class. So these replication rules can be used for moving your objects from one bucket to another bucket in the same region, in another region, same account, another AWS account as well, correct? So for that replicating this data, here it was that moving the objects between the different storage class. Here it says that you want to keep the backup, correct? So for that you can clear the replication rules. Let's get into this. For this replication you will have to enable versioning as well. Replication requires versioning to be enabled. Based on the version, like up to 2.0 or up to 100.0, the object should be replicated, and the current version will be there. Once it gets 1 day older, it will be replicated according to the newer version, correct? So for that you will have to enable. So replication is versioning is enabled now. Here you create replication rule name as demo, status enabled. here you can select in the similar way whether you want to apply for few objects or apply to all objects. Choose a bucket in this account or specify a bucket in another account. So if you have another bucket in the same account, you can select that. You can pass the name here, or you can click on the browse S3. Then region, if you want select in another account, so accordingly you can select the region as well. Then the role and the permission, like you want to delete, you want to replicate, so all those kind of permissions and other details you will have to pass in the IAM role, and that IAM role you can configure from here, just like the demo role or any permissions you want to create, you can select that. Then in encryption and the destination storage class, so in if which storage class if you want to move. So suppose that earlier in the primary bucket you have the data in standard, and then you want to move it to the from a standard to the Glacier Deep Archive. So in the similar way you can select over here. Whenever the data gets replicated from first bucket to the another bucket, it will move to the Glacier Deep Archive at the same time. So in the that way you can create your replication rules as well. You can click on the save and your replication rule will be there. So this is how you can implement your lifecycle rules, your replication rules in your S3 bucket, and with that way you can either replicate your data or you can save your data as well. So in this particular video I wanted to talk about these two concepts as well, and we have covered the Amazon S3. If anything is left, you can put down that in comment and I will try to create the video on that as well. So till the time, thank you, and stay tuned to the channel and subscribe to the channel as well. Thank you. Welcome to day 30, and in this particular video we are going to talk about Amazon RDS. So it's one of the AWS services which is provided by the AWS Cloud, and this service is particularly for the data base, correct, for the storage, correct, for the data storage. So in this particular video we are going to focus on this Amazon RDS, and we will deep dive from the theoretical perspective, and we will also deep dive from the demo perspective as well. So in this particular video we are going to learn about this, and we will create one of the database as well. So we will see that throughout this particular video. So if you are new to the channel, you can watch out the other videos which are available to the channel. You can go through the AWS EC2 other concepts, user data, EIP, your auto scaling group, launch template, load balancers, the path-based routing. Even you can go through the VPC, NAT gateway, internet gateway, VPC peering, transit gateway, endpoints, IAM role policy, and S3, the how can you host your static website, how can you create your management rules like the lifecycle rules, replication rules, and so many stuffs on the S3 as well, correct, the S3 CRS concept and everything. In this particular video we will focus ourselves on the RDS itself. So let's get started with that. Amazon Relational Database Service, as you can see from the first point, is an easy to manage relational database service optimized for total cost of ownership. So as you know that AWS Cloud provides pay as you go model. What does that mean? The moment you will be utilizing this RDS instance, you will be charged for that particular RDS instance, correct? And within one RDS instance you can have the multiple database as well. So RDS will give you a kind of infrastructure, kind of schema, or you will say the infrastructure where you can create your own RDS instance, and within this RDS you can have either one database or the multiple database as well, correct. Then RDS automates undifferentiated database management tasks such as provisioning, configuring, backing up, and patching. So even you can do the upgrade on your RDS instance, you can configure your RDS instance from the security perspective as well, that which kind of request can come to your RDS, the database, correct, which kind of request can go outside. Even if you want to keep the backup of your data, for that you can have the snapshot, you can have your primary or secondary database concepts as well, and you can do the replication. So all these features are provided by the RDS itself. It allows customers to create a new database in minutes. So there is console where you will fill in the details which RDS AWS RDS will ask, and just you fill in, and within a few minutes you will see that your database is ready to be used, correct. So that way you can even create the database. Customers can optimize performance with features like multi-AG or your cross-region replica, that feature. So what does that mean, multi-AG? That means your database will be available across the multiple availability zone. Suppose that you are creating your RDS instance in AP South 1, that's your Mumbai region. So it will be available across three different availability zones, AP South 1, A, B and C. For that, what you will have to do, you will have to select all these three subnets, correct? So subnets is the part of networking, correct? So if you have to make it highly available, you will deploy it in multiple availability zone, and behind the scene it will be deployed into multiple availability zones which will run as a standby, correct? Then you, when you can to make it highly from the performance perspective, if you want to make it like the RDS instance should be more tends towards the performance. So for that you can select AWS Graviton based instances as well, like T4G dot medium, C5G dot medium, those kind of Graviton based instances you can select for your RDS instance. Let's move to the other slide. What are the features of Amazon RDS? It's easy to manage, removes inefficient and time consuming database administration. Choice of engines, like you have the multiple engines available over there, either your Postgres, within the Postgres the multiple versions of the Postgres are available. You can go with the Aurora DB, you can go with the other IBM DB2, MySQL and other available engines as well. Highly available because it gives you the flexibility to deploy your RDS instance into multiple availability zone, or even the cross region replica as well, correct? You can see the cross region replica as well, or the multi edge. Operational expertise, no need of dedicated expertise, correct? So it's the AWS Cloud who is managing your RDS instance from the behind. You will have the control on your data, you will have the flexibility on your data, you will have flexibility to uh, maintain the security as well. But behind the scene, to make it highly available, there's AWS Cloud. So you don't have to pay anything to do the operations kind of thing, correct? Security, you can encrypt it with the KMS key, and that KMS key can work as a encryption key to protect your AWS resources, correct? Or the even the AWS RDS instance. Private or public, you do have the options to launch your RDS instance either in a private mode or in a public mode, and there is a options to do the protections as well, correct? So whether your database can be accidentally deleted or not. So these are all the theory part, and here if you see the comparison between the SQL and NoSQL database, this is the type of your SQL database which Amazon RDS is, correct? While you get into the DynamoDB table, that is NoSQL. So in the DynamoDB table, if you see the NoSQL format, it's a kind of your JSON format, the key pair value. While in the SQL format, if you see, it's a row and column format, correct? It's in the tabular format. So that's the difference between the RDS, Amazon RDS and DynamoDB table as well. If you see the theoretical comparison between these two, the RDS stands for your SQL format and DynamoDB stands for NoSQL format. While talking about the scalability, RDS can scale horizontally and vertically both, while DynamoDB automatically scales tables to adjust for capacity. So the data grows, the your JSON table will start growing, correct? So DynamoDB will do the auto scaling, but this RDS instance can be horizontally and vertically scaled. If there is a requirement of scaling it in terms of storage, that you can change. If you have to change the instance class for this RDS, that you can change. Talking about the cost, RDS is more expensive, but it gives you the more organized data, while the DynamoDB is less expensive because it has a kind of unorganized data, correct? So it's a kind of JSON format. You have to do the parsing and all those things. Features and flexibility, RDS provides the more features, that's why it's more expensive. DynamoDB goes with less features, less expensive, correct? Applications or the use case, popular choice for ERP, CRM, correct? While DynamoDB table can be used for real-time bidding, shopping carts, mobile application, and high IO nets. Table format like rows and columns, that's the format to store the data in RDS, while DynamoDB supports JSON and XML. So these are the way how your data is stored in the AWS RDS and within the DynamoDB table. Now let's move to the AWS console and we will see how to launch your RDS instance. So let's go to the AWS console here, and here we will search about the RDS. click on the RDS, Aurora and RDS, and within the few seconds we will see the AWS console, which will be having the options to create your first RDS instance. And we will also talk about the prerequisite which we will require before launching your RDS instance. So let's get into the databases. Here if you see, right now there is no database at 0, correct? Now if I click on the create database, we will have to give few details, and for that what I will have to do, I will have to just suppose that let's go with the PostgreSQL. So that's the engine version I'm selecting. Engine options, I'm going with the PostgreSQL. Here I will be giving the engine version, the latest one. I'm going with the default one, 17.2. Then templates, which kind of template you want to have for your RDS instance. Use defaults for high availability and fast consistent performance. This instance is intended for development use outside of a production environment. So you can go with either free tier dev test or to the production. So based on that this configuration, your RDS instance will be available, will be that kind of available, correct? So as of now I'm going with the production one. Then availability and durability, either you want to deploy in multi-AG DB cluster deployment, 3 instances, correct? While your read write on read can be on your availability zone 1, plus there will be two a standby kind of instances which are in other availability zones. So if we are in episode 1, so availability zone 1A will be the one where we will do the write and read, while these two instances will work as a standby. Whenever this prime episode 1A goes down, these two things will start working, correct? So as you can see, this setup provides 99.5% uptime, redundancy across availability zone, increase read capacity, reduce write latency. While if you deploy your multi-AG DB instance deployment or single availability zone DB instance deployment, that means one instance which will work as a primary, while multi-AG, that means multiple availability zones. So it goes with your one availability zone instance as a read write, and second as a standby with no endpoint, correct? So as you can see, create a primary DB instance with a non-readable standby instance in separate availability zone with the 99.5% uptime, redundancy across availability zones. So I'm going with this second option, multi-AG DB instance deployment, 2 instance, correct? Here you can give any name to your database identifier. So I'm just going with the demo DB, that will be name, and whatever the username you want to pass here, so let me give as the master, that will be my username. And credentials management, how do you want to manage the credentials, like for this database, correct? For this RDS instance, you might have to connect as well, correct? When you are launching the RDS instance, of course you would like to connect this RDS instance. You would like to create your RDS databases. You would like to create your tables, row, and all other stuffs you would like to play with your RDS instance, correct? So for that you will have to require this host endpoints, then the passwords and other stuff. Where do you want to store all this? Either you want to self manage or you want to store it in the AWS Secret Manager. So Secret Manager is one of the other AWS service. You can see here AWS Secret Manager, and here it stores all the credentials related to your databases, correct? So if you see, so it's a bit slow loading. So here you can see this store a new secret, correct? So you can store all the endpoints related things. As of now there is no secret, but the moment we will create the RDS instance, you will see that secret as well. Then the encryption we talked about, how to encrypt you the RDS instances, correct? So you can use this AWS managed encryption, AWS Secret Manager default one. Then the instance class, which instance class you want to select for your RDS instance. So if I go with the DB bus table, dbt3.micro, t4.g, t4g.small, or other available instances you can select. T3.micro will be a bit slow, so I will go with the t4g.medium, or let me go with the t4g.xlarge to make it a bit fast. Or let me go with the standard class, so I will have to go with dbm5.4x large. Let me go with this one. Might be it goes with a faster speed, correct? So that we can cover up in the demo a bit fast. So db.m5.4x class I have selected, and then for the SSD I'm going with this general purpose SSD, and let me go with the 20 GB. That should work. Allocated storage value must be 20 GB, so I have gone through the 20 GB. So this is the kind of a storage type. Moving forward, if you want to connect with the endpoints, so you can go with the connect to an EC2 compute resource. There one EC2 instance will be created, and that will be linked with your RDS instance. From there you can access your RDS instance directly by running the commands. Here I am going with the don't connect to an EC2 compute resource, and in which VPC you want to launch your RDS instance. So as of now there is a default VPC, so I'm just going with the default VPC as well. If you want to change anything, so you can create a new VPC and that VPC will pop up here, that you can select that as well. Correct. Then the subnet groups. So these three subnets which are available within the default VPC, that is coming over here. So this subnet group will be created. As of now, if you see, most probably there should not be any subnet group because I have not created. So let's see default VPC. Okay, so the default subnet group and default VPC, all the things are available there. If you want to create your own custom subnet group, you can launch your own VPC, you can launch your own subnet groups, and with the help of that you can create your own subnet group as well. Here you will click on the create subnet group, you will pass the details, you will select your VPC, you will select your subnets from here based on the availability zone. All the subnets will be here, then you can create. Correct. So that thing you can do. Then publicly accessible, you want to make your database publicly accessible or not. For that you can select yes or no. I'm going with the yes. Then VPC security group, you want to select create a new security group, or you want to select the existing one. So I'm going with the default because I'm just going through the demo. That's how can you create your RDS instance, and what are the usage of these features. That's what we are talking about. So VPC security group, from here you can select and then go with the other details. Database authentication, you want to authenticate your database, like you want to log in your database through the password only, or you sorry, you want to do IAM database authentication as well. That means you create one role, and through that role you will grant the permission to access your database. Correct. So this can be utilized for a real project as well. Here we can go with the password authentication just for the demo purpose. Correct. Then monitoring, if you want to enable database insights advanced, database insight standard, so you can go with this retention period, enable performance insights. If you enable this, you will see that your performance insights will come from here. From here you will be able to see the performance insights. As of now you won't see any because there is no database, but as soon as you enable this performance insights, you will find that those database listed over here, and from there you can select that which SQL query is taking much time, and all those connections related things, all the metrics related thing will pop up over there. So for that you can enable performance insights. That is 7-day free trial, then a KMS key ID and other things. In additional monitoring settings, if you want to do, you can do, or you can disable this. Then this one also I'm just disabling. Additional configuration, click on here. Enable automated backups if you want to take the backup of your data. So for that you can enable the automated backups, and this backup will remain for 7 days. Backup retention period, the number of days for which automatic backups are kept. So the backup will kept for 7 days. If you enable this, if you disable, then there will not be any backup. Anytime you can change these settings. Correct. So I'm just going with no maintenance. I'm going with the disabled options, maintenance window, no preference. Delete protection, that's the last point I wanted to talk about this. So if you enable this delete protection, once you create the database, you will not be directly able to delete your database till the moment you come into the settings part, you change this from enable to disable, and then you will be able to delete this. So the moment it will be enabled, you won't be able to delete any database. So this saves your database from accidental deletion. Correct. So this is what we are talking, and here you see the estimated monthly cost. DB instance 29555 2955.04 USD. Storage and total charge will be this one for the 1 month. So approx 3000 USD you will have to pay with all these configurations. With the DB T5, I think we selected as an instance class. what then dv m5.4 x large I had selected. So according to this instance class and all this configuration, you will be charged this much. So once you click on the create database, your database will be launched, and then with the help of endpoints and other stuffs, you can connect your database. So probably in the next video we will see how to launch and how to connect your database from the any other tools available, or we will see that as well. So in this particular video I wanted to cover up to this much only, not going into the much details, so that the video itself will not be much lengthy. So we will come up with other details of the RDs in the next video. Till the time, thank you so much, and stay tuned. Subscribe to the channel for other contents. Welcome to day 31, and in this particular video we are going to talk about the AWS Lambda. So in this video we are going to focus on this Lambda one, and we will talk about this service in detail. We will cover the theory part, and also we will see how to create your first Lambda function from the AWS console itself. Correct. So this is what we are going to cover. So before this, we have talked about the AWS EC2 instance, AWS BPC, AWS IAM role policy, AWS S3 buckets, and AWS RDS services. And we have talked in details like the load balancer, path-based routing, launch template, auto scaling group, BPC peering, transit gateway, NAT gateway, internet gateway, your transit gateway setup for multiple to establish the communication between multiple BPC. We have talked about the AWS S3 buckets, how to host your static website, how to enable this S3 CORS concept. All these things we have talked in the details. And with continuation to our DevOps journey, in this particular video we are focusing we are targeting AWS Lambda to cover up. Correct. So we have talked about the EC2 instances before, correct? So that was the compute server where we were focusing on how much memory, how much CPU we have to allocate according to our use case, correct? If we had to host our application, so according to our use case, we had to decide where we had to use T3.medium, T4.large, and so on, correct? M5.x large. So these kind of instance selections we had to do. Here, AWS Lambda is called a serverless compute service. As you can see, the first point itself, it's called as serverless compute service. What does that mean? That means you don't have to worry about the how much CPU, how much memory is going to be utilized over here. What does it enables? It enables you to run code in response to events without provisioning or managing servers. That means here you don't have to worry about the provisioning of the servers, the actual servers, the servers, just like the EC2, correct, where you had to provision the EC2 and you had to focus on the infra side, how much memory, how much CPU you have to allocate. Here you don't have to worry. You will just write the code, you will run that code, correct. It might be triggered from some other AWS services, or it might be triggered from the AWS event bridge, your cron expression or API gateway, or from some other AWS services, correct. But you don't have to worry about anything about the servers detail. What's the second point? With the Lambda, you upload your code and define the condition for execution, and AWS takes care of the underlying infrastructure. So you just have to write down your code, you have to define your logics, conditions, and it will execute the things. You don't have to ultimately worry about the infrastructure, correct. All the underlying infrastructure will be taken care by the AWS Lambda itself. Auto scaling and managing resources as needed, correct. So either it will scale up the number of servers, either it will scale down the number of servers based on the requirement and for how much long it has to run, correct. So this is also covered by the AWS Lambda itself. Then you can run a trigger of 100 triggers. Lambda will scale automatically, correct. So that's your third point. Supported language, you can write down your code either in the node.js or the Python, the Go, Java, and many more technologies, correct. So this is the properties of the Lambda function. And if we talk about the key concepts of the AWS Lambda, the first point is it's an event driven architecture. What does that mean? It can be triggered by some custom events or by the AWS services. So what AWS services can be there? For example, let's consider the S3. So you can run your code in response to file upload or deletion. So just suppose that you have a one S3 bucket and you upload some of the objects, some of the files into your S3 bucket. A Lambda function can be triggered due to, with response to this upload or deletion of the file into S3 bucket. The Lambda function will execute, either it can parse that file, it can do some logic operations on that, and it can perform certain actions according to your logic, correct? So that kind of trigger point can be set from the S3 to the Lambda. Then there is a DynamoDB table. It can process changes in table. Then API gateway is there. Whenever there will be get or post kind of call, the API gateway will call the Lambda function, and Lambda function will execute its logic, and it will perform some actions to either upload the data or to fetch the data. That kind of actions it can be done, correct? Then SNS and SQS, then there is a event bridge as well, which can be integrated with your Lambda function to do the event driven architecture, correct? Then what are the benefits of the Lambda function? So after this we will go to the AWS console as well. We will create our first Lambda function. Before that we are going through the theory, correct? And if you have not subscribed to my channel, so you can hit the bell icon as well. You can subscribe the channel as well, so that it will be easy for me as well to create some more such contents that will inspire me, that will motivate me as well. So what are the benefits of the Lambda function? The first is it's a serverless model. So you don't have to manage the servers, correct? AWS handles the infrastructure. So whatever the infrastructure is required to deploy your application, to run your application, all the server will be managed by AWS Lambda itself. So that's why it is called as serverless. You don't have to worry from end user perspective, correct? Second point stands for automatic scaling. Lambda scales automatically with the number of incoming requests. So the number of requests increases from 100 to 1000 to 10,000. The scaling of the infrastructure will happen automatically, correct? Third, cost effective. So as you know that AWS Cloud itself is on the model pay as you go, while Lambda function comes with more benefit as well. You have to pay for only that time slot, or only that time period for which your code has compiled or code has executed, correct? So as you can see the terms here, you pay only for the compute time you consume. So if your code is running for 1 minute or 10 seconds, you have to pay for 10 seconds only. While if you talk about the EC2 instances, you launch your EC2 instance, your cost starts, correct? Whether you deploy now or you deploy after 5 minutes, you have to pay the cost associated with the EC2 because it's in the running state, correct? While the Lambda function does not work in this way. The time period Lambda function will be executed whether 10 seconds, 1 minute, 5 minutes, 10 milliseconds. You will be paying only for those particular time duration only, correct? So no charges when your code is not running, correct? Then fourth is integrated with the AWS services. It can be easily integrated with AWS services to make event driven process within your AWS ecosystem. So in the similar way, what we talked about, the S3, DynamoDB, Event Bridge, API Gateway, SNS, SQS, all these things can be integrated here, and that's the actually the benefits of the Lambda function. You can create your event driven architecture to do some operations, correct? Then what are the basics of the Lambda functions? So you will see the handler function that we will create, the runtime environment we will do, and the execution roles, like what kind of roles and permission you want to grant to your Lambda functions, that we will cover up. So before talking much about in this, let's go to the AWS console, and we will see how to create your first Lambda function. So here we are on the AWS console side, and let me search for the Lambda function here. You will see this Lambda, and let's click on this, and within few seconds it should get populated, and here we will try to create our first Lambda function, correct? So as of now you can see there is no Lambda function, so let's click on the create a function, and I'm not going to integrate with anything. I'm just going to simply create one Lambda function, and the integration of the Lambda function, this one we will talk later on. So we'll be covering these three use cases: create event notification from S3 to Lambda. What we will cover in this, we will cover that whenever you upload a file into S3 bucket, Lambda function will be executed and it will print the content of the object or the file, correct? So that we will set up. Then we will set up these two popular use cases where in terms of the operations, so auto start RDS and auto stop RDS. So what it will cover, it will cover that whenever you want to stop your database, so most likely you might like to stop your databases on the weekends, correct? On the Saturday Sunday, your dev test kind of, or the non-production databases you can stop to save the cost, correct? While from Monday to Friday you will keep all the database up and running. You can even shut down your databases in the evening after the 10 p.m. up to the 8 a.m. morning, correct? So these things can be set up, correct, to save the cost if your team is not working in that particular time duration. So these are the two popular use cases in terms of the DevOps, in terms of the operations perspective. So these two things also we will cover up. In this particular video, we will be talking about simply create a one lambda function only. So here I am creating as a demo function that I will call demo function. The technology or the runtime programming language I will be selecting as Python 3.9. Then you can either go with the x64 ARM64 or according to your uh, requirement. Then the role we were talking about, correct? Change default execution role. So either you can create a new role with basic lambda permission, you can use existing role if you have created earlier any role that you can use, or you can create a new role from AWS policy templates, so that you will have to pass here the policy and all those things, correct? So either I can select the existing one what I might have created before. So RDS stop role, I think this one I have created before, so this one I can use, or I can create a new one, correct? So it will automatically create. So let's go with the create a new role with basic lambda permission. Create functions, and you will see that lambda function will be created within seconds, and you will see all the default properties, all the default configurations of the lambda function will be there. So let's wait for a few seconds, and yes, successfully created the function demo function. Here your demo function is created. Here if you see the options, there is an option to add triggers. So triggers we talked about here, correct? So we talked about these triggers, either the S3, DynamoDB, API Gateway, SNS, SQS, all these things can be associated here as a part of your trigger. So if you click on the trigger, you will see the available options. Either you can attach this Alexa, API Gateway, code commit, you can select your CloudWatch logs, you can select your event bridge, you can select your S3, SNS, SQS, and all these are the different services, different your the partner event sources. With the help of that, you can uh, create your trigger which will execute your lambda function, correct? Then you have this configuration section, correct? So as you see in the configuration section, if you add the trigger, that trigger will be here. Then in the permissions, the role we were talking about, so here you will see the role which is created and what are all the permissions associated with this. So even you can see from the console here as well, the allow logs, create log group, but here also you can see the same role. So this is the role which has been created automatically by the lambda function, and this is the policy which is attached. So what are the actions? It's logs, create log group, create log streams, put log events, and this is for the demo function, AWS lambda demo function. Which resource? This is the lambda function ARN, correct? So this is the role has been created, and who can assume this role? So lambda amazon aws.com. So apart from that, there is a destination. This is not of any use, and you can integrate your VPC if you want to make it in the private subnet or that kind of network if you want to bound. So for that you can integrate your VPC here. You can click on the edit. You can select your default VPC. You can select your subnets according to the availability zones, the different subnets you can select. Then environment variables, like if your code has some of the variables, you want to pass some variables value from the lambda function in your code, correct? For that you can click on the edit. You can add the environment variables over here. You can click on the add environment variable. You can add key value pair, and that key value pair can be utilized in your code. here is the code. You can write down your code over here and you can deploy the code. Once you deploy the code, you can click on the test and your test will be what we say, your test will be created, and according to your test you can see the response, and that response will help you to understand whether your code is working fine or not. Correct. Then you see the other details. The code property is 299, the packet size of the code 299 byte, and this is the function call uh, calling way. Correct. So we are using Python 3.9 and handler is lambda function dot lambda handler. So we will have to define lambda handler over here in the code, as you can see directly from here as well. So the one lambda handler is defined, and in the lambda handler we will call our other functions whatever we will define. Correct. So lambda function will call lambda handler, and lambda handler will call ultimately all the different functions what you will be defining over here. So this is how you can create your lambda functions. You can monitor as well. You can click on the monitor section. You can see the CloudWatch logs if there is any logs which is being populated. That you can see. You can see how many times your lambda function has been invoked and other details here in the CloudWatch matrix. So for how many number of times your lambda function has been invoked, how many for how much duration it has been invoked, what are the error counts, success rate, total concurrent execution, throttles, and other metrics which are available here over here. So all these things you can monitor from here, and you can work with your lambda function. The CloudWatch logs we were talking about. So whatever the code execution will happen, and according to your logging what you have written, you will see some of the log streams will be generated over here. Right now we don't have anything, so it is not reflecting anything, but as soon as you will write some code, you will write some logic, you will do the execution, log streams will be populated over here, and you will be able to see those log streams. So this is the way how you can create your lambda function. You can work with your lambda function. You can do the trigger mechanism over here, and your lambda function will work. So in next video we will be talking about the any particular use case. We will start with the create event notification from S3 to lambda, and then in another video we will cover up these two. Correct. So till the time, thank you so much for watching this video, and stay tuned to the channel and subscribe to the channel for more such contents. Thank you. Welcome to day 32, and in this particular video we are going to talk about how to set up the architecture where we will create one S3 bucket, we will create one lambda function, and we will see the use case of event notification. So if you remember, in the last video we had talked about the AWS Lambda functions. In the AWS Lambda function, what we discussed, that we will be seeing the use case of all these three categories. Correct. So the first one was create event notification from S3 to Lambda. What does that mean? That simply means we will upload one file in this S3 bucket, and whenever we will upload a file in this S3 bucket, that will trigger one Lambda function, and that Lambda function will have some code logic that will work, and according to that it will populate the bucket name, the object name, that means the file name which is uploaded in the S3 bucket, and also it will parse that content, and it will show it in the logs, the within the log group itself. Correct. So this is the thing what we are going to cover up in this particular video. Before this, we have talked about the AWS EC2, we have talked about the AWS BPC, AWS IAM role policy, AWS S3, and we have talked in the details like the path-based routing, the load balancer, then target groups, launch template, auto scaling groups, VPC peering, VPC transit gateway, your VPC endpoints, IAM roles policy, S3 static website hosting, your S3 URS concept. So we have talked all these things in detail. So you can go through all those video to understand the AWS Cloud to get started with the AWS Cloud. So here, without any further delay, let's directly move to the AWS console, and there we will create one S3 bucket, one Lambda function, and we will do the setup to generate these flow logs and to set this event notification from S3 to Lambda function. So let's get into the S3 bucket here. So here I will be searching for the S3. Let's get into the S3 console, and we will be just creating one simple S3 bucket, And before that we will require the lambda function as well. Why the lambda function? Because based on that one only we will do the event notification settings. So before that, let me get into the create bucket. Here I will just pass a one unique name for my bucket. So I will be creating as a man demo 11 publicly accessible. I will mark my bucket as a publicly accessible. You can go with the this function as enable as well, where block all public access. For now, my use case, I'm just going with the public bucket. Then rest of the things we will keep it as default, and let's go on the creation of the bucket. So your bucket creation is in the progress, as you can see, and your bucket has been created here. What we will do in the properties section, if you see, there is an option of event notification. So if you click on the create event notification, here you will see the options what you want to use. So either you can use the lambda function, you can use the SNS topic, SQS queue, or other things. Right now we have not created any lambda function, that's why it's not getting populated. So what we will do, we will create one lambda function as well here. Let me go there, and I will be creating one lambda function. So here we do have the option to create a function, and here I will just giving the name demo function. So this is the function name I am passing, demo function. The programming language I will be selecting as Python 3.9, and rest of the configurations will be the default. Here you have to attach the role and policy, correct? So either you can use the existing role, you will have the option to select from here, or what you can do, you can click on the create a new role with basic lambda permission, correct? So let's go with that only, and we will do the modification according to our requirement. So let's go with that. Let's click on the create function, and your function will be created. The moment your function will be created, we will try to upload some of the code as well. And from where we will get the code? For that, we will get into our uh, public GitHub repository, which I have created, correct? So I will be picking up the code and all those things from there only. So here we do have the option to change the code. As you can see here, code source, we do have the options to upload our code. So what I will do, I will get into my public GitHub repository where I have created the nodes S3 to the lambda. So this is my particular code. This one I will be using actually. So let's do the copy, and here I'll be just pasting this particular code. Command B. What we are doing? Let me scroll up. Import JSON. That is that one we are importing. Then we are importing Boto3 to connect with AWS services. Correct. Then we are creating this lambda handler. If you remember, when we were talking about the lambda functions, we discussed that there will be one lambda function dot lambda handler that will be there. Where is that? So okay, this one we have talked about, correct? Handler function, lambda function dot lambda handler. So we define one lambda handler in our code, and then if you want to define any other function, that you can define, and all those functions will be called in this lambda handler, correct? So here we have defined lambda handler, and then s3 equal to boto3 dot client. That means this particular function will be connecting with the AWS service that is called as s3. Then it will pick up for the bucket name, and from where it will keep fetch this bucket name. For that we are passing records, and like event records, and then 0 s3, like here it has connected with the s3 service. Then we are communicating with the s3 bucket name. So it will parse all the it will parse the s3 service, like it will get into the s3 service, and it will list down all the buckets. From there we will list down the bucket object as well. For which s3 bucket? For all the s3 buckets, correct? Then we will print hello from s3, a simple custom message. Then we will print the bucket name, then we will print the object name as well. That means which file we are trying to upload. Then in the response we are storing the data s3.get object, and we will find the object, that means the file itself. Then we will print the content of that file, print response, then data, what is there in this particular response, that we will print, correct? Print data, print event, that it will print there, all those things. So let's click on the deploy. So this will save the changes, like, so when we say the deploy, that means all this code changes will be saved there. Click on the test, and here we will just click on the create new test event, and here I'll be passing as a test, correct? Then save. Once it is saved, we can click on this, and let me just mark it as a blank. Here I'll mark it as a blank, Let's click on the save and invoke. Correct. Validation error, unable to save. Okay, what is the message error? In Lambda handler bucket name and records. Acha, this needs to be connected with your S3 bucket itself. So now let's get into the S3 bucket here, and it will try to fetch. Correct. You can see that it resulted into error because it did not get any S3 bucket and all those things. So it got failed. So what we need to do, let me get over here, and I will just refresh so that we can get this Lambda function over here. So I'm creating the event name as demo, and prefix and suffix, these are the optional, so we are not going with that. All object create events, so I just want to this in the put event. So whenever we will upload any file s3 object created put, so it will trigger this Lambda function. Correct. Then you can apply on other sections as well, but now I'm going with that option only. Lambda function, here you can select your demo function. Correct. Let's do the save changes, and your event notification setup is done. So here you see demo put, and whenever you will upload a file, this Lambda function should be executed. So let's get into the objects. We will try to upload one file over here, and let's click on the add files. Then we will get into the S3 demo. We will apply we will upload this text demo.txt. Let's click on that, do the upload. Once we have done that upload, this Lambda function should get triggered. Let's see that. Let's get into the monitor section. Click on the view CloudWatch logs, and one log stream should be generated over here. We will see whether it has resulted into that or not. And one more thing before that, so if you see in the configuration, this role that we forgot, this role should have permission to connect with our S3 bucket. Correct. Because we created this Lambda function with the basic permissions only, where it had the access of your Lambda function only. It does not have any access to the S3 bucket. Correct, as you can see. So what we will have to do, we will have to attach policy here. So let me attach the S3 full access policy as well here. So let me attach this S3 full access, add permission, and let's see whether a log stream has been generated or not. Yes, one log stream was generated, but it should result into error. Hello from S3, as you can see the print message. This is the part of our code. So if I get into the code here, you will see that. Correct. Let me just scroll up. You will see the custom message print hello from S3. What has happened over here, it has gone for the records. It went into the S3 service. It fetched the bucket name, it fetched the object name, then it had to parse the content, and it had to reflect all those things. So what happened over here, let's do this. Error correlates with the change in the runtime version. You may be able to mitigate this error by temporarily rolling back to the previous runtime version. Correct. What is printed over here? Hello from S3. Then bucket name, text plus demo.txt. This is the file name. I think due to the space, it has resulted into the plus sign. And then if you talk about the content, which is the part of your text demo.txt, that is not printed yet. So what we will do, let's get into the this folder, and we will try to rename it. So let me try renaming it, and I will just remove this space, text demo.txt. Now it is fine. Let's get into the AWS console here, and we will try to re-upload this file. So let's click on the close, and let me remove this. So what I will do, I will just delete this. Correct. Permanently delete objects, and object has been deleted. Now we will upload one another file. It's the same file but we wanted to print, but text demo.txt. This one we will upload now. Click on the upload, and it has been uploaded. Let's get into the CloudWatch logs, and here we will see the second log stream should be generated. Let's wait for that, or it should be there after this. Yes, so now you can see there's the same log stream has the new message. Correct. So if you expand it, you will see from here a start request ID. The first request ended up here, end request ID, then report request ID, and a start request ID. So the next process has started on this particular timestamp. on the same 12th March of 2025. The next request ID started. Then it has printed the custom message hello from S3. Then your bucket name man demo hyphen 11. If you see, this is the bucket name man demo hyphen 11. This is the bucket name. Then you will see the message text plus demo.txt. It's coming from your what we say, this the object name, the file name itself, correct, that is there. Then if you get into the more detail, so yeah, from here it is the request id. Okay, so that failed multiple times, so from here it can get started. Start request id, then hello from S3, then man demo hyphen 11, then text demo.txt. File name we changed, correct. Earlier you see it was coming as text plus demo, that was due to the space between that. So now it has started coming as text demo.txt, and then it has printed the response as well. So that was our code logic. After that bucket object, it has to print the response, then the data, then print data and the event, correct. So as you can see here, it has printed the response, then hello, this is S3 demo file, so that thing is printed over here. Then records it has printed, correct. So this is how you can create the event notification using the Lambda function and the S3 bucket. So what has happened over here, whenever you will upload a file into S3 bucket, a Lambda function will be triggered based on the some code logic what you have written. It will go through the operation. Either it can print the logs, it can do the some operations based on your logic, and the same trigger can be applied for the different kind of actions as well. As you see here, there are multiple options, correct. So we just did our things on the put object only, correct. So other than the put, you may want to keep this notification on for any kind of object removal. Whenever someone try to delete the files, on that this Lambda function will be triggered, and it may keep the backup of that file. It may do some modification, or it may just notify you. So any kind of actions, whatever you want to push, those kind of notification setup you can do. So this is the use case what we wanted to cover in this particular video, and in the next video we will be covering the other use cases as well. Auto start RDS with the help from Lambda, and auto stop RDS as well. When we say the auto start RDS and auto stop RDS, that means we are talking about operational things. So whenever there's a weekend, or whenever you are thinking of that your dev team or any other team, like other than the production, is not working in this particular time stamp. So just suppose that you are having a small company and you do have only 9 to 5 shift only, and your team is not working in the night. So you can stop all the non-production databases in the night, so that you can save the cost, correct. Ultimately you have to pay the cost, organization have to pay the cost. So for that you can use this operational process, the auto start RDS, auto stop RDS, correct. So this is what we wanted to talk, and in the next video we will be talking about these things as well. Till the time, thank you so much, and stay tuned with the channel. Let's subscribe to the channel as well. Thank you everyone. Welcome to day 33, and in this particular video we are going to talk about the AWS Lambda function usage, correct. So in this particular video, if you have watched day 32, there we had covered how to set up the S3 event notifications, correct. So this was our first use case, the first one, where we had created one S3 bucket, and we set up that whenever you upload any file into this S3 bucket, this Lambda function will be executed, and it will parse the content of that object, correct, that file, and it will show that content of the file as a logs, correct, in the CloudWatch logs. So this was our first use case, where you can upload any CSV file or any your Word file. Then you can trigger your Lambda function. Your Lambda function will parse the content of that file. It can be your resume as well, correct. You upload your resume that might be stored in organization within the S3 bucket. This resume can be passed through the Lambda function, and it will fetch for few terms out of the your resume, correct. And that term can be further utilized for whether you have your resume needs to be filtered out, or it does not need to be filtered out, correct. So that kind of first processing can be done through the S3 bucket and the Lambda function. In this particular video we are going to talk about the second use case, where we are going to cover how can we set up this Lambda function to automatically start the database and automatically stop the database, correct. Why this is useful? So what happens that if you are working in an organization on a real project, correct. So on the weekend, Saturday and Sunday, there might be a scenario that your team is not working, and not for the production one, but for the dev test and other environments other than the production one. Because for the production, the business should be up and running, correct? It will be up and running every time. But what about the developers? What about the other teams who are doing the POC kind of thing? They are not going to work on the Saturday and Sunday, correct? Most probably. So you can shut down your database for those 2 days and you can save the cost, correct? And this same thing can be applied on the weekdays as well, correct? Like just suppose that your organization, your team is working from Monday to Friday and they are not working in the night, correct? So then what you have to do, you have to stop the database after 9 p.m. up to 9 a.m. morning for the 12 hours, correct? For that time duration, you can save the cost if your team is not working at that particular time. So you will be doing this every time, correct? You will go to the AWS console, you will create your what do we say, you will create your lambda sorry, you will create your database, you will stop the database, you will start the database, and these things you will be doing every time, correct? But the thing is, we don't want that kind of pattern. We want that this thing should be automated. Every day, Monday to Friday, your Lambda function will execute and it will stop the database. Every Monday to Friday, your Lambda function will execute, it will start the database. Correct? So that kind of thing we want. So let's directly move to the AWS console, and we will be using the code and all the details from my GitHub repository where I have created the notes, as you can see. So here I do have the Lambda function code, auto stop RDS and the auto start RDS. So this one I am going to utilize. So before that, we will have to create one Lambda function, sorry, the two Lambda function and one database to start and stop. So let's move to the AWS console, and there we will create our Lambda function and the database. So here I'm on my EC2 EC2 console. So let me search for the RDS, and then we will create our Lambda function. Sorry, the database first, and then we will move to the Lambda function creation. Correct. Because this RDS creation itself will take a bit of time, so we will save our time to launch the Lambda function. So let's get into the create database, and what we will do here, we will just select our PostgreSQL, that will be our database engine, and the version we are going with the PostgreSQL 17.2, that's the latest one. Templates, either you can go with the dev test, you can go with the free tier and the production one. If you are not aware how to launch your database and what are all the configuration details, you can watch out the other videos which are available on the channel, correct? There I have explained in detail that what option is having what kind of meaning, correct? So there you can watch out, and even you can watch out the other available videos as well. There I have covered AWS EC2 instances in much details, like I have talked about the path-based routing, I have talked about the load balancers, I have talked about launch template, auto scaling groups, and elastic IP address, and other concepts as well, target groups, or the different policies which can be configured in your auto scaling groups. Then I have talked about the AWS VPC peering, transit gateway, your VPC endpoint setup, the NAT gateway, internet gateway, subnets, and all those other details I have talked about. I have also talked about the AWS S3 service, where I have talked about how can you host your static website, how can you enable S3 CORS, how can you set up the S3 event notification. I have also talked about AWS IAM role and policy. So now coming to this topic only, the AWS RDS and this Lambda function execution. Let's go through the creation of the RDS instance. So here I will be going with the production instance to make our RDS instance highly available. And in terms of availability and durability, we will be selecting this multi-AG instance deployment, not the cluster deployment, correct, for our use case. You can go with the single AG as well, but for high availability, I am going with the multi-AG template. Then a DB instance identifier, here you can pass any name, whatever you want. So I'm just passing as demo DB. That will be my DB instance identifier. Moving further, you will have to pass your username and the password. So username I will be passing as master for the username only. And then the password we will be storing in AWS Secret Manager, correct? Self-managed not. I'm going to store it in the Secret Manager. That's the one of AWS service. If you can see here, you will see the service itself here, AWS Secret Manager. Let's open up this one as well because it will be used furthermore moving forward. We will see the details from there. Encryption key, we are going with the default which is provided by the AWS itself, and even you can create your own KMS key and then you can utilize the same KMS key here. For that you can search for the KMS here and you will see the key management service. That's the another service of the AWS. Now here we will be using the different instance classes for launching our RDS instance. When we say the different instance, you understand it's just like that your EC2 instance. It's a kind of server where you will be launching your database, correct? So for that either you can go with the standard class or bustable class. So as per your usage, every instance class has their own associated cost. So let's go with the default one which is coming over here. It will be a bit costly, but let's go with this one only for the demo purpose. db.m7g.large, correct? Then storage, I'm selecting provision IOPS SSD, and for this allocated storage let's change the value, or let me select the different instance class, and here I'll be selecting as 20 GB, correct? So dbt3 micro, no, I'm going with that dbt4g dot large. This one I'm selecting, correct? And IOPS here I'll be selecting as JP2, correct? So now we can provide the 20 GB per storage. Just to save the cost, I'm trying to save the cost in the demo as well. So this is the configuration we are passing: dbt4g.large, general purpose SSD, and the allocated storage as 20 GB. And then additional storage configuration we don't want. So let me disable this, enable storage of scaling. Don't connect to EC2 instance, correct? EC2 compute resource. If you enable this, you will be having one EC2 instance from where you can run the AWS CLI commands, and you can directly manage this RDS instance, correct? So for demo purpose, we are much focused on the Lambda function, so I'm not going with that option here for now. VPC and the networking configuration, we can create the VPC, but in this particular demo we are going with the default VPC which is already available in the account itself. The subnets as well, will be selecting the same DB subnet group, which is the combination of all these three subnets which are the part of this VPC. Then publicly accessible, yes, I'm making it publicly accessible for my use case. You can if you are deploying it for the production one or for the real project, most probably you are going to keep your database private only, so you will be keeping here as a publicly accessible, no. Now I'm going with the yes only. Security group, the default one, and if let's see if there is any other options available. Let me go with the default and SG both, correct? So certificate authority RDSC, additional configuration 5432 is a port for PostgreSQL database. Password authentication, to log in into your database we need the password, so that password will be here created in the secret manager. That we will see why it will be part of secret manager, because here we had selected manage in AWS secret manager, credentials management, correct? That's why it will be populated within the secret manager itself. Moving forward, monitoring, uh, we are going with the insights standard, and let me here disable this performance, or let me enable this performance insights as well. You can see that how matrix and graph will come into the performance and so let's go with that as well. Enable enhanced monitoring, just disable this. I'm just going for the demo purpose, and this is our use case, so this one, that one we are talking about. So let's directly focus on launching the RDS instance itself rather than going on few more details. One more detail I just wanted to highlight over here: backup I don't want, enable auto minor version upgrade I don't want, maintenance window no preference, enable delete protection. Here I'm just disabling this. If you enable this delete protection, you will not be able to delete your RDS instance till the time you just modify this particular setting, correct? So I will be deleting it directly, so that's why I'm just going with this disable delete protection, correct? Now let's focus on creating database. Your database will be created within few minutes, so the time being it is being created. Let's go to the Lambda function service, and there we will be creating these two Lambda function which needs to be created: auto start and auto stop. So let's wait for till the time. Let's move to the Lambda function now. Lambda, And here meanwhile you can see, if you refresh, that one secret manager should be created over here, correct? You can see here one secret manager. You will not be able to see any value because it's being generated as of now, correct? So we will see it later on. Now focus on the lambda function, create a function, and here my function name will be auto stop RDS. That will be my lambda function name. The programming language I will be selecting as Python 3.9, and change default execution role. So let's get into the create a new role with basic lambda permission, correct? So I'm going with that, or let me select if there is any existing role. Okay, let's go with the create a new role with basic lambda permission, correct? Or you can create a role from AWS policy template, so you can select from here as well. So let's select as, what can we say, that auto start stop RDS role. That will be my role name, correct? And policy templates, let's select the which kind of access we want to grant. We want to grant RDS full access. Okay, it's not coming, so let me see if there is RDS. Okay, RDS is not there, so let's move from here, and we will create our role, and then we will attach the policy directly. Let's click on the create function. We are not going with the much details, and then we will move to the attaching policies to this particular role. Meanwhile, we will be creating another functions as well. So this is auto stop RDS, and then we will be creating one more function that we will call as your auto start RDS, correct? So let me open one more tab, and there I will be creating one more function, and this function will be called as auto, what was the first one, auto stop, correct? So it will be auto start RDS. The programming language, once again I will be selecting 3.9 and change default execution role. So here I can select the one which is now created, auto stop RDS role. I'll be selecting this one only, and the same role can be attached to the to any of the service, correct? So I'm just selecting this one only, service role auto stop RDS. Let's click on the create function, and your function will be created within few seconds. So here now let's change the code as well. So meanwhile probably your database is being created and modified, so let's upload the code over here as well. So here we do have the auto stop RDS lambda.py. So let's get into that, and let me copy the code from here. So let me copy the code. Okay, we can copy it from here, import boto 3. Anyway, let me just copy this completely. Let me do one thing, click on the edit. Oh sorry, even if it's my repository, but I've just forgot to log in. So let me do copy this in this way, and I can change the code over here. Let me do the control V, then for I in response, and after that I have to copy this particular part. So let me copy this part as well, Command C, and then let me change the code here for this one. Yeah, so it's fine, correct? What is there? Okay, let's save this code. So deploy the code, and what needs to be changed over here, let's see that as well. Nothing needs to be changed most of the time. So what we are going to do, we will be creating 3 environment variables over here. We are importing the boto 3, we are importing the JSON, the system, the date time import, and everything. We will be configuring 3 environments over here, correct? There will be mentioning the region, why it is required, because our logic will be performing working in the similar way. It will look for the where variable, it will look for the key variable, it will look for the value variable. So in these 3 value we are going to, in these 3 variable we are going to pass certain value. In where we are going to pass the region. In key we are going to pass the one tag value that will be called as auto start stop, and in the value we are going to pass the value as yes, correct? In the region name, here you will see the region name, and the value, this will be the value, correct, in the lambda function, and the same tag we will be creating in the our RDS instance as well. So let's create these 3 variables as well. So I'll be creating this where first. let me create this, and let's get into the configuration. Let's get into the environment variable, click on the add environment variable, and here you go with the first environment variable, then you go with your second environment variable, key, control C, and then you need to pass the value. So this will be our value. Here you need to pass your region. So the region, we do have this episode 1 only, so I'll be passing this episode 1. Why episode 1 is fixed? Because I'm creating the database in episode 1 only, episode 1, correct? So and then the tag value, auto start to stop. Let me copy this one as well, and then the value we need to type. Let's type here, yes, it's the simple one, correct? Let's click on the save, and your Lambda function is ready to be used. What is left over here? Let's attach the policy here as well. So let me open up this role, and this role should have the access to your RDS instance, correct? Then only it will be able to fetch the RDS instance, it will be able to relate with that. So for that I will have to attach the policy here, right? As of now it has the AWS Lambda basic execution role, so let me attach the policy for RDS as well. Let me search for the RDS, and RDS full access as of now I will be granting over here. So RDS full access it has. Let me attach the Lambda full execution as well, Lambda full access, add permissions. This auto stop RDS, this particular role has all the RDS and Lambda full access, correct? Now the same code we can pass in the AWS auto start RDS as well. So let me copy the things in for that as well, auto start RDS, and here I will have to again paste the code, command C, and then where is that, auto start up to Boto 3, and then auto start, yes. Then I need to pass this up to here, up to def. Let me pass command C. Then we will be passing the further code details over here, and after that I need to pass this one up to here, correct? Okay, so that's fine. Click on the deploy, and you are ready. And here also you will have to pass the environment variable, so let's pass the environment variable here as well, and the same environment variable we will need to pass over here as well. So where, and the value will be ap shout 1, then the key will be the same. Let's copy the key from here, auto start stop, where is that, yes, and the value will be yes. So that's the value we are keeping. Let's save this one as well. You have saved the things, you have the permissions, everything attached over here. Now we can work on this. So let's see whether this database is available as of now or not. So it's still getting modified, so let's wait for a few more times, and then we'll be working on this database, whether to start, whether to stop, and all those things we will see. Let me refresh from the browser itself, configuring enhanced monitoring, so it will take few more minutes, I think, most probably. So meanwhile let's understand the code here, how it is working. So let me open up this one which is highlighted here. We have imported few packages from for Boto 3 and all those things. Then let's focus on the function set RDS all, where os.environment where is having the value of the region episode 1, so it will get into this region, correct? This where will be having the value episode 1. Then key is having the tag auto start stop. Then the client Boto3.client RDS region name. So this, it will look for the RDS service in which region, in episode 1 region. So it will list down all the RDS instances which are available in the episode 1, that is in the Mumbai region, correct? it will describe all these DB instances. When we say the describe, that means it will list down all those things, the complete details of the DB instances. It will print that as a response. Then in the response, we will look for the DB instances one by one, 1, 2, 3, 4, 5, 6, and 7, so on. It will look for the ARN of all those DB instances, and it will print those, that list tags for resource, correct? So whatever the tag are associated with our RDS instances, it will look for the those tag as well, and it will list down all those tags. So what we will do, we will create one tag in our RDS instance with this value auto start stop, and the value in the tag will be yes, correct? This one you need to be focused, because our logic will work on these things only. So now if you see, if 0 equal to length of the tag list, so if your RDS instance does not have any tag, correct? If your database, this database does not have any tag, so let's create the tag as well here. So let's click on the manage tags, click on the add tag, and here we will be creating the tag as well. Auto start stop, command C, and here we go with the value. Yes, that will be our value. Yes. Let's click on the save changes. So what will happen here over here? So if you see the code logic, if the length of tag is 0, that means if there is no tag, it will become the 0. So this will print a custom message, DB instance is not associated with required tag, correct? And it will stop the functioning. If the length of tag is not 0, that means if the tags are available over there, if for tag in response to tag list, if the tag is available, it will go for this for loop. Then it will now start comparison, doing the comparison point, correct? If the key equal to key, this key is the part of your uh, what do we say, the tag, correct? So if the tag is having this key, and this key is equal to the value equal to key, this key is the one. Now I am highlighting this key. This blue key is coming from where? It is coming from this key, correct? You can see in the left side. And from where this key is having, the small key is having the value, this small key is having the value from the uppercase key, correct, the larger one. So this key is having the value from the lambda function. In the lambda function we had created this tag auto start stop. So now in the right side, this key is having the value auto start stop, and now your tag key, that means the RDS instance tag key, is also having the auto start or stop, correct? So this one, the line number 81 value in the left side, equals to the auto start stop, the value which is in the lambda function in the right side against the key value, correct? If this becomes equal, similarly for the value as well, if the value in the lambda function, here it's the value which is coming from the value, and this value in the lambda function is configured as yes. So if this yes becomes equal to the tag, the value which is in the tag of the RDS instance, this one, correct? If it becomes equal, then the next functioning will be happening, correct? So if value equal to value, that means yes equal to yes, then it will now look for the DB instances. If the DB instance status is available, it will call the function stop DB instance, and it will stop your database. If that is in stopped status already, it will say that it is already stopped. In the similar way, if it's in the starting state, it will say that your database is already in on stopping state. If it is not associated with any tag or something, it will say that this is not associated, correct? So this is how your lambda function is going to work. And from here in the lambda handler, we are calling this set rds all function. So here if you see, we have defined this set rds all, correct? So now you can see your database is available, correct? We need to stop this database. So there is one option, you can click on the stop temporarily, you can acknowledge, you can take the snapshot, and all those things you can do. But I don't want to do all these things manually. I want these things need to be done from the lambda function. What I will do, I will get into the code here. I can click on the test. I will create a test event over here, and create new test event, and here I will just say that nothing needs to be passed, just an empty value. And click on the save. Okay, here you need to pass as well. Click on the save, and then click on the invoke. Here if you see, sorry, execution started. and most probably let's see whether it has impacted the RDS instance or not. You can see your RDS instance is being stopped. The same log you can see over here as well. The this lambda function console is not working fine, but yeah, anyway, you can see status succeed, test event name, test event that we created, function logs, you can see. Yeah, now it is stable. Okay, so you can see the availability zone in which VPC we have defined all these things. You can see all the details. You can see the multi-AG, what kind of configuration we have passed. You can see the div instance ARN, DB demo DB, correct? All those details what we had passed. You can see the tag list. This tag list is from your RDS instance. You can see the tag list over here as well. So all these things are there, and it prints the message stopping DB instance demo DB. From where it is coming? It is coming from your code only. Here if you see, that was our custom message stopping DB instance and the ARN. So you see the same message over here, correct? Stopping DB instance demo DB, correct? So this is how you can create your lambda function. You can automate all these things to do your day-to-day task, and it will save your time as well. It will take a bit of time in stopping, and then we will see that how you even you can start your RDS instance using the same kind of lambda function, correct? The different lambda function what we have created here, auto start RDS. Here we have already created our environment variables, key, or oh, it will not work. You can see why it will not work. So let me just do the copy paste over here, otherwise we will go with the mistakes. So let me just copy this auto start stop, and you can see the error, correct? A is not there, so let me just paste it. Key is perfectly fine, key in the caps, where sorry, where needs to be in the caps, that is fine. Episode 1 and value, that is also fine. So let's click on the save. So your lambda function is ready to start the RDS instance as well. It has the permissions attached, the general configuration. You can see the timeout 0 minute 3 second, and one of the most best feature out of the lambda function, you can see that the moment it works, you have to pay for that particular moment only, correct? You are already aware when we are talking about the lambda function and all those other details. So the moment your lambda function works, you will be paying for that much time duration only. And here you can click on the view CloudWatch logs as well. So the all the things which are being done, all the activities which are being performed, that even you can see in the CloudWatch logs. Most probably this log streams should be generated. Let's see that. So it's going a bit slow, so let's click on this log stream, and here you will see this, it is printing hello Manish and all those things. If you expand this, you will see this particular custom message. This custom message is coming from here only. You will see the first message hello Manish, correct? So you will see the all those logs which are all these logs which are coming on the AWS console over here as well. So everything is coming here, correct? You can see all the activities are happening. So you can see you can check the CloudWatch logs as well. If anything fails over here, you can do the troubleshooting from here. You can check the logs, you can fix according to that. Then the secret manager we had talked, so let's refresh over here. Earlier it knows secret value set, correct? Now if you refresh, you will see one secret value should be there. This is the master username what we created, and the password is auto generated because we had made it as to be auto generated only. So your password is there, correct? It will take a bit of time to stop, and then we will focus on the start as well. Meanwhile, yes, we can cover one more thing here. So we were talking about the performance insights as well. So when we were configuring this, if you remember, in the configuration we had enabled this performance insight for the 7 days, correct? Retention period with the 7 days. What all things you can check in the performance insight? So let's click over here. For the DB instances, you will enable the performance insights. You will see all those DB instances listed over here. So let's select the div instance, demo DB. What are all the loads which are coming on your database, that you can check from here? Average active sessions, top weights, which kind of SQL queries are taking much time. So that kind of top weights you can see. Top SQL, which of the SQL query is taking a lot of time to get executed, correct? So that kind of SQL query you can check here. Top host, so out of the number of connections your database has, So how many number of connections are making, like how many number of maximum connections are there, top users out of the database users, which user is the having the high utilization of your databases, correct? Top sessions type, top application, top databases. So within this RDS instance you might create the multiple database as well, correct? So which database is being consumed mostly, so all those things you can check from here. Then you can check the matrix as well. When we say the matrix, all the CPU utilization which are happening, correct? All the free memory, free space, free your IO throughput, the networking part, the max time, idle time in transactions, the your what we can say, the sessions, how much how many number of sessions are being maintained, how much time duration it is utilizing. So all these things you can check from here. If there is any deadlock, so how many deadlocks are there, so all these things you can monitor from here. How many transactions are happening per second. So your performance insights gives you a lot of details about your database instance, and from there you can check out the complete details. You can work on that things, correct? So you can see all the things. You can change the graphs. And one more thing, we'll be talking about the snapshot. What is the usage of the snapshot? Snapshot you can use for the actual purpose of the snapshot is having the backup of your database, correct? So when we say the backup, that means just suppose that tomorrow something happened with your database and you are not having any backup, so you come up with the things that you have lost all the data, correct? But at the same time, if you are maintaining the snapshot, that means the backup of your database, you can recover the complete database from the previous. Like tomorrow something happened with your database and you have the snapshot available in your system for 2 days only, correct? So you can tomorrow you can recover your database with the snapshot which is available on today, correct? So you can recover the complete database. You can create your database from the scratch itself using that snapshot. You can share the snapshot with yourself within the system. You can share the snapshots across the different accounts as well, and that can help you to do the things accordingly, correct? So these snapshots will be available for that particular use case. Then one more feature of the RDS instance is parameter groups. So when we say the parameter groups, so if you get into the default, you will see there are two default parameters. If I click on the create parameter group, you may see that let me search if I find anything. Okay, so I will have to create one parameter group. So let me just click on the create parameter group, or rather than I can go with the default one. So let me go with the Postgres 17. Here just suppose that for this particular RDS instance you want to store the logs, correct? You want to store the logs, so you will have to set some of the parameters over here. So for that there is a parameter called as log retention period. Ideally it is for the 3 days. 1440 into 3, that becomes your 4320. That is your parameter where you can configure, and you can select this particular value, and accordingly you can change this as well. So it's modifiable, correct? So you can see that it's modifiable, and as this is the default one, so that's why it's not coming to do any modification. But if you create your own parameters, correct, so then you can change the value of this, correct? So RDS sorry, the log retention period, then you can search for search path where you can pass the schema of your database, correct? You can have your master or any particular schema if you want. So that schema you can pass over here, and that will help you to create your to set the value for this search path, correct? Similarly you can go with other options which are available over here as well. And let's wait for this one as well. It's still getting stopped. So the moment it will be stopped, we will execute this auto start lambda function as well. And I think it's taking much time, and the video might get longer, so I don't want to do the same thing again. But let's execute this lambda function. At least you can see the message which will come on this auto start, correct? So let's click on this what we say, the code. Let's create one test event over here as well. Let me click on the test, sorry, create new test event, and here I will have to pass the name test. Click on the save. Sorry, I need to pass this value as well. Click on the save. Oh, event already exists, so let me click on the invoke, and here probably you will see some of the message. What is the message? DB instance demo DB is in a stopping state, please wait before starting. So your database is already being stopped, so you will not be able to start this. So if it is just in a stopped state, most probably and for sure it is going to start, correct? You can see the message as well. So it has fetched all the details, and according to that it has printed that demo DB is already in stopping state, please wait before starting. And that is coming from your code itself only. You can see here auto start RDS. Here you will see the custom message, DB instance is already in starting, this one, please wait before starting, correct? This is the message which is printed, please wait before starting. So you can see the same. So for sure it is going to start your database as well. Okay, now if we execute, it will stop temporarily. You can see the status. Now let me invoke this once again. Let me close this and let's click on the invoke. Now it will start your database as well. DB started DB instance demo DB, and here you will see that DB instance should be starting. You can see the message, status message, correct? So this is how you can utilize your Lambda function to do the automation stuffs. You can create the Lambda function which will do the automatic execution of your the start and stop of the database. And to do the automatic execution based on certain timestamps, what you can do, you can create your triggers in the Lambda function that we have not talked about. We have not talked till now. So here you can select your event bridge. CloudWatch, not the event bridge we have to select, not this one. So where it is? CloudWatch logs, no. I need this event bridge. Why it is coming? Okay. Sorry, create a new role. So we can create over here the cron expression, correct? Here you can pass any rule, demo rule, description you want to pass, you can pass the description. Then here you can create your cron expression, as you can see from here, cron 17. Just let me just copy this. In the similar way you can create your cron expression, correct? This cron expression, this trigger will ensure that your Lambda function will be executed on that particular timestamp. So it will automatically start and stop, trigger your Lambda function on those particular timestamps, and the Lambda function will automatically start and stop the database, correct? So that event bridge will be there to execute this Lambda function, correct? So this is what we wanted to cover up in this video. I know it has been become a bit lengthy in this particular video to wait for this database to be stopped and being available to start again once again. So it has been a bit lengthy, but I hope you like this content, and stay tuned and subscribe to the channel to watch out more content. Till the time, thank you, bye bye.